So one of the objectives of having these kind of events is that, and talk to the booth guys, listen to all the great speakers we have, right? And pick up those keywords. You're not going to learn everything, right? But those keywords are the ones which you go back to your wherever you are and then try to dig in. What did he mean by modeling? What did he mean by topic modeling? Sarabjot spoke about so many things, right? So yeah, have fun. Don't forget to have fun. Enjoy. And I think, can you introduce our next speaker and let's get started. Yeah.
So, hello everyone. Welcome to the PyCon, PyDelhi Conference Day 2.
So after an amazing day yesterday, today we have a new set of talks and workshops. So today, for the first talk we have
Mr. Sachin Punyani ji. He is our keynote speaker. He will be speaking upon Python, a catalyst for builders. Sachin Punyani leads the business development for AI ML analytics for IoT for India and South Asia with AWS, and is helping AWS customers in modernizing their applications by integrating AI, ML, and IoT capabilities. So we welcome him with a huge round of applause.
Thanks everyone. Can you hear me? Yeah, thank you everyone. And a big thanks for joining very, very early morning on Sunday. So thanks and thank you. So I won't take much time, and thank you, sir, for having me here. Interacting with students is the most learning experience that we can have. So thank you very much for this experience. This is a PyCon, and I assume everyone knows Python, so I won't be teaching you Python. Probably you know much better than me. It's just a messaging that I'm going to pass, because when I say that Python a catalyst for builders, so 3 keywords, Python, PyCon, you all relate. So nothing new from my side to introduce, rather I'll learn from you what new is happening in that front. Second term is catalyst. Most of you come from the education background, so the word catalyst you all know. What precisely catalyst definition is. Means any compound or any event or any point that you add to increase the chemical reaction. That's the basic definition that I have. I come from a commerce background, so may not be able to give you a good science definition. I'm a BCom graduate, so. But catalyst word, I know that it is increasing a chemical reaction. It is making the action faster. Now, third point I'll just focus on, because that's where I'll start, and we'll try to connect the words. Builders. So I'll just start. So what exactly is a builder? What exactly does it mean to be a builder? Who is a builder, basically? Where I'll start. This is the definition that was given by CEO of Amazon. The builders are people who like to invent. I'll stay here, I think, otherwise, yeah. Builders are people who like to invent. I'll read out loud and then we'll explain. Who look at different customer experiences and try to figure out how to reinvent. Basically, if you are building an application, or I'll talk only in terms, the builder term actually applies to all industries, all streams, everywhere, but I'll be focusing more here on the software side, because we are right now on the Python. So whether you are building it for, say, a hardcore software product, or you are building something for a manufacturing unit, or you are building something for an automobile or aviation, wherever, effectively we are talking about giving some kind of technical background or technical base to them. So the context will remain completely on that. So I'll be focusing more on the technical application area in wherever I'm referring to. Now, builders are people who are beyond coders. We have all been talking in Python. If I say that, okay, do you know X library? Do you know Y library? Do you know X framework, Y framework? This is how application is done. This is how software is done. Builder is a bigger thinking. Now, I'll share. So I have removed the logos, but this is just a typical. Now if I have to ask something, I'll go to a Gen AI thing, so you know which two I am talking about here. So this is the difference between coder and a builder. Coder precisely is focusing on what the code is, what the requirements are, not going beyond. Now, the industry is changing, you're all maturing, industry is maturing. Builders are beyond coders. The code that you're writing, why exactly you're writing, or rather I'll say that how you are bringing those pieces together. It's not about that, okay, what this particular module is doing or what this particular software is doing. It's all about how effectively it is going to solve someone else's problem, how multiple things are coming together. That's a mindset change. You all know Python extremely well. You might be knowing many more languages extremely well, but are you able to put these things together which actually solve someone's problem? That's the major motivation, that's the major thought I want to pass out, and why and other things I'll cover up. I won't be talking too much on the Python technology details, but the messaging that I want to pass out. So this is, now why are we suddenly talking about like coder versus builder and all those things? This is the motivation. Now, as we say that things are changing, industry has always been service dominant, IT services dominant. But if you see recent past, as I say, in the last 5, 7 years, 10 years, I'll share few things and that you will observe. It's difficult to observe in first 1, 2 years, but when 5, 7 years pass by, you observe that yes, something actually has changed. So this is the NASSCOM report, just a snapshot, source is also there. If you see, in 1990s, can you see or should I, because the font is a little small, so I'll just share that this particular area, so this is the time span, 1990s, 2002 to 12, then 13 to 18, and then from 19 onwards. Now this graph, basically how many product companies do we have? We always said that we are service centric. So it is very clearly evident we are service centric here, we were service centric here, but as this decade, last decade started, it's starting to take off, and this is the stage. I remember when I graduated, if someone asked me that which product, software product comes out of India, I had to think. I mean, do we really have one, or if we have one, which one is that? That was like a general knowledge question. Now, NASSCOM report says 2000 plus. I mean, this report actually came 2022, so by that, I mean, now in last 1 year, you would have added maybe 500 plus more. So idea is like how the shift is happening. Now when we say services or building or maintaining or changing someone else's code, we are given the requirement, write the code. Now we are talking about products, we are talking about how to solve someone else's problem. Where do you bring how to improve that customer experience? That's the main focus we are talking about. Second data point, this is from the Startup India. So first one was like, okay, whether you're part of an enterprise, large enterprise, small enterprise, startup, this is what has changed. In 2016, Startup India had, so there may be many more, but this is the Startup India data. There were 442 startups that were recognized by Startup India. In 2023, by May 2023, there were close to 1 lakh. Can you see 225x thing? Change of mindset in last 5 to 7 years. Second is, where are these startups coming from? We know that Gurgaon is there, Noida is there, Bangalore is there, Mumbai, some mega metropolitan cities. This is another data, like in 2016, only 120 districts of India had some startups, one or more startups registered, primarily cities, tier 1 cities. Now in 2023, 663. That means this is spreading across. So point again coming back, this is the motivation, that mindset from coder to builder must come, because whether you are starting up by your own, whether you are working for any other organization, they are expecting this mindset change from you. Now one more case, this is the industry data, this is highlighted in 2019, government itself, this is from the Ministry of Information Technology website, URL is there. They introduced a national policy on software products. So point is, this is the push from the government. So industry mindset again changing towards products. And when the NASSCOM report has come out in 2023, you understand that they would be given some mandate by some authority, some influential body, that please share with us what the software product report is. And that's why NASSCOM also came up for that report. So idea is, this is the shift. Now this shift is happening, or rather I'll say has happened. Now how do we be the part of that? How do we bring our change? And now if we introduce, now I'm moving towards that, the major topic that we said, catalyst for builders. Now we are saying that we are in the builder mindset. Maybe when you are studying, many of you might be from the computer science background, reading like software development life cycle and all those things. They are still applicable. Agile or whatever format or whatever model you use, they are still applicable. But when we say builder, that means you might be introducing new products, you might be introducing new features, you might be doing lots of experiment. If you have a product today, just taking the example of this Gen AI thing, everyone knows we took the example of Gen AI, generative AI, and those who are following that, you know that GPT hype came up last year, December, this year, January. We are in August right now. Then came the, I'm using now some technical jargons here, FLAN model. Then in a couple of months came the Falcon model. Now I was talking to someone that the Llama model is there. Nobody's talking about FLAN model. So every 2 months, 3 months, you're seeing a change. That means for you, this time becomes too critical to bring something new out. Now coming back to this, again, bringing the point, change of mindset. When you know that time is critical, you have to bring some things fast. What is the approach? The agile one is very good when you are at this area where your product actually has stabilized. But if you want to bring new feature, you want to do test, you want to do some kind of POC. So typical words you will hear are MVP, minimum viable product that you can bring up without less number of features, without many features. POV, point of view, people use the word. POC, proof of concept. All these things you have to do very, very fast, and time is of essence. You compromise, or I should not use word compromise, you actually choose what is important. And this is the point that was given by LinkedIn CEO once, that if you have not, if you are not embarrassed by your first version, that means you have not shipped, you have shipped basically too late. So you thought too much, you took enough time, somebody has released, somebody has gained the mind share. So now the race for MVP is that how fast can you go. Now I'm coming back to the topic catalyst, that how that reaction goes faster. Now this is how typical MVP evolution happens. See, when I'm saying Python is a catalyst, that means it is helping you build faster. Why? Is it the right choice for any application? I'm not commenting, because it might happen that later on the run you say that no, XYZ language for XYZ module is better. That's the call you will take in the later steps. Here we are talking about how to bring your first thing faster. That's the main focus. I'm giving some idea. This is the base thing that you will do. You will get the idea, basic idea what you want to achieve, maybe a smaller scope. You would want to achieve some kind of research, some patterns, best practices, whatever you want to implement typically in this world. And then finally, whatever you are able to implement very fast here, you deploy that as fast as possible. These 3 steps, we are not going in too detail of analysis, requirement analysis, requirement gathering, all those stuff, then designing, architecting, all those things. People try to defer during the MVP phase. Second, this is a time where you need full stack development, the keyword basically. When the product goes very big, you know that it's a huge product, multiple modules, different teams maintaining it, typical feature change request, feature addition, maintenance, whatever term you use. Then you know that you will have some specialized people for different modules, different things. But when you are bringing an MVP, you will see full stack developer term, the term that came. You need a person who can do that faster. You are being taught, or everyone is being taught for best practices, but how MVPs are done. Because I'm from AWS, so I'll take some AWS example. It is applicable everywhere. It is typically you want your user to access something, and if I say EC2, EC2 is a service that is giving you virtual machine. We all say that you should have a microservices based architecture, decoupling, all those keywords, but this is how typical MVP is. You have one server, everything in that, no decoupling. This is how. Why? Because if you start investing initially on all those, your software must follow those best practices to scale. But if you are taking that time, thinking all those things, are you able to launch there? And if you see, in that chart we said that MVP, and then you say product market fit. For all the products, whatever we are thinking, or the development team or the requirement team, leadership team, they are thinking of the features. It's very common that what you will be, when it goes to consumer, you will have to change. Consumer might react on some things very positively, on some things like he would want a change. So that is what is called product market fit. You have to do very fast change. Once that product market fit you achieve, only then you can get, okay, now I'll plan to scale, because now I know. So you will be planning for a smaller audience, smaller customer base, and then you scale. That's a typical model that we saw. So this is how it starts. This is your first MVP coming out. You start like this. Then you say that, okay, now I know I've done something. In the next phase, let me try to scale. I'm again using some AWS keywords or AWS service names here, that some storage, some database you will try to bring in. Let us decouple something, those best practices. And then you say that, okay, now I know, now let me plan for scaling. So typical idea, if you see, the step one was on a single box. This is how people have been doing. Maybe you have a mature team, you are working for an enterprise team, so you may not start with a single server, 3, 4, 5 or some base things. But idea is like you start with very minimum requirement. Now, this is where the challenge arises. If you see, now you need a full stack developer, because you can't have one person, I mean, a team dedicated for front end, team dedicated for back end, team dedicated for DB, or all those things. So if you see, I mean, this has been, I mean, I'm sorry I forgot to mention the source here, but the report that suggests, if you see, top 4 challenges have working with multiple technologies as a challenge, and the bigger challenge or the other challenges must know multiple programming languages. Now, this is where now we come back to our title, Python. Do you really want to start with 4, 5 things? Okay, let me start with one language for front end, one language for back end, one language for some other module, because you are not focusing on your MVP. You are now stuck in your IT cycle. So how to work on that? So that is where we say that best idea is choose one language. Now that one language, it can be Python, or rather I personally prefer Python, because I know the catalyst part, as I say. So if you see, I just try to categorize some kind of workloads here. So if you see, workloads, I say, means different people might be trying to build different workloads. You may build a web application, you may build something for mobile app, you may build something for testing. So if you see different types of lists, it may not be exhaustive, but just try to collate. Whether you are building product containing one thing, or you are building product containing maybe multiple things. And typical solution is like, okay, you started with a web application, then an application might grow, say, I want to make it machine learning enabled, I want to make it AI enabled. Then again, you go to some kind of other features. I want to create a business intelligence thing for my end users, for my management, wherever. So it might happen that whatever you are trying to build may involve multiple types of workload. You may be building a game, you may be building an IoT thing, or you may be building an embedded solution, or maybe even if you take the example, when you're talking about, say, an IoT thing, embedded thing, you might want to give a dashboard also. You might want to give some kind of machine learning enablement also. So it might happen things are like you choose multiple things out of that. Now, why Python as a catalyst? Python has got thousands of libraries, we know, but I just try to map and share. See, just took the latest one that people are using. Every category has got 4, 5 libraries, frameworks, and this is not an exhaustive list. It has got thousands and thousands, so I cannot, maybe you say that, okay, what you have chosen is now outdated or we don't use, but effectively there may be one or the other. Now 3 things, it is either the library, or the framework, or the SDK, or maybe you can say that there are things which Python does not do. There might be things which there are products, or there are solutions. Just taking an example, you are trying to glue 2 services, 2 modules together. Whatever tool you use, it would have got Python interface. So my point, very first problem solved here is that you have, so first problem when we said that multiple programming languages, for your MVP, this is just an indication that you solved that challenge of not learning multiple languages for your MVP. So it started there. Now, this is, and multiple technologies, as we say, that problem I'll just take on next. Any doubt or question so far?
I had a question.
No, so I said that, see, it depends on your timeline. I'm not saying, so my only point is, if you have very less time, if someone tells you, and you do not have enough skill, so I'm not saying that you go only for Python, I'm saying it's a catalyst. Wherever you know that I will have to learn something new, you already know Python and you already have. So effectively, idea is to bring something to user faster. Test it, and then, like we said, change it as you go along, maybe for the product market fix or for the scaling.
But eventually, when you have to scale it, you have to look at a native application.
So again, I say it depends on the timeline that you have. If you say that my first product I am going to take 8 months or 9 months or a year to bring out, you are lost. You have already lost the battle. Idea is that somebody else has already captured the mind share of the audience. Only thing is, see, that's what I said, I'm not saying that Python is the right choice for all your stacks. Idea is that how to bring your MVP faster. I'm going to that builder mindset. Next point, multiple language problem is solved. Next is catalyst effect on cloud. We know that Python. Now the challenge might come, okay, so many libraries, who will learn that? I am coming from AWS, so we'll use AWS example here. Effectively, when we said that you will be building those things, you will be deploying it on AWS, for example, so that you can change later on. That problem, this is how it is solved. So we know that we were at this stage, we thought that, okay, we can choose these things. Again, depending on your choice, you might have to choose one of these or many more Python libraries. But how do you even reduce this effect, this bulky effect? So here we add, so if you see, if you're deploying on AWS, for all of these types of applications, there is one or the other AWS service. Again, AWS has got large number of services, some more mappings might be there, I mean slides cannot take, but very important thing, if you see, first of all, your deployment is on a single platform. Second, if you see here, one word called Boto3, across. Now I don't say that Boto3 will meet all the expectations here, but many of the libraries that you choose here, Boto3 itself will cover. That means one single thing and your application is done. And you can augment it wherever required. Maybe you are doing some automation, you are doing some machine learning, you are doing some UI stuff. So overall messaging that I was saying is, it's no longer the coder version, it's the builder version. Second, depends which segment of the product life cycle or which phase of the product life cycle are you in. If you are already, if your organization has already achieved that product market fit, they are into scale, then you know whatever you have been following. But if you are in the early stage, and why I am focusing on the early stage, because now, like we just saw how the startup curve has taken shape and the expectation going further with the boost. Now if you go on the Startup India website, you will see almost every year they are planning, not every year, rather multiple times in a year they are planning for one or the other hackathon or challenge, startup hackathon, whatever way, to promote. So effectively it might happen one way or the other, either you are starting up by your own, you are engaged with someone, or maybe if you are with an enterprise, they are trying something new. The Gen AI thing, again taking an example, almost all the products that you saw were doing really good, but suddenly everyone in the organization started thinking like, okay, how to bring that Gen AI enablement. Typical example I gave, that everyone, I mean from my experience, when we talk to different organizations, different customers who already have a stable, well accepted product, they said that my simple problem is my customers should get the answers very quickly. ChatGPT gives it very fast, I mean summary. So can I give that summary on a chatbot or on a voice bot to my customer? Personalized summary. Just take example, and EdTech is saying that, okay, my students are asking different questions and I have a teachers at the back. Can those questions be answered by that bot and only relevant questions go to teacher? Now, answering these questions relevant to that subject topic depends too much on what that organization is teaching. I'm not taking the name of the organization here, but there is organization which is catering to up till K-12, giving the online content. But then there is another organization which is catering to the working professionals, giving enhanced learning or add-on learning. Now, expectation, answer to those questions differ and is based on their content. ChatGPT kind of model will not serve because that's a general model. Now that organization immediately wants that how to bring this feature. If you say that I am thinking and then people are accepting it or the user experience is good or not. The first point they want is we'll think of this scale, let's launch as a pilot for say 100 students. So I'm giving you an example, this is the typical scenario. That's why I'm just trying to bring this focus on. So that was overall Python as a catalyst message. If you, why again, Python is very close to my heart because it's my first language when I start thinking of doing a POC. Most likely if I'm doing a POC or my team is doing a POC, 99% it will be in a Python, it will be in Python. And we have been able to do that successfully so far. So that's the message. I'm showing deliberately global list of companies that have tried to build. The slide is like, space is small, so that's why I brought global. I can share huge number of Indian companies. You guys can relate very well to the education, so all the names that large names that you hear, we have all, we have worked with them in building those new features, building their solutions up. So that's the overall messaging that I wanted to pass. Now over to you for Q&A. Any questions? Thank you. Thank you.
Well, we would like to thank Sachin sir for his insightful speech. I would like to call upon Gora sir for presenting a moment of appreciation. Let's have a clap, everyone. I would also like to call upon Seema ma'am for presenting a memento. Let's have a clap. Post this keynote, I would like to extend my gratitude to Sachin sir. Now we will begin with a half-hour networking session where you will be guys meeting with each other and networking and connecting your businesses. Thank you.
Everyone, please. As you know, the next talk will be starting at 10:30, and since all of our attendees are right here, we would like to do an impromptu lightning talk session. So if any one of you have any topic you would like to talk about with everyone, we can have a 10-minute slot for your talk, and if 5? Okay, you can do 5 minutes, and if you would like to do lightning talk right now, please come to the stage.
Also, for the post lightning talk sessions, the registration for the same will be happening beside the registration desk. So please be there.
एक second, you want to check.
Nikhil is the next speaker. He wants to check his. He wants to.
So that announcement was for, we will also have a lightning talk session after the lunch break. So if you want your lightning talk, if you want to prepare, you need some time, and you still want to give your lightning talk after lunch, you can put your lightning talk on a sticky note on that board near the registration desk. But if you want to do it right now, please come near the stage.
Nidin. He just wants to check. He's the next regular speaker.
So, who did we have as lightning talk speakers? Okay, the first lightning talk is by Nikhil. What's your topic? Simpai. Symbolic computing. तुमने कल submit किया था. You submitted one, yes. Do you need computer?
How do I explain that? I have to show the document.
You want to do one? Okay, so while we are waiting for people to muster up the courage and propose a lightning talk, the mic will be circulated among the audience, and you have to come up with one thing that you like about Python and one thing you don't. All right? Let's pass the mic around. Who wants to go first? One thing you like about Python, one thing you don't.
Hello, good morning all of you. I'm Ravi from Keshav College. I'm teaching BSc Honours Computer Science. And at present I have not taught Python to our students. But other teachers are teaching Python. I have some information about Python. And I like Python because Python is easy to learn. And I have explored many things in Python. There are various packages available, and for different use we are using different packages. That I like about Python. And I do not like is there are many packages. There is a long list of packages. So I think in the starting it is very confusing for the students to explore all those packages. Okay, thank you.
Hello everyone, my name is Dishant, and the thing I like about Python is it's feeding my bank. It's feeding my bank balance. And it's also easy. And one thing which I don't like about Python is I feel it's a little slow, because I've tried a couple of more languages as well, and now I feel like it's a little slow. So, yeah.
Hello everyone, I'm Akshit, and the thing I like most about Python is just how extensible it is, and we have so many fields where we can use it. And what I don't like about Python is that it isn't perfect, as in every field has a language specializing in it. For example, Go is very good for concurrency, and there are other frameworks which are good for Android and for game development. But I guess that is expecting too much, since Python does an awesome job of excelling at breadth as well as some depth. So yeah, that'll be for me.
Lightning talks are available now. The first one is by Nikhil on Simpai. Good.
So, hi everyone. I would like to talk about how you can do symbolic mathematics in Python. So I'm a very big mathematics fan. I love maths and I love Python along with C++ and Fortran because I can do maths very well in Python. The whole NumFocus ecosystem, NumPy, SciPy, Matplotlib, all of that you can do for data visualization and Python. And mathematics especially. So this is our library, SymPy. This is also a part of the NumFocus ecosystem along with NumPy, SciPy and all of that stuff. So this is primarily for doing mathematics with symbols. So like if you need to solve equations, you need to do differential equations, differentiation, integration, any higher level mathematics stuff, and you'd like to use Python for it, you can use SymPy. You can go to our you can go to our website, sympy.org, and you can also find the documentation link on the website itself. We have introductions, tutorials, how-to guides. If you are new to Python, if you are new to how to do maths in Python, all of that you can read here. And if you find anything missing in the documentation, if you find the library hard to use, please let us know. Please open an issue that you would like us to improve the documentation. We always love feedbacks. And so this is our GitHub repository. So you can just go to github.com/sympy/sympy. And we have a lot of modules available from mathematics. So you can contribute to use SymPy for any of the areas you would like to do maths in. So we have different kind of assumptions. So some of them are our internal usage. So like CodeGen is for generating C, Fortran or some other code using SymPy. But if you would like to use, so we also have a lot of physics topics, control systems, geometry, integrals, all of that stuff. So if you would like to do maths in Python, please use SymPy. Thank you. So our next lightning talk will be a Swastik, and he'll be talking about VLang. So please, Swastik. Please, can we have a round of applause for Swastik?
Hey everyone, I'm going to give a lightning talk on V programming language. V programming language is inspired from Go programming language because of its syntax and semantics. I'm the developer for the language for like 4 years. Okay. So what are the main features of V? There's no bond checking, no undefined variables, no variable shadow, immutable variables by default, immutable structures, and there is also obsolete result type returning, like how it's in Rust. We have some types, like in Kotlin, and generic syntax. We also have immutable function arguments by default. And there's no null inside V, except for C interpolation, which is needed for writing C code. Performance. And now you can easily build V. This is a GitHub repo. Okay. You can just clone the repo. CD to the directory of V which has been git cloned, then you have to run the make command. If you are on Linux, you will have to use the make.bat. that bat file which is used to build on Windows. As you can see, as V is building, you will be able to install V very easily. It comes with an inbuilt C compiler known as TCC, which is the smallest compiler ever known right now. Now, you can run V like this. Here's a V REPL which has been used. Hello world. As you can see, that REPL has given it an output hello world. Okay. There are more examples. You can use this to fetch time from the given website. We are using a HTTPS package for this. We also support JSON encoding and decoding as it's one of the most default features of the language. Okay. So what I have worked on this language so far, I have implemented operator overloading, generic syntax, thousands of bug fixes in check and parser stage. I have done around 237 PRs. 2 are open, which I am currently working on the issues. And okay. I am also the 11th contributor of the language. As you can see, the 11th one by commit, not by the amounts of file. So I think I may have done around 5,000 changes or something. And now I am going to show you what I have implemented into language, major implementation. Time. Okay. Sit. The syntax highlighting, as you can see, has been implemented by me. You can also grep it, but we don't have time, so I will show you the other example. Constant is, as you can see, is implemented by me, and let's see how I will run it. Okay. As you can see that I have also implemented constant range, and I have also implemented operator overloading. This is a simple example of operator overloading, as you can see, which has also been implemented by me. You have to define the operations for the same, and it will also auto-detect the equal to plus or equal to operators. Okay. Okay. Yeah, that's all. We are out of time. I wanted to elaborate more. Yeah. Very sorry, Arvind. Okay. Oh yeah. Wait a sec. I am giving.
The next talk is by Advik on HTTP in 5 minutes.
So, hello everyone, can I have your undivided attention for the next 5 minutes? Because I want to talk about the most fundamental thing that is to the our internet as we know it. It is the hypertext transfer protocol, which is also known as HTTP. It is a very simple web protocol built on top of TCP, and it is what powers most of the web. It was conceived about 30 years ago. So 3 decades, and it has been working till now. There has been a few major changes into the protocol, but they have not been very much received, I would say. So the one that I will, the one that I want to talk about the most, that is Okay, let's start. So how to make a request? So as you can see, the slides that I'm showing you are loaded from my website. So that means if I hit Control R or refresh, then I make a HTTP request. That means I'm requesting some data from the server. But we want to see how this works under the hood. Okay, so for that we will use a CLI application which is called curl. Raise your hands if you have heard about curl. Okay, plenty of people. So this is a simple command. We just type curl and then then the website that we want to request. Okay, so when we do that, this is what happens. This is the request. This is the data that the server receives. So I hope the text is visible because I cannot zoom it, sorry. So the first thing that you see here, there are HTTP verbs, which are different ways to talk to the server. There is I want to get some data. There is I want to send some data. These are two most fundamental things that there are, and most common also. So sending some data, requesting some data from the server is called GET request, and sending some data is called POST request. So here we are making a GET request. Then there is a slash. Slash means we want the home page. So as you can see, the URL, if you want to read the slides later, it is http://slides.advik.1. So, and then the third thing, which is this http/2. This means we are using the second version of the HTTP protocol. And then we have some couple other information. There is the host, which means what website are we requesting, which is this google.com, and this user agent. This means who is requesting the website. So here curl is requesting. If we are using the Chrome, then it will read here Chrome, and that's for the request. Now let's come to the methods. I've already talked about those. So these are the other methods. There's get, post, put, patch, delete. I don't have enough time to explain it, sorry. So let's talk to the let's come to the HTTP versions. There are, I would say, 3 major versions, which is HTTP 1.1, HTTP 2, and HTTP 3. What is the difference? HTTP 1.1, which is the most common one, let's say it's just a very simple protocol. The thing that it improved upon HTTP 1.0 is persistent connections. When we used HTTP 1.0, we had to reconnect, but now we don't. Then for HTTP 2, we can send multiple requests in just one connection. So we make one TCP connection, and then we can send like 200 requests. So it reduces the overhead. Then we have the HTTP 3, which removes the TCP protocol completely, and it builds on top of Quick protocol, which is itself built on top of UDP. Let's come to the HTTP headers. So these are different headers. This is the metadata that we send to the browser. This is host, user agent, accept, date, server. Okay, I'm sorry, this is the data that the server has sent. That is why you can see here the server is Nginx. And this was the response that we got from Google when we requested it. There is now you can see there is HTTP/2, which means which version we are requesting and which version we are using. And then there is 200, which is the status code. 200 means success, 404 means page not found, but this was found. So yeah, I guess that's it. So we can do a lot of things. One of them is writing our own HTTP server on top of the TCP protocol, but maybe that's for another time. Thank you.
So the next lightning talk is by Rajarshi on logging in Python. You've got 5 minutes.
Hello, hello. Hello everyone, I am Rajoshi. So let me quickly go to the topic. I'll be talking about logging in Python. We all know
Accessibility shortcuts.
सॉरी वाईफाई का पासवर्ड में माय केवल मेरा हॉटस्पॉट चलेगा.
Okay, before while the technical issues are being resolved, I'd like to just take 2 minutes to request everyone to visit PyDelhi.org and join one of our communication channels. If you would like to volunteer and help us organize meetups, that would be very, very helpful. It's a non-profit and a community-owned entity, so no one really has an ownership right of it. All of us own it equally. The platform is as much as yours as it is mine, so PyDelhi.org. Thank you.
Hello everyone. Sorry for the delay. So I'll be starting. logging in Python, we all know about logging messages, printing using print or the inbuilt logger module. We know it is important, but in actual scenarios for production applications, it is even more important to make sense of the data, how to use that log for our benefit. Sorry, it is delaying a bit. Yeah, so standard Python log looks like this as a single line with multiple information which you can provide. What we can do, we can simply transform the log message from plain text to a JSON document. We can use custom formatting, or we can use inbuilt package like Python JSON loggers. What it does, we can write our log messages like this, like adding the receiver API or status kind of dictionary keys. And in our output, in a JSON format, we can get all those information. If you look at another example, here I am passing file type and the row count and the error type in the JSON output. So we get a formatted JSON with all these informations. Now about using that log message, because it is JSON format, so there are many options to process this JSON data like Elasticsearch, MongoDB, AWS, DocumentDB, and many more. Once it is in a document database, we can do JSON query, or we can use inbuilt solution or custom solution like Datadog or Kibana for visualization. What it does, it opens up a lot of possibility to do data analysis on our application programs, and also visualization. The questions we can try to solve is, what is the time series distribution of the traffic in multiple API services we are using? Which API have the highest rate of failures? Or also, like say, after a major code rewrite, is there any significant performance improvement of our API response time? All this information we can get, or we can develop that dashboard or visualization or query just by translating our default logs to a JSON format. Last, I will end with showing some sample dashboard. Like here, we have managed to create a dashboard in Kibana tool. Here we can see that job count or an API output count and its time series distribution across 5 days. Here, just looking at it, we can say that at a particular day of time or a particular day, we have had number of API calls. Another example, like if we want to track the success and failure of APIs, we can see a percentage chart across all the days. Here you can say that Monday have the highest number of percentage of success, whereas Saturday have the least success. I will end with saying that whoever are using logging in their production applications, I would ask to use JSON logging instead, so we can have easily available analysis and data visualization on your existing application. Thank you.
Disconnect your laptop.
Now we will continue with the speaker sessions. Next up we have Abdeli Kothari. He is an experienced developer and product manager with a good grasp on the financial services industry. skilled in Python, big data, and machine learning, and IIT Madras alumni. He is the kind of guy who would spend hours into minute tasks just for it to automate. A GSOC contributor for 2 organizations, Genome and Wikipedia. So let's have a huge round of applause for him.
Hey guys, let me just try connecting and see if it works out. Can you guys hear me clearly? Too loud, too low? It's good. Closer? Okay. Is this good? Can everyone? Can you guys in the last rows hear me? Just raise your hand if you can. Okay, perfect. Done. All right, so today we're. Sorry. I'll speak louder. All right, so let's get started. Is this fine? Yeah, awesome. So today I'm going to be talking about JIT compilers and how that kind of fits into the Python ecosystem. And again, this is going to be a little more interactive, I guess, just because JIT compilers is like super heavy. And if I go into the theory, you guys are going to all sleep. So I don't really want to do that. So as and when you have questions, like if I'm going too fast, just let me know. If I'm going too slow and that's also boring you, just let me know. All right, guys? Yeah? Okay. So quick show of hands, like how many of you know what is JIT? 1, 2, 3, 4, 5, 6. Okay, yeah, more. All right, a few people. How many of you know what are interpreters? A lot more. How many of you all have done like an official computer science course to understand all this stuff? I know there are more people because I did meet them in coffee. Yes. All right, so I mean the main thought process of this talk is to give you some quick background. I did physics, all right, in college, and I kind of started doing computer science and technology during the course of my work time, and I've learned a lot of these concepts over time. So I'm going to start talking a little about the theory behind interpreters, compilers, JIT compilers, and stuff like that, and then we'll go a little more into like the real life coding, where we can see how it works in action, right? So a few questions again, just to get started with. What in your mind is a programming language? Seems very basic, but how would you exactly define a programming language? Anyone?
If anyone wants to answer, just please raise your hand. I'll bring the mic to them. Anyone?
It's a way to write instructions so the computer follows what you want to do.
Okay, so a way to write instructions. Anyone else?
It is a way to connect with computer. Like we speak in Hindi, that is a way how we talk with the machine.
So way to talk to machines. Okay. Anyone else from that side? Anyone? What is a programming language in your mind? Or why is English not a programming, or is English a programming language?
It should be unambiguous.
It should be, the language should be unambiguous? Yes. Okay. I thought you were saying my question was too ambiguous. Okay.
No.
Got it. All right. I mean, good answers in general. I mean, the main thought process of a programming language is essentially a language or a notation to start writing programs. And why do we write programs? I mean, you can even program a person, by the way. Like if you go and instruct someone to do something, you're technically telling that person what to do. But mainly we're all talking about computers here. So we're talking about how to instruct a computer. But still, okay, like let's say if I have a code like this, right? If name is none, print hello stranger. How much of this does the programming language actually control? Like for example, does it say that the way that if is none, all these keywords that I've used, the combination of that means something, right? Like if I go and like jumble my words in English, it obviously doesn't mean anything. So a programming language definitely starts talking about how the structure, what is the structure you need to write your logic in. What about stuff like, over here we have a string, right? Like hello stranger. How to allocate this in RAM or how to save it in memory? Does a programming language actually tell us how to save things in memory? Or what about like where should it be printed? Because you're just saying print. What is the default place it should print? What are your thoughts on all these? Like, does a programming language, like does the Python programming language give us an answer to all these three?
we are not actually doing anything. The programming, the compiler does it itself.
That's true. I mean, the compiler is definitely handling a lot of stuff. But the question is, like, let's say if I go and tell somebody else who's never heard of Python, right, like in Pluto, somebody who stays in Pluto, and I go and tell them, like, hey, make Python again from scratch. Will the answers to all these questions be the same? Because they're trying to implement Python. I can see a lot of like different people, like some nodding yes, some nodding no. The general answer is that a language doesn't really, well, depends on the language, I would say. Most languages don't tell you how to save things in memory, right? Like, for example, if I go and tell someone, hey, can you send me a calendar invite? Whether they put it in their to-do notes or they put it in Evernote or they just make a Google Calendar invite immediately, that completely depends on to them, right? Like how they want to do it. So most languages at least don't really talk about all of these questions. So the question is then exactly as you said, that Python does handle it, right? Like it has made a choice. Who made the choice? And that's where the whole nuance of specification versus implementation comes into the picture, right? When we say language, you obviously have like GCC and all these compilers which just run your code or compile your code and then run your code. But the question is now, if somebody else had to go and implement a C compiler again, will they just make all the same decisions? Typically not. So there are two concepts, specification and implementation. And nearly all the languages have the same concept, okay? Like let's talk about, because I know a lot of people here are not from like core Python, and a lot of people have done JavaScript and Rust and Ruby on Rails and stuff like that. So let's take JavaScript as an example, right? So let's say you have the JavaScript language specification, which is called ECMA for those of you who don't know. And there are many implementations of it. Chrome has an Google has an implementation, Firefox has an implementation, Safari has an implementation, Node.js has another implementation, and so on. And all of these behave slightly differently because they will all decide, like the most simplest one, if I had to print something, Chrome decides to print it on your browser, Node.js decides to print it on your terminal, right? So different things kind of vary. Again, even in Java, you have a standard language, you have different implementations. Whenever you're installing it, you'll ask, do I need to install Oracle Java or OpenJDK? Different implementations of Java. Or even in C, you have an ANSI C standard, but then you have different things like, Turbo C is what I learned in school. Then you have like Microsoft C, then you have GNU C, and so on and so forth. The point being that, or even SQL has like different, every SQL server has a different way of how they interpret SQL, right? So the point being over here is that there are many different kinds of implementations for one language, and there are some decisions that a specification normally takes, saying, like if you're not going to implement my specification, then you're not really implementing my language, you're just making up a new language. Versus the implementation is just left to whoever is trying to get that language to work on a computer. So, well, what comes first? So let's say if I had to go and make a language for the first time, what do you think will come first? Would I go and write a specification? Or would I just implement it and then see how it goes? Why don't people from this side answer, because I don't know.
Anyone?
I would do just both.
You would do both?
I would start with some specifications. I would start with some specification, then try some implementations and see how it comes around, then make changes.
Okay, so so you would do both. Anyone else? How would you approach if you had to make your own programming language?
I would first have to sit down with like a paper and try to figure out how I want the grammar to be like, and after that I can start implementing and seeing how I can implement that.
Okay, so I think every process will always have iterations, right? Like as we were just talking about in the keynote, like just before this was, you have to just get things out as quick as possible because only then you can test it in the real world situations. So I think the answer for this one, right? Like you for example said you will sit down, write it out on a pen and paper and pretty much write your specification and then start implementing. So I think you're more of a planning kind of guy who will probably plan things out before you start doing things. You're probably more of a, let me just start, uske baad I'll plan. Like let me get into the car and then I'll figure out directions to where I want to go kind of person. So the answer over here is like, it just really depends on who you are and what kind of a person you are. And really it doesn't really matter because you can be successful irrespective, to be honest. Like let's just take some examples, right? If you are coming out from academia, normally people prefer writing a proper specification and then implementing stuff. If you're in like the real world kind of situation, like the best example of this is Fast API in my mind. So, because I was in one of the PyConfs last year, and when you were talking to Sebastian, he was just like, the whole typing ecosystem in Python is so nascent, but I just wanted to use it. So I just used it, right? A typical person with a research mindset would say, let me go and improve the entire typing and then start using it. But it kind of depends on how you are. So there are many languages we just did an implementation and then started working on the specification for it after it became popular. Like PHP was one example. So in 1995, PHP came out. Specification was written 19 years later, right? The Perl is another example, like a way older language, still doesn't have any specification. So nobody can really re-implement Perl. Like if you want to write Perl in Rust, good luck, because you don't know what you're going to implement. Python also, by the way, was created ages ago, but then there is no clear specification that's ever been written out. And what these languages normally do is they have something called a reference implementation. So a reference implementation is just somebody goes and writes an implementation and just say, whatever this does is my language, right? If it doesn't do anything, it's not my language. Very simple thought process. I think you would like that. So that's basically like the reference implementation concept. And what kind of happens with that is many people then start re-implementing stuff, and then there are all these like, somebody will come in and say, oh my God, how can you not support this? And then they'll say, okay, let me support it, etc., etc. But even Python has many, many different implementations. So if you just take a quick look, well, let me actually first talk about what does an implementation do in at least Python. So in Python, let's say when you're importing a module, where the module has to be kept, like site packages and all these kind of things, in your virtual environment, in a global Python, all these concepts are not part of the language implementation. They're actually part of they're not part of the language specification. Different libraries can do different things. For those of you who've heard about PyScript, how many of you have heard of PyScript? Yeah, Python and browser. It made a huge splash with PyCon US last year. Yeah, last year. So the whole point over there is when you do an import in a browser, there's no site packages. Where are you going to import stuff from? So it actually imports it from your server, right? So many different concepts that come in when you're trying to implement Python in different places. Then garbage collection is another implementation. The global interpreter lock that we spoke about yesterday in a few talks is an implementation detail. And even dictionaries, right? Like, I don't know if you know, 3.6 has ordered keys in dictionaries, like depending on how I insert it. And that I think was because of the whole hash map change that we were describing yesterday in one of the talks. So that whole thing is also just an implementation detail. You don't have to have ordered keys in your dictionary. And there are many, many variants of Python. So you would have heard of PyPy. Again, how many of you have heard of PyPy? How many of you all think that is what pip uses to install libraries? Okay, good. That's useful to know. Because there's also PyPI, which is the Python packaging index, and many people confuse it with. But cool. So you have PyPy, Jython, which is re-implement Python in Java, IonPython, re-implement Python in C#. Does it make sense to you, by the way? Like, what do you even mean by re-implement Python in Java? Isn't Python just Python and it should be implemented in Python? Any thoughts on that? Why don't we give somebody else a chance? Like, seriously. Anyone else? Like, okay, yeah. Go ahead.
So basically, formally we use C Python, which is Python written in C. In case most of the libraries we can say are written in C language. And in the case of PyPy or for example JPython, it is written in Java. Basically, most of the libraries are written in Java, and that is why we call them. For example, when we use some function in C Python.
But what do you mean by C Python is Python written in C? Python is a language, isn't it just written in itself? At least that's a question that I get. So I'm just wondering if you guys have the same question. Do you wanna try? The next person on that?
I mean, like, okay, so end of the day, your machine can read byte code, or, it can only read binary. And Python doesn't really go directly to binaries. You need some sort of language that'll go to binaries. So if you have Java, that'll go to the JVM, which can then be passed by the machine directly. Or if you write it in C, that can be compiled directly to, this binary code from assembly, from whatever, C, C++, etc. That's why we need to rely on this sort of lower level language to implement our Python code.
Okay. But then I guess what does PyPy mean, which is Python written in Python? Do you think that is a fictitious thing and not possible?
Not sure. I mean, yeah, it means like, I think the point of C Python is that, writing it in C makes the things a lot faster. It's the standard library, a lot of it's written in C, which makes it a lot faster.
Okay.
Yeah, that's the reason we write it in C.
So all valid points, and I'm realizing a lot of my initial slides may be just obvious to you guys because you already learnt about it, so I may just speed up a little over here. But I think the main concept underlying is that, like, Python is a language, right? If you want to go run it and do something with it, there needs to be another tool which can understand that language and, as you said, convert it into machine code. That is the interpreter, as we typically refer to it as, right? So I have to install Python to run Python kind of stuff, right? So the question is now, what is that interpreter written in? If that interpreter is understanding, let's just take German as an example, right? It's like it's understanding German and then doing stuff in a computer, then that interpreter is just written in Java, or it can be written in C, it can be written in Python, and any other language. There is always a slight nuance of Python written in Python. Like, again, you have like a talk in Rust and all these things. So the Rust compiler, as an example, is written in Rust. Or the GCC compiler is written in C, right? So you have some of these like circular dependency kind of thought processes, which makes it a lot harder to create an interpreter, which we'll again see in the next talk of writing an interpreter in Python. Because the whole thought process over there is you need to have a Python to interpret Python. And what does that even mean, right? Like, where does that start? Where does that loop start? So in many of these things, you actually then need to rely on somebody else. Somebody would have a long time ago written Python in C, or Python interpreter in C, and then from then on I can start. But you need an inception point. But leaving that aside, like, there are some languages which are written in itself, some languages are not written in itself. And there are different performance characteristics and stuff that are associated to these, but we won't go into it. But okay, coming back, like different kinds of Python implementation. CPython is definitely the most popular, and the reference implementation of Python, created by Guido van Rossum in 1992. And there are many more, by the way. So there's like, or variants of this, like Nuitka, Pygeon, Piston, Brython, TinyPython, Sculpt, Rust Python, like tons and tons of implementations that people have created over time. Okay. Now again, you would not hear about most of them because we normally just use CPython and stick with it. I think 95% of the world just uses CPython without any issue. But, like yesterday there was a talk about MicroPython, which is for embedded controllers. So some people do use different variants of it in different cases. So coming back to the original question, like, is Python interpreted? Is Python interpreted? Anyone? Okay, seeing a lot of nods, so let me just pause there and let's not go. Oh, sorry, you wanted to? Is that just a yes? I can just move.
Yeah, so in a way it is, but the source code is first compiled into bytecode, and it's a bytecode interpreter instead of like other types, like a tree walk interpreter.
Okay. It's a valid answer, but not the answer to this question. I'm sorry. This is technically a trick question, guys, if you didn't get it. Python is a language. What do you mean by English is interpreted? Not really, right? Like, it's just a language which tells you how to write code or logic. So Python itself, the language itself is not really interpreted or anything like that. What you're talking about, though, is CPython, which is the implementation of Python. And yes, you can say CPython is an interpreted way of running Python code, right? So the Python language does not define whether something should be interpreted or compiled. Basically, the implementation of it decides it. And CPython has decided it to be interpreted, which means that there is an opportunity of people to write an alternative of CPython implementation and say, I want this to be a compiled version of it, right? And many people have done that, and we'll go through that kind of an example. Now again, just a very quick thing, because it seems like most of you guys are already familiar with this, like compiler versus interpreter, what does a compiler do versus what does an interpreter do? Simple thought is, when you're running some source code, you normally run it and then it executes onto your, like, somebody writes some code in a py file, somebody clicks on some command to run it, like python space a.py, and then the computer actually does its thing, right? Compilers work in this area, interpreters work in this area, before running and after running that code. Right? That's the general notion of what these tools do. And the example of the cooking example, right, is, let's say if I get a recipe, I'm going to first start buying the ingredients, then I'm going to start cooking. This is the compiler version of stuff. Basically, I sat down, I got all my ingredients, and I'm now ready. Then I start executing my recipe, which is going to cook. The equivalent of interpreting is, I got a recipe, I just start cooking. and then I realize, oh, I need some ingredients. So then I go to Swiggy or whatever tool you're using right now, ask them and buy all the ingredients that I need over here. Then I again do the next one, I again buy more ingredients, then I finish the rest of my cooking, and I again go and buy more ingredients, and I keep doing this, right? That's basically how an interpreter works. So again, just coming to compiled versus interpreted optimizations, if I have a piece of code like this, what would a interpreter do? So blue means interpreter over here. The first line is it'll just go into name, allocate some memory for name, and so on and so forth. Then it'll run some if condition, and then it actually does a print. So there are like 3 statements that an interpreter will run. Right? So interpreted, the number of operations is 3 in this piece of code. In a compiled equivalent of this, it just runs 1 operation. Can anyone explain this one, or is that already very clear? Is this clear to you guys, or do you want to go into why? Okay. Oh no, okay. So the thought process over here is that in this case, the gray basically means that the compiler will not even try to run that piece of code, because the compiler knows that name is equal to none, right? During the compilation stage, like before I even run the code, name has been defined as none. So why do I need to allocate RAM to a variable which I know is none? And then why do I need to run an if condition if I know it is already going to be false, right? So the compiler already knows these kind of things. So when I run this with a compiled language, it will only run 1 operation. So you can see order of complexity, right? For those of you who are like preparing for interviews and stuff. Order of complexity is like 3 steps versus 1 step. That's a typical notion of interpreter versus compilers. So just summarizing, compilers work before the program is run, interpreters after. Because they're running before, they just know more about the program, and therefore they can optimize the program a lot more. So again, just coming to how CPython works. So in CPython, you actually have a mix of both to some extent. First, your source code is compiled to bytecode, which is an intermediate representation. And this is a compile step, by the way. It's not like happening after you run the program. Could be thought of it. And then you run your logic, and then the runtime environment basically keeps asking for the next statement to run and keeps on running it one by one. And then it finally goes, and the runtime environment then just is able to handle multiple different OSs or multiple systems. That's why it's that's why it's system agnostic, right? Python can run anywhere thought process. So just coming back to JIT for a moment, the main thought process with JIT over here is, let's say if I had a function like this which says, give me a string, I just say hello, and it's going to run the same code that we were talking about earlier. In this case, if I gave this code to a compiler, would the compiler be able to optimize it in the same way that we mentioned it in the last slide? Which is, would it run 1 operation or 3 operations if it was a compiler? Well, the simple thought is over there, you already knew name is always going to be none, right? In this case, you don't know that name is always none. So the compiler cannot assume that the name is going to be none, because it depends on the input that is provided to it. So therefore, when it's going to compile, it's going to still keep on doing checks. The if condition has to run. You cannot avoid the if condition, right? Because even in a compiled language, it just needs to make sure that the if condition is true or false. But the general thought process with JIT kind of comes up is, what if we could optimize this function after we knew the value of input? So let's say there's an input which has been provided. The input could be 2 things, right? Like an empty string or none or just not provided, or there's actually a valid string. For each of these 3 scenarios, I will compile this function and I'll keep a record of it so that I can just do things faster. So a JIT compiler basically says, I need to wait for the program to start running, and after that, I'll figure out how to optimize and compile stuff. So you get the difference, right? A compiler would never be able to optimize this piece of code, but a JIT compiler would be able to, because it now knows some more information after you started running your program. So that's basically the whole thought process. So now, where does JIT operate? It kind of just comes into a box after you run. Like as part of your interpreter, a certain amount of that logic is given to a JIT compiler and just kind of runs that code. So that's kind of how JIT works. So this will always be interpreted, like the first line saying say hello and getting the input will always be interpreted. But then this function may be compiled or interpreted depending on how the JIT compiler works and wants to optimize stuff. This is like a nice visual representation of this, which came from one of the JavaScript blogs that I was reading. You basically have some source code which goes to an interpreter. The interpreter is working slowly, right? It keeps working. Over time, some code is sent to an optimizer or a compiler, and that piece of code is now running way faster. That's the general concept behind just-in-time compiling. You have a compiler within your interpreter or during your runtime. Okay, so lots of theory. Let me just pause for like 2 minutes and see if anyone had questions about anything I said, because right now we can just maybe go to examples to see how this all works. Questions, anyone? Yeah. You can just speak because you're pretty audible.
Hello. Yeah. So you mentioned that you have the JIT working after the code is executed.
Mm-hmm.
Then how does the optimization happen in that case?
Well, so if you see this example, right, a compiler in general will always be faster than an interpreter. Do you get that thought process?
Yes.
Because it already has the assembly code or the machine code. The compiler will always create machine code. Interpreter will think about, like it'll order that ingredient one by one. It'll like figure out what needs to be run. So with the JIT thought process, it's like the interpreter starts working. Then some piece of code, it'll realize, oh, let me now compile it. So it's compiling after I executed my program. Like after I pressed Python space a.py, like after I press enter over there, then it says that, well, something along this lines. If a function is being reused many, many, many times, let me compile and keep the assembly code for it cached. Next time when the function is called, let me not do the interpreter routine of like running line by line. I already know that if name is none, I have to print hello stranger. So it'll be just much faster because of that.
So basically, once the program is run for that particular program, there is nothing that can be done in terms of optimization. However, the result can be stored and they can be used in the subsequent repetition of that particular code.
Yes, so typically a JIT compiler will assume that the first execution of something will be slower than interpreter. So we'll see an example of that. It'll just make it a lot clearer.
Thank you.
Another question over there? Let's just do like maybe 1 or 2 more questions and then we should just go into the examples.
Actually, I had a question regarding that PyPy and GCC. Like you said, PyPy is Python in Python. Like the interpreter is in Python. So actually, I wasn't able to understand that part. Like how does that circular dependency kind of thing work? Like GCC is implemented in C, so I wasn't able to understand that part.
So the question is like, let's say if I have a piece of code, right, which I'm trying to, okay, so it's going to be tough to explain without a whiteboard, I guess. So let me try and then maybe we can talk over lunch or something like that. Cool. So the general thought is, let's say if I want to write something, or let's say if I want to speak in English, right, I need an English, or let's say I'm speaking in English, you're speaking in Hindi, and I don't know Hindi. So if I want to speak to you, I need a dictionary, right? But to create the dictionary, the English language needs to be defined, because otherwise what is the dictionary going to say is an apple or something like that. So that's what I mean by the recursive dictionary. Like for me to be able to write something in English, English needs to be defined, and somebody needs to also be able to understand English. The same kind of concept holds true when you try to write a Python interpreter in Python. It's like, how did the interpreter come to life if there was nothing to interpret Python, right? So therefore, you need someone to write the first version of that interpreter. So what that basically means is that PyPy can only get compiled if I at least have an older version of PyPy. Like if I'm going to release PyPy 2.10, I need 2.9 to be able to compile 2.10. But then what happens with version 0.1? How is 0.1 getting compiled? Because there's no 0.0. So that's where the recursion kind of becomes a little more complex. And again, there are ways of bootstrapping it and other things which people have done. But again, they would have done it back in 1990s and forgotten about it after that, right? But there are many things which also happen. Like let's say if I now want to compile PyPy for a new operating system, which just came up, I don't have a compiler of Python or an interpreter of Python in that operating system. So the bootstrapping step is still important. Like especially with Rust as the most common example. Like, I can download Rust and I can compile Rust on my laptop. But what did the first guy, where did he download Rust from? He didn't have a place to download Rust from. So he did some very complicated stuff, bottom line. That's the gist. Okay, let's maybe just move to, again, more questions we can take up later on because I'll be around here for the whole day. Is the text readable over here? No? Right. All good now? No? This is better? Yeah, you can read it. People at the back, can you guys read this thing? Yeah, people are like nodding like this. I have no idea if that's a yes or a no. Okay. You guys can read, right? Okay, just raise your hand. If you cannot read, then I'll do something about it. You cannot read. Okay, a lot of people cannot read. This is good? Still no? I think you guys should just come forward then. I don't think I can. I need at least 5 lines on the screen. Let me try. Oops. Okay, let me try going ahead. If you can't read, please do come forward. There are enough seats in the front. I do not know what that is or how to use it. I'm sorry. Let me just go with this. I think I'll just be more comfortable. Sorry. All right. So basically what we're going to be talking about over here is, you know what, actually just give me a minute. Okay, a little more bigger. So what we're going to be talking about in this notebook, again, I come from the financial analytics world, so I'm going to be talking about a particular algorithm called Black-Scholes. How many of you all know what Black-Scholes is? Very few people, okay. Yeah, people from the finance world, I met you guys. So I think, like most of you guys are in school right now, so maybe not very relevant. At some point of time, you'll have a startup. When you make your startup and you need to do your stock option management and stuff, that time you will care about Black-Scholes a lot more. But Black-Scholes is one of the algorithms which is used to try figuring out what is the valuation of a company kind of things, right? Like, or the valuation of options rather than a company. We won't go too much into detail over it because it's honestly just a lot of math, and I don't want to make this into a math discussion. But the bottom line is that math can be written in Python, which is what we care about. And the math basically looks like this. It's some pretty complex stuff with a lot of numbers and a lot of exponents and square roots and all that kind of stuff. This is just some code that I got from the internet. I have no idea what it does, so please don't ask me what it does. But the point, so I basically created this function called Black-Scholes, which takes in an argument, which is a seed argument, generates some random numbers, and then does a bunch of math on top of it, right? We're going to be using this as an example for how can we optimize this piece of code to run faster. Like what people would normally do is they've written out some code. It's all using NumPy, by the way, so it should be reasonably fast. So I have this function called Black-Scholes. I run it for the first time. It basically runs in around 75 milliseconds. Seems reasonably fast, right? Should we be optimizing this piece of code? 75 milliseconds. Okay, a lot of people squinting eyes and wondering why we are talking why we are talking about optimizing 75 milliseconds. I mean, the simple answer is it just depends on how many times you're going to run it. In my case, at least in a more big data world where we just have tons of data, I'm going to be running this on like 1 terabyte of data. So this 75 millisecond easily converts to hours if you go and run it like 1 million times or 1 billion times. So let's just take this example, and again, it's a micro benchmark. There are many more benchmarks out there, but let's take this as an example for now. So this is running in 75 milliseconds. And how many ever times I run it, it keeps on taking around 60 to 70 milliseconds. Even if I use time it for those of you who don't know is a magic function in Jupyter, which is runs some things like multiple times. It gives me the average and standard deviation of the runs. So yeah, we've written some code which is 65 milliseconds in Python. If I want to optimize it, now, you can try doing a lot of stuff in Python, but then you'll come to a limit where you can't optimize this further. That's when you start looking for weird things on the internet, and that's how I came across JIT compilers. So let's just take a quick example of Numba. So Numba is one of the tools that does JIT compilation with normal CPython. Okay? So you have like two different varieties of tools in general. One is use CPython but add JIT compilers to it. Or you can say I don't want to use JIT, the CPython at all, and I want to use Jython, which already has the JRE JIT compiler as part of it. Right? Now I don't want to go away from Python because I love pandas, I love NumPy. All of these are not available in Jython, by the way. So not all the implementations of Python give you all the benefits CPython has. So I want to stick with CPython and still get some benefits out of it, like make this faster. So if I try this with Numba, I created like a variant of this called Black-Scholes Numba. Now just for the purpose of this, I'm going to show you a diff. The diff is I have 3 lines of code which I've added. I'm importing JIT from Numba. And then I had 2 functions, if you remember my code. There was a function called CND and a function called Black-Scholes. So I just put a decorator called JIT for both of these functions. That's about it, just 3 lines of code, right? Now I'm importing that particular Black-Scholes Numba code, and you'll see that the first time when I'm running it, it's 690 milliseconds. So it's become faster, right? Yeah, thank God. All right, people are listening. So you can see over here that it went from like 60 milliseconds to 600 milliseconds. So it actually became 10 times slower. So then what's the whole point of Numba, and why are so many people in the numerical community spending time on it? Well, the simple answer is, and if you like, there's a very nice thing in the Numba homepage. If you go, it has a whole section of how to do benchmarks with Numba. Because the funny thing is that when they released Numba, and people started doing these kind of comparisons, and they said, guys, Numba is like slower than Python. Why did you guys even release this? What is the point of using it? So they have like this whole section about saying, please don't raise tickets. If you have done benchmarks in this way, this is the correct way of doing it. So the correct way is basically, don't look at the first time it ran, look at the second time it ran. And you'll see the second time that the same function ran was 1 millisecond. Right? So the first time it was 10 times slower, second times it was 60 times faster. And that's what you will typically see. So you were asking the question about the first time that you run something in JIT is going to be slow. Yes, and typically it's going to be slower because it's not about just running the piece of code. It's also running, caching it, and then doing various other logic to make sure it can be reused again. Right? So this is the most generic thought process, right? Like even if you talk about caching and all these kind of things, the way I kind of think about, or at least one way of thinking about JIT compilers is caching your assembly code. Right? Normally CPython needs to generate assembly code for every line. What if I could cache some of it? Because I know I'm going to keep on rerunning that same function or the same line multiple times. First time you run it is going to be slow. Second time is going to be much faster. So, well, that's cool. Now I can also use time it, run it multiple times. I can see it takes around 1 millisecond on average, which by the way, again, like I don't know if you guys realize, 60 times faster, right? Just by adding 3 lines of code in Python. Not the first time, but 60 times faster in all the other executions. So over here again, you'll see like with the Numba, any of these functions which are decorated by Numba, you can see a bunch of these arguments which are available. So I mean, it has a normal doc and all that kind of stuff, but then you have a bunch of these new attributes to this function called inspect. So you can actually, Numba allows you to inspect the assembly code that it generated. How many of y'all can read assembly? Oh, some people say so. All right, good. You'll be able to understand this more than me. So the simple thing over here in inspect assembly is, it gives you a function. You can see that it has compiled assembly for integer 64-bit. So whenever this function is called with an integer, it can optimize stuff, or it has an assembly code available. And I can also see what that assembly code is. It is this stuff. Yeah, just going on and on. Doing some moves, calls, something else's, doing a bunch of stuff which I can't understand, but maybe some of y'all can read it. But this is the actual assembly code that function, or the Black-Scholes function, was going to run internally. Now what Numba has done is simply it has kept a record of it, so it can keep on reusing this again and again, which like reduces a lot of the effort of interpreting it again and again every single time you're going to run the function. And you also notice that it has made some assumptions, like this code is only available for integer 64-bit. If I go and give a string to it or a floating point number, it'll again recompile that. So it'll again take 600 milliseconds. And then the next time I give a floating point number, it'll be much faster of 1 millisecond again. So there are all these nuances about JIT compilers that you'll see. Oh, there's also LLVM. So internally, Numba uses LLVM, which then converts to assembly. Again, for those of you who can read LLVM, you can look at that too. It's all just gibberish to me. I'm sorry. I've never learned this stuff. So I will just skip it for now. But you can actually look at it and see what's happening internally, which is pretty cool. Now, a quick note over here is, right, it's whenever you use a library, it's important to know what is the main objective of this library. So in this case, you can see Numba tries to make NumPy faster. So it improves vectorization for NumPy, parallelism, some MKL libraries like fastmath, and some approximations sometimes, and so on and so forth. But like it has a JIT variant, like Numba does just-in-time compilation, but it also does a lot of other things, which just make your NumPy code faster in many cases. And again, you can always make your NumPy code faster by rewriting everything in C, by the way, right? Because you can write a new function in C and then use it in NumPy, but not everyone likes to do that. I mean, I would much rather just write 3 lines of code and make it 60% faster, or 60 times faster, as compared to spend a week rewriting my logic in C. So, or Rust, maybe now. But different people have different things. So Numba basically helps in these kind of things. But Numba has limitations, like it cannot understand everything that Python does. The most simplest example is, let's say if I have a function where I'm importing Flask, or just some other library. Numba will throw an error, saying there's something called import, and it doesn't understand what importing even means. So Numba cannot optimize import statements, or it cannot even like run import statements. So it can only do mainly numerical functions, like sine, cos, plus, minus, the math library and stuff like that. And also you need to be careful about corner case behaviors, because as soon as you go to low level stuff, Python is being dynamically typed and all, there's a lot of type checking at runtime. When you start going to assembly, the type checking are kind of stripped by Numba. So let's say if I have an example where I have a function taking an integer and just doing a simple range function. So Numba can run this, all good. But if I give it 2.1, Numba gives me 0,1, right? This is kind of wrong for those of you who know the range function. Normally, if I run this in Python, it gives me float object cannot be taken as an integer. So you'll see Numba, the reason it's faster is because it removed an if condition, which says, make sure that whatever you're getting is an integer. And that's one of the things that makes Numba faster. Again, there are ways of saying, like, don't be so fast, but be more robust. So you have all these flags you can play around with Numba, but that's basically the gist of it. Now, I know I'm running out of time, but let me just maybe go quickly to one more example of Piston Light. Piston Light is another really cool thing. It again, just a 2-liner code that you can write. Piston is created by something called Dropbox, for those of you not familiar. So you just import, like pip install Piston Light, import Piston Light, and just enable it. This also makes your code, well, in this example, actually not much faster, because it went from 65 to 75 milliseconds to around 60 milliseconds. But again, Piston Light also has a JIT compiler, but again, look at the objective of the library, because too many nuances in some of these low-level stuff. It has a JIT, but it has a very, very, very basic JIT, right? The JIT is not what really makes it faster, but it has something called faster cached attribute accessing. Like whenever you're using a class and you do the dot function, basically it's like you're accessing an attribute from your class. It has so what Piston Light can easily do is that if your code takes, let's say, 100 minutes to run, it can reduce it by 20% quite easily just because of attribute caching. But again, like remember, if I'm doing NumPy kind of stuff, I'm not going to do much attribute caching. But if I'm using something like Flask or Django or something like that, like if I'm making an API, like, I normally do like tons of attribute caching with my ORM layer and all these kind of stuff. So whenever I do attribute accesses, Piston Light is kind of been really fast. So 2 general notions that I've seen just from my experiences, if you're doing numerical Python, Numba is like really awesome and you should really learn it if you don't know it. If you're just working on other libraries like Flask, Django, web APIs, etc., take a look at Piston Light, because it is just outright able to give you like a 20% improvement, which normal C Python doesn't really give you, right? Like 20% is a pretty decent improvement if you're thinking about it. And just with 2 lines of code, import Piston Light. Again, just a very, very quick look is you also have something called Cython, which pre-compiles the entire Python code for you. I'm not going to go too much into it, but it's a really cool tool. You may again want to take a look at it. So this is an example with Cython. Cython is like pre-compiled Python, so it's a compiler variant of Python. It was able to run this in 40 milliseconds, not 1 millisecond. Better than 60 milliseconds, but 40 milliseconds. So you can see that sometimes the compiler is not able to optimize your code as awesomely as it could. But JIT compilers, because it has more information, can optimize it better for you. So that is just an interesting observation for me. And Python is not the same as CPython. A lot of people have the misunderstanding. Python is a compiled version of Python. CPython is an interpreted version of Python. And it has all these cool things where for every line it will actually show me what is the exact C code it ran and all of these kind of optimizations that you could do. So yeah, that's pretty much it. Let me pause over here. We talked about JIT compilers, normal compilers, interpreters, and the main gotcha is just for you to look at whenever you're looking at these slides later on is check the Python version compatibility of some of these libraries, because a lot of them are heavily optimized for only one version of Python. So they'll only work on Python 3.10, no other version. So you just need to be comfortable with these kind of nuances. Be careful about corner cases. So we saw the example of float versus integer giving different behavior. Just be careful of that. And do your own benchmarks. Just because I'm showing you it can be faster for Black-Scholes doesn't mean it's going to be faster for your code. Because a lot of these are just very low-level things that you cannot easily develop an intuition for. So in these kind of cases, it's better to do it empirically, try it out and see how it goes. And if it gives you a benefit, then that's great. Okay? That's about it for my talk. I know we're out of time, so maybe any questions, we can take it up outside. All right, you can, yeah, that's about it.
Thanks for the talk. We learned a lot about JIT and everything. I would like Gora sir to give and Ali sir to take the memento. Okay, so ever wondered how does an interpreter work? How does a Python interpreter takes your code, takes your lines, interprets it, and most importantly, run it without a bug or an error? So today we have Tushar Sadhwani. He's a Python developer. He's a contributor in Pip, Black, MyPy, and a lot more. So please welcome Tushar with a huge round of applause. And he would be showing how does a Python interpreter work? How is it built from scratch? Tushar, stage is all yours.
Give me 1 sec. Just a talk.
Yeah, let's start. 1 second, actually. This the watermark is a bit annoying, so I'm just gonna get rid of that. Yeah, that's better. And full screen. Yeah. Okay. So, so I'm gonna be trying to explain how a Python interpreter works, and I'll be doing that by showing you how to write an entire Python interpreter from scratch in about half an hour. Now, when I say something like this, the first thing that should come to your mind is why. Why would you want to write a Python interpreter? We already have so many Python implementations. Why would you want to write one? Well, the point of this talk is kind of twofold. The first point is that it's not exactly some archaic black magic how to write a language from scratch. So a lot of people kind of think that writing a program using a language is fine, but writing a language itself that would be very, very hard. I won't even take a look at it. But that's not the case at all. Writing a language is kind of just like writing a normal program. And the second point is that even though Python is a 32-year-old language, and thousands of the people have written that language, so it's a giant project, but that does not mean that it's so complicated that you cannot begin to comprehend it. And the fact is, at its core, Python is still a fairly simple a very elegant code base, like the CPython the repository, and I think that you can and that you should try to contribute to it. So yeah, let's start this entire thing with a short story. So a long time ago, I wanted to build a JSON parser, and that's where it all started. So I wanted to build something like this. So there's a parse function somewhere where you get a parse function from somewhere that it takes in a string. The string contains JSON data. Say here we have a dictionary of results that contains the two objects, two people's information, where the first person, Rob, is not a vegan, but the second person, John, is a vegan. And by calling this parse function, we're able to take this string and very easily extract the information out of that string. That's what I wanted to build from scratch. So the thing is, what exactly is a parser doing here? If you take a look at this JSON data, it may be obvious to you that there are two items here, the name is the key and John Smith is the value. But to the computer, this is just a string. It's a bunch of the characters that don't have any specific meaning. But you can tell various facts about the string, the keys here are strings and the values are strings as well. So how exactly do we do that? So the first step towards accomplishing something like that is a step called tokenization. It's where we take the input string, then we segregate it into a bunch of tokens. We have the whole thing is kind of wrapped in the curly braces. The first token is a curly brace, and the last token is a curly brace. We have two colons in the middle in the red color, and then we also have two strings highlighted in purple, and there's a comma in between. So we have separated the input into separate tokens, which each of them may have their own meaning. So this first step of segregating the input into sort of meaningful tokens is called tokenization. And the next step from there comes from the JSON spec, and the spec is very important. Without the spec, you can't really say for sure the thing that you have, is it JSON or is it not JSON. But thankfully, the JSON.org website has to define like a clear spec so for JSON, then it goes something like this. Like the grammar on the top says, like an object is like defined like as an opening curly brace, so followed by a bunch of items followed by a comma. Like you can have an item and a comma and an item and a comma and so on. Followed by an item without a trailing comma and then and a closing curly brace. That's the definition of an object in JSON. Now, what exactly is an item? So, well, an item is just like a key followed by a colon followed by a value. So, in this example, like you can assume that that the key and value are both strings, but with this spec, you can like very clearly tell that this string is trying to represent an object here, and that's an item. Like there are two items here, and like that's a key and that's a value. So by using a properly defined spec, we're able to like turn these to a bunch of tokens into like information that we can directly access. So that's like the kind of all there is to parsing. You've taken the structured input, you take a spec, and you implement that spec to be able to get some information out of your input. I think that's enough like talking in the air, right? So let's actually like take a look at some code that can like do this thing. Okay, so we have a tokenized function here, which takes in a JSON string and it creates like a queue of tokens, a deck of tokens. And like how do we implement that? I think I'll require a pointer for this. Yeah, I guess that's good. Yeah, so we have a queue of tokens here. We like start with the index like 0, then we keep going till the end of the string. And we take out each character and we basically go character by character here. So in JSON, all the white space is ignored. So we just do index like a +1 and continue to the next character. Now, if we were to see a character like an opening brace, like or a colon or like a comma or something like that in the string, we turn that into a token, like where we like to store the value with the type operator. So we add that to the queue of tokens, and we go to the next character. There's like 3 more cases here. Like there's like one for a string, one for a number, and one for special cases, which is true, false, and none. And that's like all the possible tokens that can exist in JSON. So but the problem with these tokens is that like they're not a single character. Like they can be as many characters as you want. So like previously, like we were doing index plus equal to 1, but like now we don't know how many characters ahead we have to go. So we kind of like define these functions like where we give the current index and then like we return the new index like which will be say at the end of the string here. So let's take a look at this like extract string function here. So this function is supposed to like take out an entire string from the JSON input that we have given. Yeah. Then like right here we basically do the same thing like that we have done in the top level tokenized function. We like start a while loop like which goes until the end of the string, but like instead of starting from 0, we start like from the current index of the string. We jump over the starting the quotation mark, and so we keep going until we see the end quotation mark here. And like at that point we stop, we like extract out that string, and we append that string to our tokens and return the index after the closing quote. The only exception to this rule is when we see a backslash. Now that's because like JSON strings, they allow you to have these escape sequences inside them. So for example, what if you want to have a double quote inside your string? So in that case, so we see a backslash and then we skip the 2 characters. So we sort of like jump over the double quote. So we we avoid hitting this condition. So we are able to successfully like tokenize like the string properly, even though it contains a double quote. No, like that's the kind of like all there is to tokenizing a like a JSON string. Like let's like like looking at like at the parsing phase from there, we have like collected all of these like tokens until like we ran out of the input string. So now we have a queue of tokens. We pass these queue of tokens to the parse function. Like now the parse function, it takes a look at like the first token in that list. It like checks for some the properties like is it a list? Like is it an opening bracket? Is it a like an opening brace? Like is the type a string? And like based on that fact, it like calls these functions, which like the parse an array, parse an object, and so on. Now, like for the specific like values like true, false, and null, we just like turn them into the Python's true, false, and none, and like we just like return that value that we just parsed. Now, the real sort of magic like that happens here is in these two functions, parse array and the parse object, because like let's like take a look at the parse object function here, for example. So what happens here is like if you want to parse like a JSON object, you basically like what you do is you expect to see like an opening like a curly brace. Then the first thing that you expect is a key, like which you parse as a string. Like then you expect to see like the colon character, which you just discard, and then like for the value we're calling parse once again. So the parse function is calling parse object, but like parse object is calling parse like again. So it's kind of a recursive like definition like of the parsing. So how exactly like does that work? Well, this works because like the parse function, as we saw, like it only consumes tokens like until like a single Python value like is generated. Like for example, like if the token type was a string, then we simply like take a look at the first like token here, then we just like return. Okay, so like it's kind of a lazy implementation which allows it to like easily recurse. I think it would make more sense if I showed like a pseudo live example of this. So like say I call the parse function with these tokens, like there's an like an opening curly brace, the string name colon John Smith, and like a closing curly brace. So like the parse function, so what does it do? It like takes a look at like the first token, like looks at some properties. So here like the first token like happens to be a curly brace, so it calls parse object. Parse object like it takes the first token, parses it like as a string. So this like token like becomes the Python string name. Like then we expect a colon, like we find the colon, great, and like then for the value we call parse again. Like now what does parse do? It like checks these the properties. So this like token right here, John Smith. Like is it an opening the square bracket? No. Like is it a curly brace? No. Like is the type string? Yes. So here we call parse string. Like this becomes John Smith. Now this function, like after this, like it either expects like a comma, like or a closing curly brace, and since we find a closing the curly brace here, we break out and we store like how we return this like a dictionary that we have parsed out of the object. So this is like basically the idea of recursive descent parsing, where we kind of like rely on like recursion and recursive definitions to be able to like parse the queue of tokens that we have. And yeah, with this implementation, like our JSON parser is basically complete. So we defined a tokenized function which like turns our string into these tokens, and then so we call the parse function with these tokens. Then we get a Python dictionary out. Let's do a small demo of this, I guess. Let's see. Do we have a demo? Yeah. So examples JSON.py. Oops. Yeah, so I'm going to run this like a JSON.py example with the small JSON string, and we get a Python a dictionary out of it. So if I were to put it in a variable, we can access properties out of it. Let's print x and print x foo. Is the font good enough actually? I think that would be better. Yeah. So we are calling the parse function with this a JSON string, and we get a dictionary, and we are able to access the properties inside that dictionary. So with around 300 lines of code, we've written a working JSON parser from scratch with zero dependencies, no libraries, no pandas or anything, Yeah. So the great part about the JSON spec is that it's such a small spec that some giant JSON string, so with all these features, we have a Unicodes, we have a bunch of nesting, we have everything here. This same 300 line JSON parser is able to parse the entire thing. So yeah, that's the great thing about recursive descent parsers. They can pack a lot of power with a very simple implementation. So yeah, but the talk was not about writing a JSON parser, right? The talk was about writing a Python interpreter. So the thing is, this JSON parser, we are going to be trying to write a Python interpreter that runs this JSON parser. So that's kind of the goal of this talk. And I'm gonna call the Python interpreter interpreted. That's the name of the project. So yeah, first things first. What exactly is an interpreter? So the interpreter is actually made up of three parts. There's the tokenizer, the parser, and the interpreter. Yeah, I know that the third part itself is called interpreter. It's just weird like that. So in C Python, for example, all these three parts, they're written in C, and that's what it means for a language to be written in some other language, because these three parts are written in C. That's why we say that C Python is a C implementation of Python. But for the sake of teaching, I'm trying to I'm going to try to write these three parts in Python itself. So say that we have a print hello world program. If I pass it to the tokenizer, I should get something like this. I should get a print token, an opening bracket, the string hello world, the closing bracket, and then a new line. New lines are important in Python because that's how the language works. There's no semicolons, so new lines are important. Yeah, this gets passed to the parser, which creates this nested structure where we kind of have a Python module which has a function call to the function name print, and there's only one argument with the constant value hello world, and then the interpreter takes this nested definition of that the parser gives you, then it tries to run that the print function with the one constant value to a print out to the terminal hello world. So that's kind of how the three parts of an interpreter work. So yeah, first things first, the tokenizer. So Python's a tokenizer is actually very similar to a JSON tokenizer. There's mainly only two big differences. The first one is that like new lines are important. Like so in our previous implementation, like whenever we saw white space, we just like jumped over it in the tokenizer in the beginning. We cannot do that in the like the Python tokenizer. So we do something like this. Like whenever we see a new line and so we are like not in a bracketed statement, like a multi-line or dictionary definition or something like that. Then so we add a new line token as well. And then like all the new lines after that like are sort of ignored. Like so like you can have white space like in the language still. Like the second big change in the language is that like we need to take care of indentation. Like now like whenever we see a new line, like the new line of code can be on some like level of indentation, right? So like we need to kind of make sure where the line of code is, like which scope the line of code is in. So like for example, Python like has to like keep a note of like all the indentation levels as a stack. Like right here, like we have a 4 space indentation, and then like we go from a 4 space to like a 4 and 8 space like indentation here. So the indent level here is 2. And to be able to figure out that we went from 2 indentations to 0 indentations here, we need to to keep a stack to make sure that like we went from 2 to 0. So we need to make sure that we jump out of 2 scopes, not just 1. Now the implementation of this is kind of convoluted, but basically every single like tokenizer that exists for Python has this exact like implementation. Like you might have even like seen this like error called like inconsistent use of tabs and spaces yourself while writing Python code. But yeah, like that's sort of the the implementation of the intended the word detection part. I won't be able to go over this because I'm short on time. But yeah, that's basically the changes that you have to make to the JSON tokenizer to be able to make it work with Python. Now the deal with the parser is it's basically exactly the same as the JSON parser. So you take in this Python code, turn it into tokens, and you create this nested structure out of it by using the recursive descent technique. Now this structure in Python is called the abstract syntax tree or the AST, and that's what I'm going to start calling it from now on. Well, the definition of parsing I think is best explained live, so I'll just try to quickly go over that. Let's see if I can do this. Yeah, so if I try to run the parser for this, Python interpreter.parser, if I give it the code like this, you see that in the module, we basically parse 2 statements. There is one assign statement here, which had the target x, and the value was a binary operation of 2 plus 2, and the second statement was a call to the print function with one argument, which is the name x. So how exactly does this work? So similar to the JSON grammar, there is a Python grammar. In the Python grammar, so you define things like this. So the top level module has a bunch of statements. There can be 0, there can be 1, there can be many. What is a statement? A statement is a single line or a multi-line statement. Multi-line statements can be function definition, if nodes, while nodes, so on and so forth. What is a function definition? Well, it starts with a token, the def token. There's a name token, that's the function name. There's a bracket. There can be parameters, but they're optional. There's a closing bracket. There's a colon, and then we have a block of code. So that's the kind of how the entire Python grammar works. And the implementation of this is basically exactly what the grammar says, what we saw in the JSON parser. So the parse function for the module, it creates a list of statements, and while we have not fully consumed the list of tokens, we keep parsing statements. We add them to the list of like a statement that we have, like, and then we create the module node. Like how do we parse a statement? Like if we see a def, like if like for a while, like a token, then we parse multi-line statement. Parsing a multi-line statement, like if we see a like a def node, we parse a function definition. For a function definition, the first thing like is that like so we expect the def keyword, like, then we expect a name, then like an opening bracket. Then we parse the parameters, like there can be like a name and a comma and a name, like so on, like in a while loop until we see the closing bracket. We expect like a colon and then the block. So like the parser is basically like the same deal. Now like there is a small like note here on parsing blocks, which is since like we calculated like how many like indents and like dedents there are, like we like get nested parsing for free. Like I'm not able to like go into details like for why this happens, but yeah, like since we calculated like dedents, so we're able to calculate that we like jumped out of 2 scopes like here on the, like this line number here. For the interpreter, like we basically take this like parse tree, like we go from top to bottom, left to right, like using the visitor pattern. It sort of looks like this. Just it should take a minute or so. Yeah, so like running the code is basically like having like a global scope, like where we like store all the functions and classes like and objects and everything. And to visit a module, we take a look at the body and take the statements can, like we saw that like there was an like an assign node and like then a call node and so on. So we simply like find the function called like a visit, like the visit assign or like a visit call or so on, and like they get called right here. So there will be a visit assign which will like take the function's value and like then like set it in the scope. So like that's how like the interpreter like goes over each and every statement one by one and like runs them like that. So yeah, that's like kind of like all the time I have to explain this. But yeah, like this like interpreter doesn't really have like a bunch of these like features, but like once like a bunch of these are implemented, we get a bunch of these for free, because like all these libraries are like written in pure Python, so we like don't need to re-implement them because Python is just Python, so we can just like run it. And yeah, like if like this like seemed interesting to you, then like you can like look at these 2 books. There's crafting interpreters and there's C Python internals, like very good like books. And yeah, like if you want to help like finish this Python implementation in Python, like I have an entire like roadmap that you can like help work on. And yeah, like the source code is available on GitHub, and that's all I have. Yeah, thank you.
Thank you so much, Tushar. And I just want to thank him because he's been my mentor for the past 4 years, and he's helped me a lot in learning Python and mentored me about a lot of things except coding as well. So please give a huge round of applause to him. And Satya sir, could you join us on the stage?
Also, a quick announcement. The workshop is commencing in 5 minutes, so whoever wants to attend it can attend. It's a data visualization workshop by Jaydev. So you may go.
And the next speaker is, there's another, Abdeli Khutari. He's giving another fantastic session. And it's not about performance or JIT compilers. He's going to talk about automating stuff with Python, especially using browsers. So if you want to know how to automate things which can take minutes and hours, here's the session for you. No, I'm the admin session. Which code is that?
The last time वाला OJ.
नहीं change हो गया.
Change हो गया.
I would like to request the peeps sitting at the back to come forward, please. Excuse me, can you please come forward? Fill up those seats, probably.
All right, let's get started. I heard there is a data visualization workshop, which I'm sad that I'm going to be missing. But cool, I'm glad that you guys are here for the talk. Let's maybe just get started. This is going to be a little more light-hearted, which is why you'll see fancier colors over here. The main discussion that we're going to be having here is not about performance that we were talking about for so long in the previous two talks, or interpreters or compilers or any of that kind of stuff. We're going to be talking about browser testing. So how many of you guys are actually, like, I guess most of you all have made a website at some point of time? No, yes, no, yes. I'm very glad with the people in the front because you guys don't nod like this. I think it's just people at the back who do that. But cool, I'm seeing a lot of yeses and nos. That's nice. So the general thought, right, let me just maybe give you a 2-minute intro on this, is browsers are the most popular software that most people have on their laptops. I think a browser is open for 99%. Like the first thing I do when I open my laptop is open a browser, open VS Code, open a terminal, right? And not just from a developer perspective, like as somebody who creates products, a lot of my products which I create are in browsers just because they're so ubiquitous and available everywhere. So what kind of becomes really challenging, or the problem with browsers, is that they're there everywhere, but it's not very easy to use them. And what I mean is that browsers are made for humans, okay? Like they are expecting you to know when to click on something. They are expecting you to know when a page is loaded, or what does a loading symbol mean, and all these kind of things. If you were to ask a program, is my web page still loading? It doesn't really know that. And that makes automating browsers very painful, which means you cannot write test cases for your products if you are using a browser, right? Like make sure that if you click on something, something is happening. All of these are very painful to write. And this is something that, I'm basically working at Corridor Platforms. So at Corridor, the product that we create is a purely browser-based product. And we need to make sure it works, right? We can't just say, oh, we couldn't test this part because we can't test browsers easily. So testing things which are working in a browser is a pain. And there are many other things that you also do, like you want browser automation for many other cases. Like the most popular one, which I don't like as much, is scraping for data. So whenever you're doing data science projects, you want to go and like download, let's say, data from Wikipedia and stuff like that. Now, most organizations give you this whole compiled data, like in a tar.gz file or something, which you can just use. But many times they don't. In which case you start writing these programs to go and download all your content for you one by one, using things like Scrapy, Beautiful Soup, and all these kind of tools that we've heard of, right? So even in that kind of cases, you need to automate stuff that's happening in browser. So browser automation is a very generic thing, can be used for many real life use cases, but also for testing. And I'm more focused on the testing part, not as much on the data scraping part of things. But whatever we are going to talk about is going to be useful for both, right? So whatever floats your boat. So let's talk about browser automation or browser testing. What are the options? What are the challenges? If you've ever been in this whole area, or if you've ever been in the testing area, you may have seen this testing pyramid, which says that most of your tests that you write need to be like unit test cases, which is just checking if your function is working correctly. Then you have integration test cases, E2E test cases, and then UI test cases. The UI and E2E is where browser testing kind of come into the picture. Before that, you just want to see if whatever you have written in Python is actually doing it, right? Like, is an SQL query firing and things like that. And that's the part, the top part is the one which is important because it's testing your entire stack, right? Like your unit test cases can all be green and pass, but it may actually not work when you do a click. And that's a pain that most people have. So UI testing and E2E is also important. But again, most people don't focus on it because it's so difficult to write. The reason for why it's kind of difficult to write is because exactly what I described of browsers, right? They're meant for humans, not for computers to be used. And there are many different tools which are available for these kind of things. So some of these tools, has anyone ever used Selenium? Just so I can understand the crowd. Oh, great. Okay. So actually, most of you have used Selenium. How many of you have heard of a tool called Cypress or used Cypress? Much lesser. Makes sense. What about Playwright? Anyone used Playwright? How many of you have heard of Playwright? Okay, only 3 people, which means that you haven't even read the title of this talk. Shame on you guys. So we're going to be talking more on Playwright if the title didn't give it up for you. But the main thing is that there are many tools which are there in this space. And I think Selenium is like the de facto standard, right, that most people have always heard of. Selenium has been around for a very long time, even when browsers didn't have JavaScript, right? Which also means that it has been designed for browsers which didn't have JavaScript. So it kind of sucks for browsers which have JavaScript. So Selenium has been around. I think that in the last 5 years, as web pages have become more dynamic, right? Again, most of you haven't been around for that age, but earlier when you click on something, it'll always load a new page and show you the new content. It wouldn't be like this whole flashy dynamic. The most dynamic thing that we had back in like 2005 was marquee tags, which used to like make your text go around and come back. But coming back, so as the web has become a more dynamic beast to manage and become more JavaScript driven as compared to backend language driven, tools like Selenium are not really being able to keep up. So there's been something called WebDriver.io, which has been very popular. You have Puppeteer, which has been very popular, which kind of help you interact with browsers in this with the whole dynamism that it brings you. So overall, there are like 4 things in your testing automation stack that you would worry about. Browser actions, which is like, can I do something with a browser? Very low level stuff, right? It could just be, I want to go and press a button, press a mouse click, or I want to go and type something, like very low level actions at a browser level. Or even open a new tab and all that kind of stuff is all browser level stuff. Then you have user actions, like, I want to swipe. Because if you're trying to make a mobile website, you want to swipe. Now, that's not swipe is not considered a browser action, just for those of you who are not familiar. What is considered a browser action is touch, movement, touch end. Okay, so that's kind of the difference between browser action and user actions. Then commands, which is how can you, like we were talking about languages and stuff, but how can you tell a browser to do something, which could be done in Java, Python, JavaScript, whatever you like over there. And then also test case organization if you're doing the testing part, kind of like stuff like PyTest or Test Cafe, Cucumber, if you've seen any of these kind of tools out there for browser testing. We'll be more focusing on the user action area, so we won't be as much focusing on test organization, but we'll see how it goes. And the main challenge was, as I said, rise of JavaScript has been the biggest problem. Flakiness of these kind of tools. Like when, if you click on something and it doesn't click, you just go and click again, right? A computer does not have the benefit of doing that because it doesn't know how many times to click or when to stop clicking. Speed. Like a lot of times what people do is they do a click and then they just make the computer wait for 5 seconds. And that's like the worst thing you can do because it just becomes really slow to do anything that you would want to do from it. And maintenance. Like because it's all flaky, how can you make sure, or as websites keep changing, today I'm using React, tomorrow I may be using another library. How can I make sure things are robust so I don't have to keep on going and rewriting my testing framework, which everyone hates doing if you have not guessed by now. It's like, code to test if your code works. Who writes doing that? So that's basically the main thought process and the main issues which come up with a lot of these tools that we've seen, like Selenium and so on and so forth. And again, for those of you who are like diehard Selenium fans, I'm sorry if I'm offending anyone. That's at least my opinion. You may have a different opinion and I'm cool with that. Playwright basically helps me, and I was, I came across Playwright about a year ago, pretty recently, but I've known the challenges of Selenium for the last 5 to 6 years, easily. right? It's just been a pain to maintain all our Selenium test cases for quite some time. Playwright has alleviated a lot of those pains, which is why I really wanted to do this talk for those of you who are not familiar with Playwright. Well, let's just maybe go into a quick demo, because most of my things are normally demo-centric, and let's hope this whole thing works, because this really needs internet. Let's see. Let me just go back to my old mode. Can you guys read? I think lesser crowd this time, so everyone should be able to read. Yeah, cool. Awesome. So how do you start with Playwright? Well, simple. You do a pip install Playwright. And the only thing with Playwright is Playwright internally, just so you are aware of the internals, it has its own variation of Chrome. Like it takes Chrome, but then they've done some stuff, which I don't know exactly what they've done, but it makes the Chrome a lot more stable for automated running. Right? There are these concepts of sandbox modes and isolated modes and all that stuff. For those of you who are familiar with Selenium, it does a lot of that stuff directly in Chrome. So it installs its own browsers. It installs its own Chrome, Firefox. I think it has Safari now, I'm not sure. But it installs its own stuff. And if you're using WSL, then you may want to just follow this particular thread also, because I don't know, I use WSL a lot because I use a Windows machine. But if you're using WSL, then there are a few more things to install to make sure it's all working correctly. Now, once I have Playwright installed, the next thing, I need to start writing Playwright code. And Playwright, by the way, has many languages. You can write it in Java, JavaScript, Python, and one more I seem to have forgotten. But I normally use Python. That's what I really care about. So I'll be focusing on that. So I'll start with something called a Playwright code gen tool. Let me just get things in order. Yeah. So Playwright code gen basically looks like this, also called the Playwright inspector. What it starts doing is it has a recorder, and it also shows me how I should start a Playwright application. Now here's the cool thing about Playwright is I can also have the different libraries. So .NET was the last one. So I can say I want to write this with Python using async Python. So it starts showing me all the async await kind of stuff. I can even say I want to do sync Python. Like, this is a normal old school Python without async IO, and it has libraries for that too. Or I can say Node.js or Java or whatever I want. I can actually just come over here and start looking at things at least in an easier way. I'll go with the sync Python because I'm normally just more familiar with that. So what we normally do is I can just go and record, and I can say here I'm going to start doing some stuff on the browser. Let's say go to cordoplatforms.com. Yes, internet seems to work reasonably well. So you'll see there is at least some code which has gotten generated over here, right? Now I'll go to a different tab, and you can also see some code is again getting generated at the back over there. You cannot read the code, I get that, but I'll come into what the code is doing. So as I'm interacting with the page, it keeps generating different kinds of things of how this will write in Playwright. Now again, Selenium and even Cypress have some tools which do this for you, but they're kind of like third-party extensions which sometimes work, sometimes don't work, sometimes are painful to use. But Playwright has it out of the box, which I really like. And this just helps me, now I'm fairly more familiar with Playwright, so I know all these commands out of in my head. But when I started out, at least this was really useful, so that I don't have to go into a documentation or ask ChatGPT how to do something, which didn't exist at that time. But I can just go and look at a recorder, and it can just show me what I should be writing. But the normal issue with code generation is that it's not easy to understand. So it just gives me a reference, and then I go and start doing my own thing from there. So let's maybe take a better example over here. So we looked at code gen, which is a good starter for most of you who are going to start out with Playwright. Let's start actually doing something with Playwright. Now a quick note is over here, I'm using the async API of Playwright, mainly because Jupyter notebooks don't support the sync API. But if you're using a normal Python shell, you can just use sync APIs, much easier. I normally write most of my code with sync APIs, just because it's easier to write code with sync, is my opinion. Again, don't get angry async IO fans. So what we start with is we get the async Playwright out. If I want to do this with sync, I just remove the A's. That's pretty much it for most of these commands. And I say, I want to start a new Playwright session. I'm going to have to run all of these. By the way, it also has the context manager if you want to write context manager stuff, which will clean up. But for Jupyter interactive stuff, I'm going to not use context managers. And I'll say I want to launch a Chrome browser. Now you'll notice this actually doesn't do anything. Internally, it has just gone and created a connection with Chrome. It hasn't really created a Chrome browser per se. For that, I need to create something called a new page with Playwright. So this is what actually creates a new page in Chrome, right? The blank page in this example. And here you'll see again, this is it's actually Chromium, it's not really Chrome. And it goes into incognito mode and all that kind of stuff so that I don't have to worry about caches and like already logged into a system. It gives me like a nice isolated environment for myself. Now, what I'm going to start doing, and I know you're not going to be able to read stuff. Can you guys still read? Is this okay? Yeah? All right, good. Because otherwise it will be tough. So I'm going to start running code on the right. Your right, yes. And you can see what's happening on the left. So the first thing I'm going to do is I already created a new page. I'm going to go to corridorplatforms.com, which is the same thing I've done earlier. So there's a page.goto which goes to corridorplatforms.com. It's loading, and yeah, internet seems to be reasonable, so it's able to load this page. And then I can also like start interacting with this page. The most basic one, which I always do, is you know the title in a Chrome, which is the thing which you show on the top, this new tab section. I'm just going to get the title and see if it is correct. Yep, seems all good. So I'm actually going to start interacting with this page more. Next thing that I would typically want to do when I'm doing browser testing and automation is start interacting with my DOM, right, which is my HTML code. So here is where, again, this is not easy to read. So let me at least increase it a little. All right. So I'm going to get a locator which says that the text is equal to facilitate innovation, right? Here is one thing I really like about Playwright and was not there even in Selenium for the longest of times. You have, again, some libraries in Selenium that do these kind of stuff is whenever you want to interact with a web page, there are two kinds of people who interact with web pages. One which say, I will go and find the exact CSS class and I will use the CSS class for my interaction. Or the other one which says that I'm only going to look at the web page as a user, right? Because the user is not going to know which CSS class is being used for which DOM and all that kind of stuff. I only know what is actually shown to me. And I'm going to start interacting based on it as a user. I normally go towards the latter, at least for browser testing, because the important thing is that there is a button called click here or submit, right? The important thing is not that that button has a style called something like .click here or something like that, or an ID or a class. So I always interact it as a human, and Playwright has some pretty nice stuff for interacting with browsers as a human. So I can just say, find the text, facilitate innovation. So if I run that, you'll see that it's giving me a list with two locators in Playwright, which is going on to that URL, and the selector is text, facilitate innovation, nth equal to 0, nth equal to 1. So the first item and the second item of this text. Now if I go through this page, you'll see, okay, so facilitate innovation is present here. Interestingly, it is present in two places. So there are two items which are coming out. I can also do an additional, like I can chain my selectors in Playwright. So I can say first I want to look at text, facilitate innovation, and then get the first item. So this will only give me the first item. Well, in this case, it's showing it to you in this way, but you can ignore that for now. I can start chaining my selectors in nice ways. But that doesn't mean that I cannot do CSS. For those of you who like CSS and all, you can also write CSS code directly over here. So corridor mission card item is the name of this card. So I can say, I want a card which has the text facilitate innovation. And this is an operator which, at least I've only seen in Playwright. I don't think it exists in Cypress or Selenium and stuff. It basically says, first run this selector, and after that, or inside that, run this selector. So I can actually mix and match my CSS and text and user-driven stuff quite easily, which is something I really like about Playwright. So this is another way of getting the same text, which says, get the selector, and there are 4 items with the selector, or 3 items with these cards. Get the one which has facilitate innovation. And for those of you who also like XPath, you can also use XPath. Again, in my mind, at least XPath makes it even less readable than CSS, so I don't really use it as much. But you can also use XPath and then do class contains and all of these kind of stuff if you want to. Right? So the cool thing about Playwright is it does all the stuff that Selenium has. Selenium mainly has XPath and CSS out of the box. But then you have some stuff like bytext and all these other functions which Selenium and even Cypress provide. It's just that Playwright provides it out of the box, which I like a lot more. Now, once I have my selectors, I'm going to start performing some actions. So I have a locator, and I'm going to say hover. So you'll notice that we have this cool animation for hover. So if I want to do the same thing in an automated way, I can just say hover. You'll notice it has hovered on the back, right? In case you didn't see that, just repeating it, it became a little bigger. So I can do hover animations. I can even do click and other kind of actions which I may want on top of it. We'll just come back to it in a moment, right? You can also do some pretty cool kinds of selectors. I just wanted to show this, is because in my mentality, at least, if I always want to do user-based finding of things, many times what a user would want to do is, let's say if I want to click on this learn more, right? Learn more is there many times. So what can I do? Should I do learn more? Give me the first learn more. What I would want to do is I would actually want to say, I want to learn more about connected design, right? This is kind of painful to write in Selenium, but in Playwright, what you can do is, first you can get the text equal to connected design. So you can find the card which has connected design. And then you can also say, I'm going to just enter it here. Then you can also say, get the text learn more, which is near another text called connected design. And that's something I find pretty cool, because if I have many things like submit, 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 I can know what am I submitting. This kind of stuff makes it easier to find things that you want to actually click on or do actions on. And that's just something I like. And again, there are many different norms. You can have near, you can have left, right, sibling, child, different kinds of, all of these are called layout selectors. Selecting based on a layout. Apparently my link is wrong, I don't know why, but I'll fix it later on. So you have layout selectors, and near just means give me the closest thing called learn more, which is closest to connected design, right? So you'll see it has all these high level things that users would want to do, but I can automate all of that kind of stuff. You can also take screenshots, which is a very popular thing people do for like debugging and stuff. So you can take a screenshot, you can open the screenshot and just look at how the whole thing looks like. So all that stuff is like pretty trivial. I'm just going to skip that. Now, the next one, which is very important, is actionability, and hoping this link at least works. Yeah, looks like it works. So what you want to do is, you want to go to a page. Like, I'm not going to go to Corridor More, I'm going to actually go to hotstar.com. Now, the thing about Hotstar is, you'll see it's a very dynamic page, right? Like different parts are loading, and a very scary screen for some reason, but different parts of it are loading, and it's not like I know when this whole thing is loaded. Right? Because Hotstar is a very JavaScript dynamic website of the current world. So what do I do in such cases? Normally, if I'm going to do something in Selenium, what I'll go do is I'll go to that page and then I'll do a timeout. I'll wait for 3 seconds for the page to load, and I hope the page loads in 3 seconds, and then I'll do the next action. Which, I was very worried about these kind of demos if I was going to do it in Selenium, because I don't know how much time to wait for these kind of stuff, right? Like especially in a slow internet like my mobile hotspot and all, I don't know if that's really going to, 3 seconds is going to cut it or not. So what you can do with Playwright is, because of the actionability checks that they do, which is also called auto waiting, and again, you can't read that, so let me try zooming in. Yeah. So what it will do is, let's say if I do an action called click, it will internally go and double check a lot of things. Is the event, or is the DOM element that I want to do the click on, is it attached to my page? Like has it actually been rendered? Is it visible? Or is it like in the scroll screen below? So in that case, it'll automatically scroll for you and then click on it. Is it stable? Like it'll wait for a few milliseconds to see if that thing is like dynamically changing a lot. Enabled and ready for events, and all of these kind of checks which it does for me. So let's say if I do a goto statement, you'll see over here that my goto will run very fast, but it's not ready to get clicked yet. So it waits for my action called sports, like the icon for sports, before it clicks on sport. So that kind of stuff is really useful in Playwright, like all the sane defaults, right, of waiting for things to run and all these kind of stuff is all available out of the box. Now, again, I'm running out of time, so let me just show you one more thing with Playwright, which I find really cool. I'm going to close the page, and I'm going to create a new page with tracing enabled. And when I do tracing, I can have screenshots and snapshots and other stuff traced along with Playwright. What does it mean? So I'm going to enable tracing. I'm going to create a new page. I'm going to go to Hotstar, and then I'm going to click on that thing. So you'll see goto is completed, but click is not yet tried. It was waiting for the click icon to get visible, and then it did the click. And then I'm going to stop the tracing. So what this will do is it will go and create a trace.zip file over here. And again, Playwright has a function called show trace. It's basically like a screen recording, all right? Like for those of you from Selenium who've seen those video recordings, it's kind of the same, but it's a lot more powerful. So it has the entire recording. It says nothing happened, then the browser started doing something, there was a loading icon, and then over time, this thing got loaded, something else got loaded, and then a click occurred, and so on and so forth, right? So it actually gives me the entire event timeline of what's happening. And for each of the actions, I can go and see what is Playwright internally doing. So when did the click action occur? At this point of time, you see the red dot, that's what Playwright clicked on. And you can also see in the logs that it waited for the selector to come in, it resolved something, it attempted a click, the click was not possible, so it again did some scrolling, and then it again attempted a click. All of these kind of things that Playwright is internally doing for me. So with this kind of stuff, I can debug what the problem is a lot better. Like when I do a click in Selenium, it just tells me unable to find element, right? And then I put a timeout, and then I hope it'll work. And I keep doing this again and again. But with Playwright, I can see exactly what check it was trying to do, which did not work. I can also see the network logs. I can also see console errors if it's all linked to some control error. So I can get all this information easily, and it's all nicely recorded for me. So when I send some kind of stuff to automated testing with headless browsers and all these kind of stuff, I can see this if something failed. Right? So tracing is super powerful in Playwright. And I won't go into this stuff, but it also has the low-level functions. So 3 things that we've mainly spoken about. One is the fact that it has high-level functions like click. And when I say high-level, it'll do a lot of stuff for me. Because as a human, when I go and click on something, I would have tried to find it on the page, right? So Playwright is also trying to find it on the page for me. The next thing that it does is it can trace all this information so that if something did go wrong, I can go and check what happened and understand that with a keener eye, right? Better than just a video recording or so. And the last one was, if I really want to go to the lower level stuff, like I want to do keyboard events, like, they have something called fill, which will just make sure I can fill some input box. But if I want to go low level stuff, I can also do type and pressing and all these kind of stuff. So I can get the whole power that Selenium would provide. So coming back, Playwright is pretty cool. Some of the things that we already spoke about were auto waiting is nice, easier debugging with tracing and stuff. And all this stuff about async APIs, sync APIs, just give me a lot of options, which I would really like. Most of you have not heard about Cypress, but Cypress also has a lot of these things. But Cypress is an async-only framework, and it's only JavaScript, so JavaScript plus async. But Playwright gives it to me in Python, it's just much easier to write for me. And I can also now link it with all the other tools I have, like PyTest and other stuff if I'm doing browser automation testing, which has helped me a lot in terms of easily writing out my browser testing. That's about it. Again, I know I'm a little out of time, but any immediate questions, or we can always meet outside. Yeah, go ahead. You can just say it. I think I can hear you. I see. So your question is, with Selenium, your major issue is versions of browser. Do you mean like Chrome versus Safari or Chrome 100 versus 102?
Chrome 100 versus 100. You see, it's mostly like, for example, I have a QA, so I have right now like 3 Selenium projects and 1 of Playwright. Playwright was more or less sorted with Jenkins and all of that integration. But in when I did work with the Selenium, I had a hard time installing Chrome and then a Chrome driver, then debugging on with all of the versions, and it would work for 10 days and then break it all of a sudden.
Yeah, I mean, I have never had that problem, I guess, because luckily, I guess we just assume Chromes are updated. Maybe that's a bad assumption, but I guess we're just assuming Chromes are updated. But I have not really I've never tried multi-version testing, to be honest. But what I will tell you is, because Playwright is installing the browser for you, whenever you do Playwright install, I've never had a situation which says that this version is not working or any of that kind of stuff. Now, I don't know if Playwright install can install multiple versions of Chrome and then make sure they're all working. I've never tried that myself.
Well, actually, it is not with the script that is doing. It is mostly the breakage between or you can say the driver and the Chrome itself.
But that's
the
where
Chrome Debian's package and the driver in the Selenium. They mostly break, and they would say this is not working, this is not working, which is completely irrelevant to the code.
Fair. I get what you mean. Yeah. I get that. Makes sense. I see.
To specially install that old version of Chrome and get it to work somehow. That's what.
Again, I've never faced any issues. Like what I understand is that Playwright has their own variant of the web. They don't use WebDriver.io and stuff. So when it does Playwright install, it installs its own variant or fork of Chrome, which has some of these automation libraries that it is expecting on the Chrome side. So a quick note, I cannot use Playwright with my Google Chrome, or I can, actually I can. I can use Playwright with my own installed Google Chrome, but then I need to figure out the versions and all that stuff to make sure it's working correctly. But with Playwright install, it just installs and manages the entire thing for me, which could be the drivers, the client, and everything. So I've never, I've installed it in at least 100 laptops by now. I've never had any issues in terms of version compatibility issues and so on and so forth. So maybe because it's installing its own Chrome, but again, I don't know. I've never had the problem. It'll be good to hear feedback from you guys if you try it out. Any other questions? No, we're good. All right. I think that's it.
That was an awesome talk. I would like to ask Gora to come and present Memento to Mr. Ali. Can we have another round of applause? I've always enjoyed Ali's talks. So yeah. So I hope all of us are having a nice time here at the Python conference. And it may come as a shock to some of you if I told you that we also have some Rustaceans among us. So bringing on to the stage, Tushar and Ashwin, I know both of them by their involvement in the open source communities and contributions. So please welcome them for their talk for Rust for Python developers.
Right, yeah. Window. Yeah. Just a second.
Can you fill this form out?
What is the
It's a speaker consent form.
we already filled it yesterday. Yeah. Yeah. Where did that go?
Permissions
Permissions. Need to do it again. Window. Yeah. Hello. Single window. Center. Sure. What? Okay.
Controller, right?
Hello.
Well, so we're here at the Python conference to talk about Rust. And there are good reasons, and we hope that we're able to sell you on the idea of the language. Okay, so before we start, we have a QR code here on the screen, just so you can open the slides on your laptops or your phones. There's also a link below the QR code. I would recommend you open this because we have some links and code that you might want to look closer at or click. Okay, assuming that it's done now. Before we start, a bit about ourselves. I am Tushar. I'm a senior computer science student at the moment. I'm a generalist developer. I've written code in both Rust and Python professionally in startups and a lot for open source projects. I'm also a co-organizer for Rust Delhi, which is a Delhi-based community for Rustaceans, i.e. people who like Rust. I'm on Twitter and I have my own website, so those are below. And I also have a co-presenter, Ashwin, please.
Hello, I am Ashwin, and I mostly work on web dev stuff and use Python to automate tasks and for CI/CD. I also write backends in Rust and love new tech and learning about new things.
So we're at a Python conference and we know Python is awesome, right? And we've had a lot of talks yesterday and today that talk about how awesome Python is, but it's not a perfect language, okay? So I won't jump into why Python is good, but we will talk about why Python is not. Two reasons that are big for me. First is performance. It's a high level interpreted language, which means that performance isn't exactly its forte. In fact, a lot of core and third-party Python libraries have their performance-sensitive code written in C or some other compiled language like Fortran. Also, Python has something known as the global interpreter lock, which doesn't let you write truly parallelized code unless you rely on multiprocessing, for example, which has its own drawbacks. Enter Rust. It started as a personal project by Graydon Hoare, who was an employee with Mozilla back in 2009. Eventually, Mozilla ended up sponsoring Rust for the development of their server browser engine, which went into Firefox. Despite its humble beginnings as a personal project and then a browser language, it ended up being a multi-paradigm general purpose language that's very popular today. It has an emphasis on speed, memory safety, type safety, and just giving you the most awesome developer experience you can think of. It has perhaps its most important contribution to the world of popular programming languages, its ownership model. It's a novel solution to memory management where neither does it rely on a garbage collector nor on reference counting, and definitely not on manual memory management that is like free and mallocs that you see in C and C++ sometimes. Rust is also very expressive, which for me is the best part about writing Rust as a developer. It lets me think about my domain and model it very succinctly with its type system. And it has functional APIs that let you write really elegant code. Rust is also loved. As recently as the 2022 Stack Overflow Developer Survey, Rust was admired by a whopping 85% of the survey developers compared to Python 67%, which is awesome. And it has been that way for at least 7 years now, ever since Rust 2016 general release with its 1.0 version. Now, I'm sure a lot of you have seen Rust on your social media, Twitter, for example, even on LinkedIn. And you might have wondered if Rust is a fad. Well, here are some facts. Android 13 has Rust. approximately 21% of Android 13's new code is written in Rust. In fact, parts of Microsoft Windows are now being rewritten in Rust. This was since 2020, and now if you use Windows 11, it's likely that you have Rust code running on your laptop right now. It's also the second language to be introduced to the Linux kernel, which is a big deal because Linus Torvalds hates on everything. He hates C++, and he hates anything that's not C, but he let Rust into the Linux kernel. Discord switched to Rust from Go in 2020. In fact, now a large part of Discord's infrastructure is written in Rust, which is because they wanted performance. Garbage collectors are not ideal for a high-performance environment because of CPU spikes, right? So your garbage collector takes CPU cycles away from you to clear up your memory, which also means that there's a delay between when you actually stop using an object and when the memory is freed up, and you pay a performance cost. Modern Python libraries are being rewritten in Rust. At least 2 libraries that I know of are very popular and written in Rust. One is Polars, and another is some of the libraries by Hugging Face. So with that being said, I think we should jump into see some of Rust features and how it's different and what makes it stand out for Python developers. Welcome, Ashwin.
So let's look at a few examples, few things that sets Rust apart from other languages. The most prominent of which is the developer experience for Rust. Starting with the compiler. The compiler itself tells you where the mistakes are and helps you with opinionated suggestions on how to fix the errors. Clippy is Rust's linter, and it also has a built-in formatter which allows you to set good standards for your code base. And it also has a built-in documentation generator which you can use which uses your doc strings to generate documentation websites. And the RustUp toolchain, similar to the PyEnv, allows you to select which version of Rust you want to use in your current project. It also has a built-in testing framework which allows you to easily write tests and make sure your code keeps working. Moving on with more language features, in Rust being a multi-paradigm language allows features from many other programming languages, including functional patterns which allow you to easily manipulate your data and use it. And another very important feature of Rust is its take on error handling. Starting with its lack of use of nulls. So Rust doesn't have nulls. Instead, it uses something called an option enum, which you can return from a function, which means it can. I don't think so. I mean, they already have the slides. Like, we gave them the link to the slides. Yeah. So, yeah, just that one. Yeah. So, instead of nulls, Rust uses an option enum, which means you can, which means a function can either return something or it can return nothing, which the compiler makes you handle explicitly. So you can't mistakenly have null pointer errors in Rust. Similarly, Rust also has a result enum, which means you can have errors as a value. In other languages, error handling is done through exceptions, which when an exception occurs, it throws you out of the current context into a catch statement. But in Rust, you can have, by having Rust errors as values, you can pass along the values to the calling function, or you can handle them explicitly in place. And if explicit error handling is too verbose for your taste, you can use the question mark operator to automatically bubble up the error to the calling function. Safe Rust code also ensures that your code doesn't have any race conditions thanks to the borrow checker. The borrow checker ensures that the same data is not being modified by multiple scopes. So in this example, the same data vector is being modified by multiple threads. But this is unsafe, and the compiler lets you know that it is unsafe. And so when you have the data behind a mutex, and all the threads are properly locking before modifying the data, the compiler knows that this code will not have any race conditions anymore, and it compiles successfully. Rust also has pretty good meta programming features. It allows you to extend the language and write domain-specific languages like HTML, as in this example, right into your Rust code, which allows you to make front ends and many other domain-specific things directly in Rust. Okay, so Rust safety ensures that you don't forget about cases that can occur in your application. So in this example, we are setting the state to connecting, but we are not handling that particular case. So the action variable stays in an undesired state. But if you do the same thing in Rust, the Rust compiler will error and will not compile unless you handle all the possible cases or explicitly ignore the case. Staying with the theme, the Rust compiler the Rust language helps you write code in a way that makes invalid states unrepresentable. So in this example, if a function accepts a color, if you take the input as a string, the string may or may not be a valid color. But if you write it in Rust through enums, and you can have explicit types on what type of color and what possible states it can have. So all the possible states that can be represented in this code are all the valid states. This removes the requirement of having runtime error handling, and if your code compiles correctly, it will not error at runtime. Now, I would like to invite Tushar back to let us know how we can learn from Rust and write Python code more like Rust.
Thanks, Ashwin. So we could go on and on about Rust, because barely scratch the surface. Rust has so much to talk about, and Rust has so many features, and the ecosystem is massive. But to its credit, the Python ecosystem has also been evolving. If you look at the past 3 or 4 years in Python development, starting from Python 3.5, we have a lot of new features that would let you write Python more like it's Rust. And that's a good thing, because Python now has a type system. The Python ecosystem now has good package management, finally. And these are things we can learn from. These are ideas we can borrow from Rust and have in Python natively with a good developer experience. So let's talk about the first of them. Use a good package manager. Here's my suggestion. Poetry or PDM are really good package managers that adhere to the pyproject.toml spec. It's a PEP, I believe. They let you declaratively manage a project that includes versions, the name of the project, and everything that comes with it. If you've ever tried to publish your Python application as a package or use relative imports, you might have run into an issue where you need to have the project as a package. Now, packaging a Python project involves at the least writing a setup.py file. You don't get that for free, and it's a lot of boilerplate, to be honest. But this also means that you are not natively declaring your Python application or its contextual meaning anywhere else in a standardized place if you're not using a package. Enter the pyproject.toml file that solves this for you. You get all of your dependencies declared in the same file as you would your project name and all the other metadata that comes with it, just like you would expect in Rust with its cargo.toml or in JavaScript with the package.json file. You also get zero effort isolation, environment isolation, right? So I'm assuming everyone here has used virtual environments, right? So virtual environments are great, but they are a lot of work. You have to create a virtual environment, and then you need to remember to activate the virtual environment and deactivate the virtual environment when you're done using it. However, if you're using a tool like Poetry or PDM, they do it for you. So you never need to bother with actually activating or deactivating the virtual environment or face problems when you forget doing any of those things. You also get log files. Both Poetry and PDM have log files. However, PDM's version of the log file is better since it actually hashes your dependencies and makes sure that your dependencies are in a valid state and you can reliably reproduce what you have working on your machine on other machines and in production. No more it works on my machine. Next up, use a type checker. Starting with Python 3.5, Python now natively supports type hints. This doesn't mean that Python is a statically typed language all of a sudden, of course. These type hints are totally ignored at runtime. However, you can use a type checker in your IDE, which you probably already do if you're using Microsoft's official VS Code extension or a good LSP. And also you can have it in your CI. What this means is you get to catch errors like you would with a compiler before your code ever goes into production, which is good. Let's look at an example of how this helps you, right? I've got a function here called defsearch that takes in 2 parameters, and that's all I can see in the code and my IDE if I have just this code without type hints, okay? I have some questions. If I look at this code, I don't know what the actual type of the records parameter is. So if I were to use this function, I would have to look into its implementation to see what it's expecting and what the type of the thing should be, right? I also don't know what check should be, and I also don't know if this function is returning anything or what the contract of this function with the caller is, right? Enter type hints. The same function with type hints lets you annotate all the parameters and also the return type to be explicit that records is a list of the record type, which is a type you probably declared somewhere earlier in your code base. That check is a callable that takes a record and returns a boolean, which now with the semantic meaning and the context added by the parameter name makes it very clear what it's doing. Also, you have a return type annotated, which says that it returns an optional record. An optional is very much like the Rust enum that Ashwin discussed earlier, and it lets you be explicit that it can be a none or some value. And also, the handling of this optional value will be enforced by a type checker, so you can catch the same error, just not with the compiler, but a type checker. Next, writing Python classes can be hard. Let's imagine a scenario where you were to write a Python class just to store some data. Now, it's a lot of boilerplate. You have to write an init method to initialize your class, and you have to write at least the representation and the equality magic methods for to be able to print out your class or stringify your class in some meaningful way, and to check equality between different instances of the class, because otherwise it wouldn't work, right? So, of course, we don't do that. We don't write classes to just store data. Instead, we do something like this. Either we return tuples, I've done that, or we return dictionaries. I've done that too, because Python was one of the first languages I ever wrote code in. Okay. Now this is good, but both tuples and dictionaries have problems, right? If I look at a tuple, I can see that the function is returning multiple values, but I can't see any semantic meaning behind those values because there's no descriptor like you would in a parameter or a dictionary. The dictionaries solve that problem. You have semantic meanings, but you don't have types again, so you lose something, and you lose, and you also don't have the number of return values. That's something else you lose. Fortunately for us, there is a solution, and now it's built into the Python standard library. Enter data classes. With a simple add data class decorator, you can have this decorator write all of that boilerplate for you, so you can just focus on the code and focus on this, what you're trying to express, like you would with Rust or any other sane language. The same definition that we had before with the tuple and the dict boils down to a wallet specs as defined here in the code. I hope you'll see. Next up, emulating ADTs. Earlier, Ashwin showed us an example of an abstract data type in Rust. Abstract data types lets us combine product and sum types to express a complex type, because not everything in the real world is expressible with a simple type that contains a number of values, right? Sometimes there's an OR relationship between type. Let's take an example of a payment method. Let's say you're implementing some form of a backend for an e-commerce website or a digital store where you can take in multiple types of payments. Now this payment can be a credit card, of course, but it can also be a third-party wallet, maybe a PayPal or Paytm or something. It can also be a bank transfer or maybe COD, cash on delivery, right? It's not a simple type because each of these different values have some other information associated with them. For example, with Paytm, you might have the user's number and you might have some authentication token or something. With a credit card, you'll have number, the CVV, and all of that, the expiry date. With a cash on delivery method, you'll have nothing. So you can't store it in a simple data structure unless you apply some runtime logic to check for what kind of payment method you're dealing with. However, with an abstract data type, you can express this simply in a single type with a union joining all of these different concrete types that you would usually write. Complete with the new match statement introduced with Python 3.10, you can write really elegant code that lets you express logic that you would in probably 3 or 4 times the number of lines that you see here, and also ensure that you're exhaustively checking all the different data types that this abstract data type can contain, which is again very much like Rust and helps you write better code. I should also mention that this match statement here can help you match structurally on items just like in Rust. If you don't have the context on that, it means if you have a complex value, let's say a class that has nested data inside of it, with a match statement, you can destructure that data inline and get values out of that. It's very powerful and lets you write less code. Next up is new types. If you've ever written functions that return primitive values that don't have any semantic information attached to them, you might have found yourself mixing them up while calling some other function that takes in those same data types. This is less than ideal, but fortunately Python's typing module again has a solution for us in the form of new types. New types mask other types to create an opaque type that contains them. This lets you return different types from the functions that would otherwise return the same type and helps you avoid bugs associated with mixing them up or using them the wrong way. Using regular functions and constructions, if you've ever written code like this, because, okay, Python, first of all, does not support function overloading. It also doesn't support object overloading, constructor overloading. So this means that if you want to initialize an object in multiple ways, you would have to resort to using dictionary arguments or variadic arguments, which now means that you need runtime logic to see what kind of function call it is, And this results in some ugly code. Now, to be fair, I've been told by some Pythonistas that we're about done, that the code can be better, but again, this is how I would imagine this could be. Enter how you would do it in Rust. You can just use regular methods as constructors instead. So you can have a method just for regular construction, and you can have a method for construction from another type or another set of values. And then you can also avoid implementing the magic init method by using a data class, as discussed, as I showed you earlier. Now, variants can be encoded with types. Let's say you have an object where not all internal states of that object support calling some functions on that object. Here's a client object that is kind of like that, right? So I can't send message on a client that's not connected or authenticated, for example. You can instead use the type system to represent this information, so you can avoid bugs with misusing the object, because with types you won't have those method calls at all. There are also self-releasing mutexes. Now, this is something I think we can skip over, but again, in Rust and other languages that support an RAI API like C++, you can have automatically drop objects when they go out of scope and call functions as some object goes out of scope, right? In Python too, fortunately, we can do that with the context managers like you would with files. So you can use something like this, and there are libraries that can do it for you also. Now, the last thing I want to discuss, and this is perhaps really important and drives our point home, is interoping Rust with Python. I discussed earlier how some of the newer Python libraries are actually written in Rust, like they would earlier be written in C or Fortran. It's actually really easy to make this happen for your own applications. It starts with two simple components. First is PyO3. These are Python. These are bindings for the Rust compiler with the Python interpreter. And second is Maturin. It's a tool that can build Rust crates into Python wheels. The Rust side of things looks very simple. So you can have these translator functions that call your actual Rust functions, return Python types, and then you can just use some decorators or attribute macros to declare them as Python modules or Python functions. Here we have made a Python function and then a Python module that exposes this function to the outside world. And then you can use Maturin to compile this to a Python package and then use it from Python. And it just works. Not too complicated. Well, this was everything we were going to cover today because of just how little time we have. But for a recap, we saw that Python is a modern expressive language that has really strong guarantees, and you get a good developer experience out of it. Lets you write better code. We also saw that the Python world can borrow some ideas to fix prominent issues and make the overall developer experience better and just write better applications. We also saw that the Rust and Python interop scenario is very practical at this point in time, and there's good tooling around that. We also have some resources for further reading if this talk got you interested in Rust. There's the Rust book, there's Rust Links, which is a series of exercises developed by the Rust team to learn Rust, and there's also, for you professionals out there, Zero to Production Rust by Luca Palmieri, which is a very authoritative book on getting your Rust code out in production. And that's it. If you have questions, we are open for answers, but that's only if you have time. Sorry, we don't have time.
Thank you, Tushar and Ashwin, for this talk. I would now request Gora to present mementos to our speakers. Yeah, I think you can take up questions after in the break or after the, they're out of the stage and we have the talk. All right, next up we have a talk on for the people interested in monitoring or logging, and we will have our next speaker Yuvraj Singh over here. He's a Python enthusiast, he's also an AI ML enthusiast and backend enthusiast, and he's also a music producer. So please welcome a man of many talents, Mr. Yuvraj Singh Patania.
आप मीट में जाओ, स्क्रीन शेयर, स्टार्ट, वही जो भी करना है, लाइक whichever works.
Why does the window show up? Wait.
I guess it is because of different entire screen कर लो, आप बीच में बंद कर लेना जब आप कुछ करना हो sensitive.
एक second. I need to have some notes. That's not necessary, but I'm not sure. एक minute, I'll open Canva here. I mean, yeah.
Yes.
Is it coming up? But so works. Just wing it.
Sure. So push.
Just think for the
Yeah. Let it.
While we set up the next talk, I would just like to ask the crowd here. Like, obviously, we are to some level familiar with Python, which is why we're here. So, as a quick survey of sorts, could people raise their hands to tell if Python was their first language, or was it something learned afterwards? All right, so that's 3 people. 4 people from those listening, which could be a small sample space, but okay. I was expecting more, but I guess I managed to hatu upar nahi kara. Like 5 now. And are we ready? Yep, we're ready. So please give a huge round of applause again to Yuvraj. Yes. Right. This or this? If you I'll take the mic then.
Actually, is this okay? Is this audible, right? Yeah. Okay, good afternoon, everyone. Today's talk is going to be about building a multi-client log streaming service. I know it's a mouthful, but we'll unwrap all of these step by step. Before moving on, just a little bit about myself. I'm Yuvraj. I'm currently working as a software engineer at a cybersecurity startup called CloudSec. I'm into backend AI, building scalable systems. I read a lot about that stuff, and that interests me currently. I produce music while my models train. Well, I do produce music on the side, and you gotta do something while your models train. So this is a nice hobby I enjoy. And I've also been a community manager at Google Developers Student Club at my college, which was VIT Vellore. I believe GDG, Noida, New Delhi are community partners. So of this event, I'd love to connect with some of the folks from there as well. All right, moving on. This is the talk outline. I'm going to try and explain certain keywords and concepts which are going to be necessary for all of us to understand how such a service is supposed to be built, and it's just so that everyone is on the same page. Next, we'll understand the technical issues which are associated with building such a service, because building something is as important as understanding what issues can come up during the process. And I'll also then talk about the architecture which we'll set up. We'll go over high level stuff, and then I'll also like to present a demo of this service, and hopefully that goes well. Post that, we'll explore alternative solutions to set up such a service, because as engineers and people who write code, it's important to explore all solutions, because anytime you want to optimize or you want to fix something, it's important to get a holistic overview of what exactly is going on. And then if time permits, I'll open the floor for some questions. All right, moving on. So let's talk about logging. I'm sure all of you are aware of what logging would mean. It's basically recording and storing events in a file, be it observability platform like Grafana, Loki, or whatever you're using. I believe logging is definitely very important. Otherwise, no logs, no evidence, because it's really important to audit and actually understand if something breaks. So that's logging. Then, okay, real time. Real time, as the name suggests, is trying to deliver information or data to a client or some sort of service as soon as an event happens. So in the case of a log streaming service, what that would mean is, as soon as a new log is generated, let's say we are using a log file, as soon as a new line is added, and if a client wants to know what's the line added, it should be in real time. That is, there should be no delay in which in the time frame where the log was generated to when it was read. Okay, multi-client. Again, these are straightforward words, but they can get so complex that we can have entire talks on them as well. But just for the sake of this specific service, multi-client would essentially mean that we'll have concurrent clients who can actually stream these logs and actually see how logs are being produced. So the whole idea is concurrency here, and the aim of such a service would be that all these clients are able to experience real-time concurrency. Okay, async. Again, async is another popular keyword. So I have a little meme there I found it pretty funny actually. So yeah, the guy is trying to cheat and he gets a response that the person will share the answer when he's done. So that kind of captures the essence of async. So async again, it's a different programming paradigm. I'm sure some of you are aware of the term and have used it in a couple of services that you've built. So the basic idea of async is that it allows APIs to be non-blocking. So better way to give you an example. Say you have an API endpoint and that endpoint does a DB query, and if you have multiple requests from the client and your API is still expecting a response from the DB, if it's a synchronous flow, the API would stall or wait until it gets a response back from the database and then move ahead. But in case of async, what it can do is it can await the response and continue with other processing tasks or whatever it's doing, and then move on. So it's just a quick explanation of async. And again, so now we come to the most important keyword here, which is called server-sent events. So just a raise of hands, how many of you have heard of server-sent events before? All right, bunch of you. Okay, so server-sent events, spoiler alert, that's the web technology which we're going to use to actually build this service. So the way I came across this sort of web technology is because I was researching about web sockets, and I thought, what if I need a protocol which only works unidirectional? Say I only want to send data from a server to the client, right, and not say bidirectional. Well, in that case, server-sent events is the best possible web technology I believe out there. And we'll go in more depths of this as we proceed, but for now you can imagine this to be something like a unidirectional WebSocket, even though that's not 100% right, but that would do for now. What it essentially means is that there'll be a single HTTP connection between a client and a server, and as soon as there is new data available with the server, it pushes it to the client. That's one way to understand it. Again, so the next thing which I want to talk about is generator functions. So I'll quickly go over this because this would actually be used in building this service, as I'll show you later. Generator function is a special type of function, you can say. In it, that it doesn't really return, it doesn't use the return statement, it uses something known as the yield keyword. And what happens is that it basically, instead of using an direct output, it returns an iterator, and that iterator you can iterate over basically. So say it returns an iterator, and then you can take that object and basically on demand get the data that you want from that iterator by essentially iterating over it. Okay, so let's go over the high level architecture now. So I hope all the components are visible. So what we have here is, first of all, the larger rectangle you see, that signifies the server. Inside the server we have a bunch of things. There's of course an API endpoint which I've denoted with like a square box which looks like a CPU. There is a log generator, and there is a log file which the log generator writes to. So I'm trying to like emulate a log streaming service, and the assumption is that logs are continuously generated and somehow passed to the server. Now I'm not covering the you can use this sort of approach with any sort of data source for your service. It can either read from a log file, it can either expose an endpoint where you're pushing logs. But for the sake of this demo as well as this presentation, what I've done is I have set up a function which infinitely runs over a loop and adds new lines to a log file. Now, there are 3 clients which I've shown here for the purpose of showing multi-client features. What it's doing is that there's an endpoint which I've defined, and the clients send an HTTP request to that endpoint, and server-side events does a beautiful job of maintaining a persistent connection. Now, what happens is that with the same HTTP request, the logs would be streamed concurrently from this file via that endpoint to the clients. Now, if you've not completely understood this, I'll show you the demo and then things will be much clearer. But this is the high-level architecture of what we're going to build today. Okay. Again, to summarize the major components, again, there's a server, there's a client, and there's a log generator. And basically, the log generator is writing to a log file, which the server has access to. The server reads these logs in real time and streams it to the clients which are connected to the server at that point in time. Now, if you notice, this is actually sort of similar to a pub-sub model. For those of you who would be aware about pub-sub, you can basically subscribe, that's the word, to an endpoint and then stream data. Now, in this case, the streaming is powered by server-sent events. And the interesting part is that, the HTTP connection, a single HTTP connection will stay alive for as long as, either the client destroys it or there is no data on the server side. So, okay, now actually let's try and understand what SSE can do for us. So, a very simple way of understanding how SSE works is there's the client requests. Again, so I think what will help you understand better is some examples of SSE. So, let's say Instagram sends you a notification every time your friend puts up a story, or every time someone creates a new post, or let's say notification, right? You need to check where your Zomato order is, or your Swiggy order, or any food delivery for that matter. And notifications is one of the most common application of server-side events, because the way this happens is that only the server is sending the data to the clients, and only this is the requirement. It doesn't need to be bidirectional, and it doesn't need to be something like, I'm constantly sending request to a server to understand what's up, and then the server responds back. It's not like that. It's pretty much more useful, because the client does not need to worry about, at what intervals should it query the server, or, something like this is, I'm talking about long polling essentially, for those of you who are aware. So anyway, the client sends a connection request to a server, and a connection is established. Once that happens, using the same connection request, which stays persistent, every time there is new data with the server, it will send the event to the client, and this is how the communication happens. And once there's a timeout, or if you can set up a timeout, or if you want to close the connection, that can happen. Now, this is like a template for a single event message. So every new event, you can imagine this to be an object, new event, which has these parameters. It has an ID, it has an event, and it has data. Now, how this ID is very important is that server-side events actually allows you to keep track of what was the last information you sent. So for example, let's say you are streaming logs, and at some point in time your connection drops off. Now the next time you subscribe or call that endpoint, it will have the you can actually configure an endpoint to look at this ID and then pick up logs from that particular ID as well. So what I'm trying to say is that it will allow us to pick up from where we left off. And also, so yeah, that basically means that it automatically handles reconnections. And below I've mentioned a curl request. I hope everyone's aware with curl. It's a command line utility tool to make HTTP requests. So this is one of the ways in which you can actually query that endpoint. So right now you can see that there's a endpoint called stream logs, and usually how you'll just a simple curl request would not include all these extra parameters, -n, -lv, the headers. You don't need that, but why I've put them up is to make you understand that the way server-side event works is that you need to pass in the header called text/event stream. This tells the server that it needs to send an event stream to the clients. And if you look at the -n flag, that basically means that it should not buffer the output. It should directly send data to clients as soon as it's available. Okay. I've been told I've got 10 minutes left. I'll quickly try and go over the demo now. Okay. We'll come back to the rest of the slides in a bit. So I'll just reshare my screen again. Okay. What I'll do is I'll run the demo first and then show you what's happening. So I have this Docker container I'm running API server in, and this will listen for hello. 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 Yeah, it's back on. Is this working? Yeah, sorry about that. Yeah, so event source response, basically how you can understand is that it converts the generator object into server sent event signals. So if I look at the definition of this function, what it's doing is very simply it's tailing a particular line, and by that I mean that if you have I hope you guys are aware about the tail command in Linux. So this is very similar to that. What's happening is that with the tail command, I am essentially iterating over every new line which is being added to the file, and then I yield the line. This is again a generator function. So what this would do is it would pass the generator object here, and then as soon as I have a new line added, it would send a server sent event via this class, which wraps around the event generator and sends it as server sent event as soon as a new line is added. That's why you see this data being pushed to the client as soon as it's available. One more thing I want to quickly show you is the other endpoint I have for is existing logs. This is basically for reading all the logs up till now and then coming up to speed. How these two endpoints differ, streamlog and existing log, is streamlogs would push the logs to you from the point in time when you created a HTTP connection with the server. It won't bother about the previously existing logs. Now, for any good log streaming service, you should also have the availability of clients to look at previous logs as well. So for that purpose, existing logs is there. And the way I'm showing this is that, just give me a second. Yep. So I'll do a curl command and do existing logs. Now this as well is being shown to me in chunks because the file size, if it's large, what I've done is I basically look at what I'm doing is essentially I look at how big the file is, the file size, and if the file is big enough, I chunk it and then yield the response, and then of course server side events send the response as SSC signal, or otherwise if it's a small file, I just send the entire file contents as one. So this is just a small implementation detail I wanted to share. So again, I can take up doubts after the session also about this demo. I'm slightly short on time, so I'll quickly switch over to the slides again. This is just to give you a feel of how easy it is to set up server sent event based services with fast API. So I'll reshare my screen again, back to slides. Yeah. Okay. Let's quickly go over some technical issues. So I know that was a quick demo, but let's talk about what was actually happening. So assume the user has established a connection with the server at the streamlogs endpoint. What happens is that every time, as I said, a new file is added to the log file, the tail pointer essentially yields the line and it is sent as an SSC signal. So the events source response is basically Starlet, which is again you can search up Starlet. It's what fast API is built on top. That is the Starlet's representation of a server sent event. And again, the most important thing to remember is that it converts Python generator objects into SSC signals. And moving on. Okay, so if you notice the function which was actually tailing the file, again, just to reiterate, that loop over there for line in tail, that particular line, what it's doing is that it's iterating over the output lines of the tail command. So whatever output the tail command gives, again, this is the same tail command which runs on a Linux terminal, and whatever output it gives, it's basically yielding that line and sending it to whoever is consuming that function. Okay, so how do you make sure that only newly added text is sent to the client? So as you must be aware, how tail works is that it indefinitely follows the log file and yields new lines anytime the file is updated. How was I able to set up concurrent multi-client connections? For those of who are aware about async in Python, I'm not sure what's the current status on the global interpreter log. Some people are saying it's getting removed. I'm not sure about that. But currently how we are running is a single threaded event loop. You can set up more workers to handle better concurrency, but async fast API is how I'm running multi-client connections. Again, let's quickly talk about some alternative solutions. So I want to compare WebSockets to server-sent events. So interestingly, the way WebSockets work internally is that they upgrade an HTTP connection to a WebSocket connection. So assume, there's an initial HTTP handshake from the client to the server, and then the connection, a simple HTTP connection, gets upgraded to a WebSocket connection. The only downside is that it's slightly complex to implement, and it does not directly run on a raw HTTP connection. You need certain more complex setup to actually enable WebSockets, and with most programming languages you need to use some of the other library to actually implement this properly. And yeah, WebSockets relatively demand higher CPU compute as well, and for this type of service it's unnecessary because you only need to send data from the server to the client, and you don't necessarily need bi-directional communication. Another alternative is event-driven architecture utilizing message queues. So again, I mentioned earlier that this is slightly similar to a PubSub model, and the way you can use message queues is actually you can set up something like, say, Kafka, and you can have a log topic, and a server can continuously push logs to the topic, and you will have consumers to consume them. Okay, so with that I've come to the end of my talk. I'm happy to answer any questions related to server-sent events, async, or of course, and my music production career as well. Yeah. Any questions? Okay, so I'll end with this image from, yeah. Sorry, my what? My playlist, yeah, sure, I'll do that.
Your playlist, please.
Yeah, we'll connect after. So yeah, with that I end. Thank you for being a lovely audience. I'm happy to connect after the talk.
All right. Thank you very much for this talk. I think it is time for Gora to come on and congratulate you with a memento. All right, now that was an awesome talk, and thank you everyone for being here. I would just say that I would like to ask you once again, what has been your experience with Python so far? If anyone would like to volunteer, just to get to know the audience better, I think it would be good if anyone would like to share. Would anyone? Guinness. I'm looking at you, Guinness. Guinness has a thumbs up experience with Python, which I think would be for me as well, and for you as well. And so I guess we have our lunch.
हाँ कॉल नंबर इस पे है ना
कॉल यार मैं लाइटनिंग करा रहा हूँ किसी और से बात कर Yes, I'll announce it. We'll announce it. Next. जो ज्वाइन करेगा तो दे दे. हाँ. Can I have your attention, please, everyone? Hello. We are starting with the lightning talks. Please be seated.
यार वो मिलेगा हॉटस्पॉट नहीं चल गया ऐसे ही चल गया वो
चल रहा है
हाँ चल गया
Get him set up.
YZF URCD
CDN
CDN
तू पहले वो कर लेगा
हाँ पहले ये कर रहा है श्योर
सेकंड आप
ठीक है
डोंट कंफ्यूज लेट हिम गो
यू गो
नहीं आप कर लो ना
अरे थोड़ा सा करना
कोई नहीं शेयर योर स्क्रीन
Did you share your screen?
You have 10 minutes, right?
श्योर जल्दी हो जाएगा
आप स्क्रीन शेयर कर दीजिए
हाँ मत करना
शेयर अब होगा फिनिश करना एक बार
मेरे को हॉटस्पॉट मिल पाएगा क्या मतलब आई एम यूजिंग दिस
माइंड यू का
हाँ
साइन इन करना है करो साइन इन का ऑप्शन आया आपके पास
वो आ गया था बंद कर दिया मैंने
कर दिया
हाँ
दक्ष तू आ जाए सेटअप कर
हाँ आप कर लो
मुझे भेजा किसने था
इसलिए यार
इसमें ये मांग रहा है ना इसलिए वो नहीं पाएगा
for MC managing all these things
अरे you can use my hotspot if not.
हाँ hotspot will be better.
Can you make it?
Sure, just a second. एक second. वो मेरा तो connected ही नहीं है.
All right, we are starting with the first lightning talk. The first lightning talk is by Daksh Jain. He'll be talking about DOS your APIs with Python requests. Please have a round of applause for Daksh.
Okay, hi everyone. So I have a very quick lightning talk on why you should limit your APIs and how you can actually DOS your APIs using Python. So first is why you should actually put a rate limit on your APIs. You don't want abuse and overload of your API. You want to optimize usage, and of course you don't want your systems to crash. So what happens if you don't have an API limit, have a rate limit on your APIs? So I have this API which validates emails. I'll zoom in. So what I'm doing in the code is calling the API using a list of emails which I have, and I'll get the response from the API, just like usually how it goes. So that's all the response I'm getting. So what can I do if I'm a malicious user? Is I can randomly generate a huge amount of emails and put it through the API. So for example, I have 5. I can make it 15 right now and run the code. So you can see it will keep making requests as long as you like, and it will eventually crash the server. So it's quite important to have rate limits on your APIs if you don't want a scenario like this. So if you're a hobbyist, if you make products, if you make projects, make sure to have rate limits on your APIs. You don't want this to happen. So I'll go over to the code quickly. So I'm using request, random, and string. I have this base URL, which is my API. Then I have a function which generates random email. So I'm using username and joining with the domain. Then I return the email to the function. So I have number of emails, and I generate random emails using a list comprehension. And then I just go in the for loop, add the email in my URL base, and I send responses. So if you are making APIs, if you are testing, if you're in a company, please make sure to have rate limit on your APIs, or you'll get something like this, and your system will get crashed. So that's it. Quick lesson for today.
Next up, we have Unsafe Rust by Yash Tomar. Is Yash Tomar here? Please have a round of applause for Yash Tomar. No, just join a Google Meet. That's it. What is the link? Share your screen. Not visible. Daksh, allow. Someone has to manage that, okay? Till then, we have 4 speakers actually. Next, an interactive platformer game to teach local languages to children are Soham, Sanvi, Satyam, Yuvraj. Are they there? Yeah, please come here. I mean there, after him. Get your laptop set up till then. It's not visible. Okay, seems like Yash has some problems with the projector. Next speakers, please. Link. एक सेकंड Y URCD CDN अलाउ
नो रिक्वेस्ट
साउंड नहीं आएगी जस्ट प्रेजेंट
रिक्वेस्ट नहीं आई मैं
visible
Okay, so throughout the conference, day one and up till now, we haven't seen any games being developed on Python. Like we took part in a hackathon in our college and we built this game on the theme of Back to the Future. So our project's name is Omilia. It's basically an e-learning platformer game which helps children of small ages to learn regional dialects in a gamified format. So yeah, we can show you what.
Basically, when we start the game, we have this help section which shows you how to play the game. So since this is a platformer game, if you guys remember games like Mario, it kind of has the same format to that. So I'll show you how the game works right now.
As of now, we have 3 languages in our game because we made this in a hurry. Okay, so all the languages have a different world associated with that. So if a single child wants to learn all 3 languages, it will not be a monotonous experience for him, but a rather good experience as he'll be able to play different levels on new worlds.
You see, because the problem is generally, in the traditional educational system, what happens is generally a child is handed a textbook and then, it is expected from him to learn a language just by looking at the word and memorizing its meaning. So we decided that we wanted to gamify that format and turn it into a game so that we could grab the attention of a child and kind of, make them attracted to this game so that they can learn languages while also playing, so that playing becomes something productive for them. Now we'll show you the demo of the Hindi language that we have. Once you start the game, you will see that there is a guide here. The projection is slightly small, so you won't be able to make out what the words are here. But basically, we have pictures and words corresponding to their meanings. So once we start the game, you'll have a level here. And basically, you can't hear the sound, but there is a voiceover here, which we generated through AI, which has the voice of Marty from Back to the Future. And he's basically saying that instead of traveling through time, they've gone to a different dimension. And now they can't really understand what language the other person is saying. So your task in this game is to understand the word that is there, and then you have to basically figure out that word. And once you figure out the word, you move on to the next level. So yeah, once you finish a level, you will get this prompt first. This is in the first level only. And here you actually understand what is the core concept or what is the plot of this game. So basically, we have doctor here telling us that they've gone to a different dimension and the only way to go back is by understanding the word. So let's look at the word here. For example, we have bandar here. Now the task of the player here is to identify bandar as a word, and he or she needs to calculate, actually basically understand and pick which one of these images represents a bandar. So in this case, it would be the first image. Once you select the right image, you would move to the next level. But if you get the image wrong, you would basically have to repeat that level. And we have multiple questions there which are randomized. So you would get a random word every single time, which is pani now. So you would have to choose pani here, which would basically be what the game is all about. This is how you learn languages in this game. Once you choose the wrong word, you will basically have to repeat the level. Now, regarding this game, Sanvi will explain you the meaning of the word Omilia and why we chose this name for this project.
Hi everyone, let's talk about the spirit of the game. So the name Omilia is actually derived from the Greek word which actually translates to language or communication. So we actually developed this game as part of a hackathon which was conducted by the Open Source Developers Club of our college. And the theme was Back to the Future. We wanted to combine the principles of retro games and retro technology with something which helps the community. So like there's Duolingo, but Duolingo basically teaches international languages. So we thought, why not a game and a learning sort of app or software or web application which would help children with learning difficulties to learn local languages in India, which are not basically taught at other places. So that's where our game Omilia comes in, and hope you'll enjoy it.
And a fun fact about it, you guys can't really hear the sound, and I wish you really did, because the assets in this game, the sprites were developed, they were created by us, and the rest of the stuff we generated through AI, using generative AI which is out there. And the music and all that is in the game, we also created that on our own. So basically this project is something that we, the assets for which we created from scratch on our own. Now Satyam here will tell you how we created the levels in the game.
So hello guys, all the levels you see, they are all editable. There are 7 levels currently, and I made a level editor which gives it a like open source phase, like you guys all can contribute and make more levels, so it's not limited to 7 levels only.
Now we can show you the game in different languages. Like I told you that the game supports different worlds. Like we created different worlds for it. So yeah, if we run the file again, and yeah, if we run the file again, we can see that if I choose a different language, we'll see a different world being. So this is a different theme, and the levels will be different as we progress. So yeah, that's about it.
Yeah, that is all about our project. Hope you guys found this interesting, and yeah, that is it. Thank you guys so much.
Next up, we have Pratyush. He'll be talking on handling PDFs in Python. Please have a round of applause for Pratyush.
Hello. Yeah, so sooner or later we all get PDFs in our work, and we need to extract some data from PDFs or process them. So these are few of the libraries that I have tried and researched on while doing our work, and I will share a few of them. About me, I am Pratyush. I run a website called screener.in. It's a research tool for stock investors. You can go on the website, type in a stock name, and you get all the history of that company. And in our case, we get lots of PDFs. The companies publish the annual reports, announcements, everything is in PDF, and that's where we really need to work on PDFs. The use cases for PDFs are multiple, like we need to sometimes extract the tables, the financials presented by the companies or the comparative data. Sometimes we just need to extract certain number, like in case of invoices, we might need to extract the total invoice amount, what the item is, those kind of things. We can even nowadays the text is very useful because we can pass it to GPT, and with GPT the amount of things we can work on PDFs is even more. Like now we don't need to create multiple special models to extract that table or things if we just get the text from that PDF. So how to get the text from PDFs in the best way? One of the libraries is PDF to text. it's a simple library. It uses Poplar under the hood. Poplar is written on C++. It's part of Linux core tools. So Poplar is well maintained, written in C++, and that's why this library is very fast. The best, the thing this library gets done is that it represents the exact representation of text on the PDF. So अगर PDF में multiple columns हैं या tables हैं कुछ भी है, it doesn't care about tables or those things. It will give exact representation of the text in that format. If there is a table of 2 columns, it will return 2 columns of text just like it looks in that PDF. So we get a plain text version of that PDF, which we can pass to GPT, and GPT is very good in handling these kind of structures. It is automatically able to detect whether this was originally a table because of those spaces between the text and those things. So if you are trying to pass something to GPT and like if you use this simple function extract text and then tell GPT whatever you want to extract, it will do a fabulous job. The problem with this is that it consumes too many tokens because it retains the space bars to position that text at that particular place. I will also like to talk about why PDFs are tough. Like PDFs were not created for human consumption; they were created for printing, for printers. And in a way, it is an image format. It doesn't have sentences, it doesn't have paragraphs, and all the libraries under the hood try to compute like, if the letters are too close, this is probably a single word. And if words are too close, then it is probably a single paragraph. So, this is a good library which doesn't care of all that. It just gives that representation. Another good library that we use a lot is PyMuPDF. This under the hood uses MuPDF. It has wrappers around MuPDF. MuPDF is written on C. That's why this one is also very fast. It has few advantages over Poplar one is like it gives positions of individual text. So if you want to do something like sometimes we want to detect what are the headers of this page or what is the title of this page or whether it is a page number of those things. So in those cases it returns the positions as well, and we can crop the page dimensions. Okay, that ignore the top 100 pixels, bottom 100 pixels and those kind of things. So this gives little more using that get text blocks option. It returns list of all the text on that page. So all the paragraphs, we properly get all the paragraphs and all the text blocks in a single page. And if we get single paragraph, then we can do much more work, much more targeted work if that's what we want. So this one handles paragraphs and those things very well. For 2-column data, it will give a single list of all the paragraphs in a proper way in which they were actually written in the PDF. So last one gave up exact text representation. This will give list of all paragraphs in the order they were added to the document. The good thing about this library is that it also works with any other format. It even works with JPG images, any image format, even XPS files and those things. So it's pretty robust library. Another library is PyPDF. This uses QPDF under the hood. It has wrappers around QPDF, and that's why this one is also fast. The problem with this one is that it doesn't support extraction. This one is very good for splitting and merging PDFs. So if you want to extract few pages and modify the PDFs, then this one is pretty good. Then there are 2 more libraries, PyPDF and PDF-6. These are written totally in Python. These are totally written in Python. They don't use any other thing. So for all the previous libraries, we also need to install their core packages. In case of PDF to text, we need to install Poplar. For PyMuPDF, we need to install MuPDF. These will work in standalone. These uses, like any other libraries, they also use heuristic to detect text blocks. What is a word, what is a paragraph, and sentences, those kind of things. This one is a bit slower, in fact a lot slower than previous libraries, but it is good if we want to extract more metadata of a particular text, what was the font size, whether that text was bold or not, whether it was in italics, and those kind of things to do further heuristics. These 2 libraries are good. That's it. Thank you. You can reach me on these coordinates.
Thank you, Pratyush. This is the last lightning talk that we'll be having today. Just for information, we are having a workshop right now on Sanic, given by Akshita. So if you want to attend that, you can go in the workshop room. So, yeah, Lavanya? Lavanya? Where is Lavanya? Where is Lavanya? Is there anything else? Yeah, go ahead. You know this guy, right? Mohit, आपको बताया ये वाला schedule है? Yes. So software engineer at So our next talk is on scaling Celery infrastructure on AWS with Python, and the talk will be given by Mohit Bansal, alias is Philomath everywhere. Mohit is a software engineer at Essentia and also a veteran of India Linux Users Group Delhi. So if you want to talk about Linux, Mohit is the right person to talk to. Please have a round of applause for Mohit.
Thank you, Shan. Let's see.
Go to the meeting. Stop presenting. Present. Your entire screen. Entire.
So, hello everyone, my name is Mohit. Today I'll be talking about a problem that we as an engineer sometimes face, and it will be a case study where we'll be going through the problem and finding the solution to this, and how can we scale our AWS system with using Celery and Python. So who am I? I'm Mohit Bansal. I'm a Philomath. I also work as software engineer at Essentia.dev. I use Python and whatever is necessary to solve problems. And also you can find me at MI Philomath, anywhere else. So why are we here? We are here to find a solution to a problem that can save us a lot of time and money in terms of our services and debugging time. And also to dynamically scale our ECS services. So if you know about AWS ECS, it would be very easy for you to understand how we can scale or how ECS scales our application there. And one more thing. So before we go ahead, I want to share about how distributed computing works and how different asynchronous tasks can be processed by our application. And this problem keeps in mind, this problem is around a Django environment deployed on AWS ECS cluster. But before we will go through the distributed computing part. So in a distributed computing, we have different processes that is put in a message broker, and each task can be put in a queue, which is consumed by different consumers. The dispatcher is responsible to divide or assign those processes tasks to each queue. And ideally, we should divide the task to a queue according to their criticality, and the consumers should be separated accordingly. Celery is one of the libraries that is used for this to achieve this solution, to achieve distributed computing. And Redis is used as a message broker in our architecture, in our problem. In this particular environment, so Django is our application that will be hosted on AWS ECS, and it will be generating a lot of events, and it has a lot of tasks to process. What it will do, it will put all these tasks in a queue, which is handled by Redis, and these queues will be consumed by Celery workers. And Celery also has a scheduler which will dispatch those tasks in those queues. So if you can see that Django sends task to message broker, and the task will be distributed among different Celery workers. So we can dynamically distribute a workload to more than one worker to process them as soon as possible. And we'll iterate through the problem statement again, that what was the problem that we were facing and how we achieved the solution that we needed. So the problem was, in our application, we had a lot of asynchronous tasks that we needed to process. So we had certain number of queues, as in this diagram, we had certain number of queues in Redis, and all of those queues were processed by different salary workers. But we needed a solution to scale this, because the workload on those queues were not predictable. Some queues were empty, some queues had millions of tasks pending in their queue, and each queue has a salary worker associated, a worker consumer associated with it. So we cannot just put any available consumer to any queue. It has to be mapped to a queue. The problem was that we cannot scale it according to our variable load. When the load is almost negligible, we cannot have all the services or consumers running all the time because it will be costly. So we needed a cost optimal solution which is highly scalable for our use case. And we had a few possible solutions in our mind. So since it was deployed on ECS, we could run n number of tasks on ECS services cluster to achieve our highest workload, the highest workload that we expect from our application. But what about that? What about when we do not have enough workload or enough processes for our application? It will be just a waste of resources there. So it will be very cost heavy solution. Another approach was to use AWS auto scaling group. So AWS has a built-in feature in ECS to use their auto scaling group, but we'll come to that later, why we cannot use it and why it was not usable for us. So for fixed number of tasks where we have n number of tasks already running all the time, it has a high cost associated with it for each task running, and we will not be using all the cores all the time. It's not an optimal solution in terms of as a computing problem. And it's not scalable as well. So if I know that I expect thousands of requests and I have a system deployed to handle 1,000 requests, but it can happen that I receive 10,000 requests or 1,000,000 requests. And even for a temporarily high load, this solution will not be able to achieve our solution, that what we need. It's not optimal as well. And even cost is not justifiable. With auto-scaling group, the problem was that the auto-scaling criteria uses CPU and memory. So if you define a threshold that CPU, if the CPU usage is more than 80% scale up and less than 20% just scale down, same for memory. But it doesn't work in our use case, because for asynchronous task not necessarily uses a lot of CPU. It may not be a lot of CPU heavy tasks. But the number of tasks blocks my queue. If I have 10,000 of tasks, but they do not consume not even 100 MB of space, or not even one core, then the auto-scaling group will not be able to scale up or scale down according to my requirements. And it was also killing my processes in between when they were processing task, because the criteria for scaling down was achieved, and AWS just shut down those ECS tasks, which was very difficult to debug for a while. So that's why we need a new solution to save our costs on our services, to scale and handle variable loads. So when I say variable loads, I mean that load can be in terms of millions and zero as well. It could be a jerk of high loads of task processes, and we needed a solution that considers the number of tasks instead of not only CPU usage and memory usage for our consumers, but the number of tasks in the queue that the consumer is responsible to process. So what our optimal solution looks like here. Our optimal solution should be able to track the number of tasks that is present in our message broker, which is Redis queue, so that we know how many consumers we require to, or how many consumers needs to be added to our application so that we can process all those tasks within n minutes and scale that number of consumers dynamically. We should also be able to control the maximum and minimum number of tasks similar to AWS auto-scaling group. So auto-scaling group in AECS also allows you to manage or define the maximum and minimum number of tasks along with the thresholds that you want to achieve. But the threshold criteria is of CPU and memory usage. In our case, we need that to be the number of tasks in a queue. And it should not drop any ongoing task. So the system should not shut down. Our application should not scale down when it is already processing a task. It will lose our purpose. So what we did, we needed almost three important things: something to track our task and scale and control. So we had a monitoring services implemented, which will be tracking all the tasks available in each queue and scale, and another task will be scaling accordingly. If the number of tasks in any queue is above the threshold that is configured in our database, in our configuration settings, it should scale up and scale down accordingly. So the solution is bit configurable. That's the advantage of it. So we can configure what should be the threshold and how many workers should be added to our scaling. Primary consumer would be consumer that will be always be running and will be monitoring the queues, will be running the services for scaling up and scaling down. So this is something we have one monitoring task, scaling task, and different queues for different services. So how we create queues in a distributed computing environment? Characteristics of tasks should be part of single queue. And critical, so based on their priority, based on their criticality, we can separate the task in different queues. And there's one queue for type service A types queues and one queue for service B types queues tasks. Another queue will always be consuming the task for essential services such as monitoring task and scaling up and scaling down logic. This is our ECS cluster can look like if we want to achieve this solution, where we'll have one service running all the time with all the essential tasks that will be consuming our essential queue and providing service to our application as well. So web will be monitoring all the web requests, and other monitors can be, we can have another Celery consumer in this service, which will be responsible for consuming the task for queue for essential services. Service A and service B will be services managing queues for these tasks. Yeah, so configuration. In terms of configuration, so as I said, our application, our solution should be configurable enough for us to achieve our solution, for it to be optimal for our use case. But what affects our configuration? It not necessarily has to be the number of tasks, and even if it is, what other things should be there? So how frequently should it check for the number of tasks in the queues? Because queues, the variable load can occur in the interval of 3 minutes, 30 minutes, or 3 hours. So it depends on your use case. If you expect the variable loads, the system to get the high load in very frequently, I would suggest that have this frequency as low as possible, as high as possible. Otherwise, you can have an interval of larger duration. What is the average rate of processing of our ECS task? So to scale up and scale down dynamically, we need to have a rough estimation on what is the average consumption rate of our queues. So each queue have a category of task running or processing in it, and if we know that each task would take about 30 seconds or 1 minute, so we know that the consumption rate would be 1 task per minute or 2 tasks per minute, a rough estimation, so that we can define if we want to scale up or scale down, how many workers do I need to add to my scaling up logic to process X number of tasks in Y minutes, or etc. Similarly, for minimum and maximum number of tasks, I do not want to just add 100 number of tasks or 1000 number of tasks just because my logic says. It would be stupid. My cost will be exponential just in a span of 1 minute or 2 minutes. So to control that, I need to have a minimum and maximum number of tasks, just similar to AWS auto-scaling group. So I'll go through how our monitoring or scaling logic can look like if you want to achieve this or work around with this solution. So monitoring logic should be a periodic monitor that should keep track of all the tasks in each queue and check whether that number of tasks in any queue is above the threshold or not. If the number of tasks in any queue is above the threshold, that it will be the responsibility of a scaling logic to scale up or scale down accordingly. Yeah. So we can also track the retry state. So mainly we want to track active and reserved tasks, because active and reserved tasks are those tasks that is already assigned a worker in Celery. So I do not want to assign or count a task for my scaling up logic that is already in retry state, but it's not in the queue. I only want to consider the task that will affect my system performance. But it's up to the use case as well. If you think that retry task can also be considered and should be considered for my scaling up logic, definitely it should be. Yeah. So as I said, scaling up logic, the consumption rate, how many tasks can be consumed per minute, will be helpful if you want to scale up. So if the number of tasks is above the threshold, number of tasks if I want to process all the tasks in next 5 minutes, irrespective of the load, if I have a load of thousands, 10,000s or million, I want to process all the tasks in next 5 minutes, 15 minutes. Accordingly, I can configure it in my configuration settings that how many maximum number of tasks should be there and consumption rate. So if I want to, if my consumption rate is about 20 tasks per minute for each Celery task, and I want to process 2000 tasks in, 5 minutes, so I'll need about 20 tasks, in 5 minutes, right? Just simple math. For scaling down logic, what I did, I waited for all the queues to get empty before I scaled down to prevent interrupting any ongoing tasks, because that's one of the problems we wanted to solve along with the cost and scaling. And these are the configuration that can be used: rate of consumption, minimum and maximum number of tasks, and threshold for each queue, that after how many tasks, if the number of tasks is more than X in any queue, I want to scale up so that it will not slow down my system. And why Python? Because it was easier, actually. There are multiple solutions to this problem. There are many ways to achieve this, but whatever works for us works, right? So Python was easier for me to implement anyways, and it gave me the power to manage it easier. It was more configurable for me. We could also use CloudWatch Monitor, which is an AWS service, but it will add more cost to it, because CloudWatch is a service to AWS and each metric add to its cost. So Python was more cheaper and configurable and useful for my use case. Yeah, what can be improved? So there can be multiple things that we can improve. Like in scaling down logic, I was waiting for each queue to get emptied. Instead, what we could do, when the threshold is below, when the number of tasks is below the threshold, we could stop redirecting tasks to the number of workers that were scaled up. And once it's done, we could just stop those tasks. So instead of waiting for the queues to get empty, we could scale down, but we have to reroute or control the routing of each task. Yeah, I could also write a Django app that can implement it in any Django project, but it's very small niche. So, right, result. So when we implemented this solution, we were able to save about 30% in the cost of our service, which was very huge in absolute terms. And we never faced any interrupted task after that, which was very good. And rarely if we did, because ECS takes about 30 seconds to shut down any target task. And if the task is already picked anything from the queue, it will be there. But the results were very impressive for our use case, and we were satisfied with it. So as I said, there are multiple ways to achieve this solution. And if you have any solution that you think that could be used in this case, feel free to reach out to me. Yeah, that's it. Thanks for listening. And if you have any problems, I'll be in hallway. If we have enough time, we can discuss it right now as well. Do we? Questions? Yeah, if we have time, we can do questions. Yeah, so if anybody have any questions, we have 5 minutes. Otherwise, I'll be available in the hall for anyone to ask any questions. No questions? All right. Thank you.
Well, thank you, Mohit, for an insightful speech. Now I would like to call upon Gora sir for a piece of memento. Let's clap, everyone. Thank you, sir. For my next speech, I'm calling upon Ms. Shloka Shah. She'll be speaking about the power of harnessing web scraping using Python. So let's welcome her.
I'll mostly do a demo here. Do I need to unmute here?
No, you can start. Just.
So, hello everyone, good afternoon. I'm Shloka and today we'll be discussing about web scraping. So, in this talk we'll see how we can scrape effectively to get the most out of the data. So, a quick introduction about me. I'm Shloka and I work at HackerRank as a software engineer. I also write monthly blogs about my experiences and learnings from technology. So the brief agenda for this talk will be around the 4 topics. First, we'll understand what web scraping is. Then we'll see how we can scale web scrapers. once we have understood how we can scale web scrapers, we'll see how we can store the scraped data, and lastly, going into the ethical considerations while scraping. So, starting with what is web scraping? If I have to define web scraping in 2 simple words, it is automated extraction. So we can call it as automated extraction of data from anywhere on the internet, be it in the form of HTML elements or XML data or any other different elements in the form of JSON, which we can store in the format that is required for us. So there is a usual conception that scraping and crawling are 2 same things, but there is quite a bit difference between the 2 of them. So we'll first understand what is actually scraping and how it differs from crawling. So if you see the difference over here, yeah. So if we talk about on the basis of purpose, a web scraper is usually used to extract the metadata from a specific URL, whereas a crawler is used to navigate over the entire web and fetch different URLs for us. So talking about the depth of a web scraper is usually very shallow because we are already given a URL and we just need to fetch the metadata out of it. Whereas in terms of a crawler, the crawler is navigating the entire web for us, so it's like an infinite possibility and it just keeps on fetching different URLs for us. Talking about the data volume, so in terms of a web scraper, we have just limited metadata that the URL will provide, but the crawler will index all the URLs for us. And output again, it's just the scraper gives us data which we can store in our databases or in a CSV or any text file, whereas for the crawler we need to index all those URLs or pass it on further to the scraper. So now that we have understood what the difference between a scraper and a crawler is, this is a high-level view. Yeah, this is a high-level view of how an ideal crawler to a scraper communication or architecture looks like. So we'll have a web crawler which will crawl the entire web with all the URLs that we need. It will store all the crawled links and then it will pass it on to the web scraper, which will be responsible for finding all the metadata out of it. So it's the crawler, the crawled links, the scraper, and the scraped data. So now we understood like the difference. Now let's see like what were the traditional methods to do. Like before all the Python libraries came into picture, people still used to do scraping. So let's understand the traditional methods of web scraping. So these are the 2 major traditional methods. The first one is the regular expression. So we have like what people used to do was they used to write regex so that they could find patterns in the different HTML structure and get the data out of it. The problem with this approach was like as the web started evolving, people started adding dynamic content and the HTML structure of the same website also keeps on changing. So it's not a very scalable approach and it won't work most of the times. Similarly, the next one was manual copying and pasting. Now again with copying pasting, it doesn't look like a scalable approach because we can copy paste data only for one website but not do it for n different websites. So yeah, these are the drawbacks of traditional methods. The first is like it works best with static websites, like the old web where people didn't use any JavaScript to render data, but nowadays websites use JavaScript to render data, so it doesn't work with dynamic websites and only with static websites. So the next is manual labor. There's a lot of manual labor involved in copy pasting data and even in writing different regex expressions for n different websites. And it's not scalable. So the first library that we'll talk about is Beautiful Soup, which is the most commonly used Python library for web scraping purposes. So it's usually used to parse HTML and XML documents. So the thing with Beautiful Soup is it doesn't directly fetch the data from the website for us. What we have to do is we have to use a request library in top of it, which will fetch the HTML content for us, and then we can use Beautiful Soup as a parser. Like Beautiful Soup has different HTML and LXML parsers that we'll have to use on top of that HTML content to get the different titles or the A tags in the website. So this is a sample, like a very basic example of how Beautiful Soup will work. You just import the request library, then you import Beautiful Soup, and we just need to make a request to the URL and then parse the content that we got using the HTML parser, and then we can easily extract title or the A tags from it. The next library is Selenium. So Selenium is actually an automated web browser testing library, but it can also be used in cases where we have a web page that gives dynamic content like JavaScript. So that is where Selenium becomes very helpful in scraping data from dynamic websites which render data using JavaScript. So what we can also do is we can combine Selenium with Beautiful Soup. Yeah. So we can combine Selenium with Beautiful Soup. So here, as you can see, like we import Selenium, use the Chrome driver, and what we can do is we can call the website using Selenium. It will load the entire website's HTML page source for us, which will also include JavaScript, and then we can use Beautiful Soup with it. So we'll towards the end of the presentation, I'll give you a quick demo on how to use these two. But now let's switch to scaling the web scraper. So all of us usually try web scraping in our colleges on a very small scale, which is just like we are scraping one website with very minimal data. But when it comes to scaling web scrapers, there are different parameters that are involved, which we need to consider. So the first one is getting banned. Like when we try to scrape a website continuously, there are a lot of chances that the user agent that we are using will get banned. So the one way to do is to use multiple user agents. Now when I say multiple user agents, it's not like we need to use proxies. We can try different architectures. For example, like if we are using a Linux machine, we can use another machine as well, Windows machine, to scrape, so that our user agent differs, and that way our scraping won't get blocked. Enough IPs. So this the scene of IPs come into picture when we are using some cloud solutions to do scraping. So at that time we can use a system so that it automatically scales up and down so that we get enough IPs. The next is to rotate, like not use the same set of user agents and IPs always, like to rotate user agents and IPs in all the requests that we make. And finally, following a different structure for scraping. Now, what happens is when we scrape the same website in the same manner every time, it's very easy for the bots to detect our pattern. But if we spread out our requests properly, it increases our chances of getting the accurate data. The next thing is visited URL. So we already discussed about the crawler and the scraper architecture in the earlier slides. Now what happens is if we are crawling a lot of URLs, there are chances that we will have duplicate URLs that and we don't want the scraper to scrape the same URLs again and again for us. So here what we can do is we can consider this thing as a graph data structure and maintain a list of visited URLs, and before sending any URL to the scraper, always check that if that URL has been visited already, and if it's not visited, then only we send it to the scraper. This makes our computing cost less and we don't have to do duplicate effort. The next is handling the dynamic content like we discussed. So there are two approaches to it. So one is using headless browsers. There are a lot of different headless browsers that are available. Like one is we can use Chrome driver, we can use Puppeteer, and even Playwright that was discussed earlier. So we can use a headless browser. So what the benefit of headless browser is, it loads all the dynamic content for us and it increases our chances of getting the right data. And the next is varying page structure. Now this is something which is not in our control, but it is going to happen. Like websites are going to change their pattern frequently, and we'll have to keep up with it. Like we'll have to add some checks to add a regular monitoring that whether the data count that we have been getting has been constant. If the count drops, that means like something is wrong with our scraper, and we'll probably need to change the values that we have been fetching. The last thing is structured data. So there are different patterns of structured data that are available for us. So the first one is JSON LD. So this is like JSON for linked data, and this is something that even Google recommends for all the websites to use. So the benefit of using this is it follows a proper schema for different types. For example, for a course, there is a different schema. For a person, there is a different schema. So if we follow this schema, it becomes very, if we use JSON LD, it becomes very easy to fetch the data, and we don't have to add a lot of manual tags parsing in the beautiful soup parser. And the next one is Open Graph, which is also like a social linking protocol, which again provide different fields like the title and the name, which can again help us in finding the right data. So this is the queue. I'll give a live demo right now, like how we can use this different libraries to scrape data. Is my screen visible to everyone behind? It's visible now? Yeah. Yeah. So the first thing is importing the libraries. The second is we'll start with, this is the particular URL that we are trying to scrape. So this is a Coursera course. So this is a Coursera course that we are trying to scrape. So the first thing is to make a request to this particular URL. The next is to So the next is we'll take beautiful soup and we'll get the use the HTML parser to get data from it. Now so if you see here, this is the website that web page that we are trying to crawl. So let me zoom in. So if I go here and try to see the CSS for this particular tag, like we are trying to fetch all the teachers or the instructors who are associated with that particular course. So here you can see that the class for this particular instructor is this thing. So what we'll do is so here we'll try to make a request. We'll use the span class and just add this value here. Now what this will do for us is it will parse the entire soup content that we fetched. We'll look for the span tag and fetch all the values which have this particular class. So I'll run this and show how it will look like. So as you can see, we fetched all the instructor names that were associated with this particular course. Now if we go back to the example, we can see that what we had to do was we had to go to the web page and then find like what was the particular class name of that for all the instructors. So this is the thing that happens with Beautiful Soup. Like we have to understand the HTML structure ourselves and then get the name associated. Now what is the benefit of using a JSON LD format is we'll see in this example. So we'll import all the libraries first. We'll again use the same URL. In this case, instead of using Beautiful Soup to make a request, we'll use Selenium to make a request to that particular URL. So this is how you define like the options. You set headless to true as we had discussed. And so this is the Selenium definition that is done. Now once this is done, we'll use the line driver.get URL. It fetches all the HTML page source for us. Now what we'll do is we'll use Beautiful Soup on top of it to fetch the different content in it. Now once this is done, we will again find the script tag in it. So the JSON LD in all the website is inside a script tag, and the type is usually LD plus JSON, which indicates that it's a linked data. So we do this, and I'll run this and we'll see the this usually, yeah. So as you can see here, so this is the JSON LD of that entire web page. So it is in the LD plus JSON, and it has this context, which is usually like schema.org has defined all the different LD formats for different types, like a course, a person, even a recipe. So here we can see the entire metadata for it. Now we are only interested in finding the person data because we need to find. So here you can see like all the instructors for that particular course are under this person type. So now all we have to do is parse this JSON and find the person, find the value where the type is person, and then we can have the name of the instructors in that particular course. So here now you can see that we have found all the course instructors and all their other metadata as well. Like this is a type person, we get their name, the job title, and also the image of that particular person which is used in the Coursera's page. So we looked at different examples of how we can use Beautiful Soup and Selenium along with JSON LD. So these are the 4 different ways in which we can store the data. So the first one is CSVs. CSVs are usually beneficial when we are trying to do some data science task on top of it. It becomes very easy to use pandas along with CSV. SQL is usually when we want only certain structured data that we want to store. So the next is NoSQL. We can store data in MongoDB or even Elasticsearch if we just want to make a JSON dump. And the last is simply in a text file. Like if we just want the instructor's name, we can just put it in a text file. The last thing is ethical considerations. So there are 2 things that we should keep in mind while we are scraping. The first is respecting the website policies. Like all the websites have a robots.txt where they mention all the rules, like whether we can scrape something or not. So it's very important to look into that and respect that before scraping. And the next is scraping only publicly available data. So this is, yeah, so that's it for the talk. You all can scan this QR code and I'll look forward to connecting with you all and discuss what has been your web scraping adventures. Yeah, thank you.
Thank you, Shloka, for the insightful speech. Now I would like to call Gora sir for the memento. Thank you, Gora sir. Now I would like to call upon on stage Mr. Saurav Jain.
Hey everyone, hello. Welcome to the best talk of PyCon Delhi 2023. And first of all, how many of you heard about the word open source? The last person? How many of you? Many. Wow. So how many of you have ever contributed to an open source project before? Don't count your don't count contributions that you contributed to your friend's repository for the Hacktoberfest t-shirt. The actual contributions. How many of you? Okay, very few. Good. And how many of you have ever been a maintainer or maintaining a repository that is open source or is the owner of a open source project? Okay. Three. Oh, very good. I'm proud of you all. So yeah, as you can see, this talk is about 3 factors that are blocking contributions to your open source project. So if you have never contributed, don't worry. This talk will help you how to figure out contributing for the first time. And if you want to make your product open source, if you want to run an open source project, maybe be a maintainer, this talk is for you. It will help you a lot to eliminate all those blockers that comes between the first contribution and your open source project. So the agenda of this talk will be, I'll start with explaining what open source is so that we all are on the same page. Then I'll go to some terminologies that comes in open source. And I'm pretty sure many of us don't know about those terminologies very well. And after that, I'll come to the actual talk, what are those 3 blockers and how I eliminated that while working at application. So before that, who am I? Hello everyone, I am Saurav. I am working as a community manager from last 2 years at application. I'll tell you a little bit more about application in the next slide. But before that, I consider myself as an open source evangelist. I am in this, I'm in the open source scenario from last 3 or 4 years. And this all started like, you can guess. I contributed to my friend's repository for Hacktoberfest t-shirt. And I stayed. And after that, I contributed to a few more projects. And then eventually in 2019, I got a chance to be mentor for TensorFlow in Google Code in 2019. So what is Google Code in Google Code in? It was, because that was the last edition, it was Google's summer of code, but for teenagers of 13 to 19 of age. So I was a mentor. I helped few students to work on the tasks they have been assigned to do for TensorFlow. And I learned a lot about communities that time, the open source projects and everything. And I started contributing to more and more projects. And eventually, in my last year of college in 2021, I was contributing to a very small project called Amplification. And after contributing for a few months, after creating few articles for them, I got a job offer from the CEO itself, and I joined them. So I'll tell you about Amplification in the next slide, as I said. Before that, I'm very active on Twitter and LinkedIn. If you are not following me, you are missing out. So please do. And I love to travel, I love to code, and I love Twitter very much. So let's talk about Amplification now. I am not promoting the Amplification here. You don't have to use it. I'm just saying it because you get where I started and how you can make your project this big. So currently, Amplification is big enough. We have around 35,000 plus developers community. We have 7,000 Twitter and more than 25,000 active users, which is very great. We create it. Amplification is open source and it's a dev tool. So these are the most two important terminologies that you should know. I'll tell you about open source in the next slide, but before that, dev tool. So a dev tool is something that reduces the time of tasks that developers do in their daily life. So what Amplification does is it's create production-ready backends, Node.js backends in few minutes for developer teams working on it. So it decreases the time significantly for them. And currently we have around more than 200 contributors on our project. And when I started, it was only 30. And the community was around 300 to 500 only. So we grew significantly in last one and a half year. And how I did that, I'll start telling you. But before, what open source is. So I'm not telling you a definition from GitHub or a Hacktoberfest website. I'm just telling you what I believe open source is. So it's any software or a project that is publicly available to each and everyone in this planet. And anyone from this planet can bring changes to that project. And this concept or this belief or this practice is open source. It's not a technology, it's not a tool. It's a practice or a belief. So let's come to terminologies. Before that, sorry, if you go to github.com/amplification, you will see the whole code base of Amplification publicly available to everyone. You can make pull requests, you can bring changes, you can see which technologies we are using, what are the best practices that our engineering team is using. So it's publicly available to everyone, and this is what open source is. And coming to terminologies, I'll start with maintainers. So initially, maintainers will be the core team of the project. It will be the founders who created the tool, or maybe some of your friends that are contributing to your project. But as the project grows, more and more maintainers come from the community. But what maintainers actually do for an open source project is they review the changes you bring to the project. They see whether it is right or not to bring that changes to the whole code base. They manages the roadmap for the project. So for those who don't know what a roadmap is, it is just like what features are coming in future. And when we talk about an open source project, it's very, very important to have a roadmap, because there will be 4 community members saying we need feature A, there will be 4 community members saying we need feature B, and there will be always a clash between those features. And no small team can work on all features at the same time. So that is the time where maintainer decide which feature will come next, and which is very important. And they basically manages the whole project for the open source community, and they are the owners of the project. After that, the second most important thing is community. I always say that community is the engine of any open source project. Initially, let's assume you have started making a product. Initially, you will be very small. The team will be very small. It will be less than 10. It will be only your friends or some of your colleagues working on a project, and that will be your team. And when you're making open source, it's all about collaborating. And you want more and more people, more and more developers from the world to contribute to your project. And that's exactly where the community comes in. And community can be of thousands of developers. And when they start using your project, and they find value in it, they drives the project, not you. They will decide what feature should be in the project. They will bring that feature. They will request you to accept that pull request. They will find bugs in your project. They will open issues. They will make your project better. They will provide feedback. They will spread the word, everything. So community can make your project growth 10x, at least 10x. And the contributors. So who are contributors? Contributors are the community members who contribute to code. And this is a very wrong belief that only code contributors are the contributors. That's not true. There are many other things as well. You can contribute to documentation of the project. You can maybe design something for them. You can advocate about the project. You can be a user. Whenever a project is very small, it's very, very important to have users who provide feedback. So the best thing you can do for any small open source project is use it and provide feedback to the team, what's wrong, what's right, and what they should do. So that's the very important thing, and that's the most important contribution you can make for them. You can help other community members to use the project. So maybe some other community member is having some problem in the installation of the project, or they are trying to do something, but that is not happening. You can help in that, and that is also a contribution. So this is who contributors are. And after that, I'll try to tell you what's the point of view of a person who is trying to contribute the first time to any open source project. Either they are beginner to the technology world, or they are seeing your code base for the first time. They are seeing your repository for the first time. And what they will do, they will try to understand the code. They will visit packages. They will open files. They will see what is happening. And they will read documentation, maybe try to figure out what's going on. They will interact with the community, ask few questions, and they will use the product. And then whenever they will start doing this, there is a very good chance they will have a problem. For example, I included a screenshot when a person G forever, whatever, he started using application. He go to a good first issue, he opened it, and he started having a problem. So that's where this is the first blocker that came between your project and an open source contributor. So the very first problem is getting overwhelmed by code. Yes. So you will all relate whenever you want to contribute to an open source project. You will open their repository and find the code base very overwhelming. It is like thousands. If I go to the code base of application itself, there are tens of packages, there are hundreds of files, and there is tens of files in every packages. And I don't know, really don't know which package does what, which file does what. And it can be very difficult from a point of view of a new contributor to figure out this. And this is the very first blocker that comes. It can be an error in installation, it can be figuring out which package does what, it can be adapting different technologies. Maybe the person is using different technology and your project is using different. And it's very, very difficult to figure out what's going on. And that's where you have to introduce good first issues. If you're contributing to the first time, you have to go to good first issues first to start with it. And if you are a maintainer, you have to make sure there are enough good first issues opened at any point of time in your repository that any newbie coming to your repository contribute to your project, they know what's going on. And what a good first issue is, and how I implemented it, is it can be code issues that can be solved in only one file. You don't have to visit multiple files to solve that issue. So, for example, if a newbie visits your code base, they will go to the first file, they will solve that issue, and they will learn what this file is doing and what that package is doing in particular. And then they will pick up next issue, and again the same process will happen. They will understand what this file is doing, what this package is doing, and eventually after 2 or 3 issues, they will start learning more about your project. And this is the gateway that they will get and start contributing to your project and become a more stable contributor for your project. And It can be UI UX issue. It can be documentation issues, bugs in documentation, correction in documentation. It can be small bug fixes, typos, and always making read be better. At least that. So good first issues helps to contribute. And that's the first blocker that you can eliminate by implementing good first issues to a project. For example, if we visit the issues section of application and we go to good first issues, you'll see there are 29 good first issues open this time. So you can go to there and just start solving it. And it will be very easy for you to contribute to open source. After that, second blocker that came is support. So let's assume you picked a good first issue, you started working on it, and there is a Git error, there is an installation error, and you don't know, it's very overwhelming, you are not getting what to do. And if you are a contributor, I'll say start asking to the community, start asking to the maintainers what to do. Even if it is a small error, you can ask, you can always ask and have a solution for that. Don't just think that I don't know anything. It's not like that. You can always ask and learn. And if you are a maintainer, it's very important to be proactive and see if some contributor has picked the issue. So you have to take status updates on that. Either they are working on it or not. Maybe they are having an issue and you don't know they are having an issue, and they are just taking the issue and not working on it. So if you maintain the status update, it will be good for you. And if they are having a problem, you can either take a meet with them, either tell them what's going wrong, or you can always ask your team to do that. So for example, I'm not sure this screenshot is clear or not here, but in the first screenshot, there was a contributor named Harsh Singh. He asked for an issue from me about 3 weeks ago, and after a week or so, he maybe forgot about the issue, and I maintain a status update, and in a day he made a PR, and he's an active contributor now to applications. So that's how you have to be proactive to bring attraction to your project initially. And in the second screenshot, I have shown that there was a guy having a problem, installation problem with the application, and it was not. He was not able to solve this for a week or so, and then he asked us, and I just asked an engineer from my team to have a meet with them, and the issue was solved, and he is also an active contributor now. So you have to maintain status updates regularly to eliminate this blocker as a maintainer. The third last is rewards and recognition. So I always believe that every open source contribution should be celebrated. If someone is investing their time for your project and doing something for you, creating a feature, fixing a bug, maintaining your dogs, or anything, they are giving your time, they are contributing your time. The least you can do is and we provide some swags to them, we post on our social media about them, and this helped us a lot in growing the project contributors. So for example, this is the chart. You can see in a year and a half, we went from 0 to 200 plus just in a year and a half. And this works for us. So yeah, this is all. If you have some questions, You can join our Discord. You can give us a star on GitHub. You can scan this, and I'd love to connect with you and start your open source journey. Thank you.
Thank you, Saurav, for the speech. Now I would like to call upon Goda sir for presenting, sorry, Satya sir for presenting a memento. Clap everyone. Now bringing us with the last act, I would like to call upon Mr. Dollar Dingraji for presenting us with the best practices for continuous integration in Python. Mr. Dollar Dingra.
कहीं भी करनी है
आपकी मर्जी फ्री माइक या पोडियम
ये ठीक है
कोड है वाई मीट लिंक कर दीजिए आप गूगल मीट
लिंक मैं दूँ
नहीं मैं बता
अच्छा
You're supposed to give at 4, right? You are comfortable right now अभी मतलब अभी देने के लिए
मतलब I can give at 4
you
also.
are ready ना
आपके पास लाइक टाइम है आप आराम से कर सकते हैं
ठीक है
YZF hyphen URCD URCD DDD hyphen CDM. Guys, let's welcome him.
Asking to be let in. Asking to be let in. I'm not in the meeting right now. I have asked myself to be let in. Depends upon the audience. So, हाँ मतलब you can pass on the mic. I'll be okay. Now I have to share my screen, right?
Hello everyone. Am I audible? Okay. So, hi everyone. I'm here to speak about best practices for continuous integration in Python. Let me introduce myself first before introducing the topic. I'm Dollar Dhingra and I'm working as Associate Engineering Manager at Tata 1MG. Apart from that, I am very passionate about solving back-end engineering problems, developer experience problems, and Python has always been a passionate experience for me. I have been working with Python from past 8.5 years now, since the starting of my career's journey. So, before starting with this particular topic, I wanted to interact with the audience. I wanted to know more about the audience, what their experience about CI/CD has been till now. So before we start, can anyone tell me what CI/CD is?
Let me bring the mic, yeah.
Automation of doing tests and then building the package and then in some cases even deploying it and then even deploying it to production. Having that full pipeline is CI/CD.
Yeah, correct. So you're definitely right. CI/CD is basically a pipeline which has some automated tasks which help in deploying your application onto production. So let's deep dive into it before we actually create a blueprint, before we actually see how we can create an effective blueprint to have an efficient continuous integration pipeline in Python. So when we talk about CI/CD, there are two parts here. One is CI, which is continuous integration, for which we'll be talking about today. Another is CD. We'll be talking briefly about that, but we'll be touching about that just to know why we are doing CI at the first place. So CI is continuous integration, CD is continuous deployment and continuous delivery. So we have already discussed this. CI is responsible for building your code and running checks or running tests. CD, on the other hand, whatever build was created by the CI, CD is responsible for automating the process of deploying that code or image or artifact, anything you can call, onto production or onto wherever your application needs to be deployed. So in the continuous integration part, we are basically doing two parts here. We are performing some checks which can be linting, formatting, or unit tests, integration tests. So Python is not a compiled language unlike other languages. So we don't have a Python build process here, but we can, if we are working on a Python library, then we may be building a wheel, or if we are working on a backend, we may have a Docker container which we will be building and pushing to the Docker registry. That can be comprised of the build part. If we talk about continuous delivery, let me explain that using a diagram. What exactly continuous delivery and what exactly continuous deployment means. So continuous delivery means that whatever steps that we did in CI, we are pulling. For example, let's take the case of the Docker container that we pushed to Docker registry. In the continuous delivery part, we are pulling that. We are spinning up the container and we are deploying all the code changes. We are running our application basically on production. But this has a manual intervention. So this can be controlled by a push of a button. And if we talk about continuous deployment, so everything is same. We don't have that manual intervention. We are automatically deploying everything that has been passed by the CI and CD. Okay, so let's do a basic litmus test here of how many people are practicing a proper CI in their organization, or if they have an open source project, how many people are practicing a proper CI here. So I have few set of questions, and I want you to raise your hands if the answer to those questions is yes. So this litmus test is a popular litmus test for CI by Martin Flower. Firstly, how many of you practice continuous integration in your organizations or workplace or anywhere?
Please raise your hand, everyone. We expect many people here to practice that.
Okay, I see. Keep your hand raised. It'll take just 2 minutes. So the second criteria is everyone in your team commits and pushes to a shared mail line, which can be a same branch if you are practicing feature branch strategy, or in trunk based you will be having a common mail line. So basically a shared master branch. Like you are creating a feature branch and then merging that into the master branch. So that is same for everyone, right? At the end of the day, you are merging your code into the master, that's shared, right? So how many of you do that? Okay. I think some of the hands are not raised now. In each commit or in each pull request, an automated build is triggered or automated tests are triggered. I see 1, 2, 3, 4, 5, 6, 7, 8, 9 hands, 10. Okay, the last question. When the build fails, it's usually back to green in 10 minutes. Means that you are able to debug and fix that build. So let's say you have raised a pull request and the build which runs with the pull request as soon as you push the commit has failed. But you are able to debug the issue and you are able to fix it within 10 minutes and push it. So when you push it, the build pipeline runs again and it is successfully runs within 10 minutes, or let's say 20 minutes or 30 minutes.
Just a second, please. Whether I do it or not.
No, I'm asking whether you do it or not.
Okay.
Whether your organization or your workplace does it or not. One,
no,
two.
we try to do, but not always, yes.
Okay, that's an honest answer. Yeah, that may not be possible, but let's assume that is possible in most of the cases. Okay, so I think if all of these criteria is met, all of these criteria are met, then I think we are doing a proper continuous integration. Okay, so what can you take away from this talk basically? I could have covered this in the beginning, but I wanted to just set a context. So what is proper continuous integration? We have talked brief about that. Why would you need one? Why do you need one? Why do you care to have that? Lastly, if you care to have that, how can you implement that? If you want to implement a CI pipeline from scratch in your service, or let's say if you already have a CI pipeline and if you want to optimize that pipeline. Okay, so let's cover the why part, and we'll also be covering the what part after we cover the why part. This is very important for the business also. Let me come to that. So we are starting with product here. Every developer, every engineer is working on solving a problem that is related to a product, right? Whatever we are doing, the main goal is to solve the product's problem, right? We are not doing anything for the sake of engineering. Obviously we want to improve engineering, but the main goal is to improve the product, to improve the business. right? So an effective CI pipeline can improve the frequency of your releases, basically improve the frequency of the releases that you do. Every product requires different A/B testings to finally actually launch a product. And they need to do multiple releases to actually make sure that the product they want to launch is correct or not. And it needs a lot of releases. So CI pipeline will actually improve that in the long run. Apart from that, an effective CI pipeline will catch a lot of quality issues at the beginning before going to production. So your product will have a better quality in the long run. Also, the developers will also be able to focus more on the product. They'll be more close to business. So this is very important. In today's time, every organization is focusing on profitability. Everyone is making cost cuttings, and this talk, there can be many takeaways to actually see where can we do some cost cuttings also in the CI pipeline itself. So for developer, there obviously is a better developer experience because the efficiency and the productivity of the developer is increasing. The feedback loop through which they are getting the errors, the readability of the errors, the action that they have to do on the errors, that is clear in an effective CI pipeline. So let's say if I release a feature, let's say I'm working on a login screen and I do a commit, I release a feature, the build fails, the build tells me that this specific test case has failed. I know, okay, this test case exists in my suite, I have to fix it like this. I fix it, in the next commit the build successfully runs, things are working fine. And in another scenario, the debugging may be hard if the CI pipeline is not giving a proper feedback to us. Apart from that, the dev cycle time is also very slow, is also very short. What do we mean by dev cycle time? Does anyone know about that? What dev cycle time is? So dev cycle time is the first commit pushed by the developer to the VCS that they are using till the time that feature goes into the production. So one more set of questions. How many of the developers or product or anyone working in their organization, what is the average dev cycle time here? Is that less than 2 days? If yes, you can raise your hands. In most of the cases, less than 2 days? Only one? Okay, I wanted to go beyond that also, but I think less than 1 day? Okay, so an effective CI pipeline, the goal of effective CI pipeline can also be reducing the dev cycle time so that it can be reduced to less than 2 hours also. Just imagine the productivity that can be achieved using that. QAs, you wouldn't want your QAs to spend a lot of time on doing manual testing, doing a lot of manual interventions, doing a lot of sanity that is redundant, that they do each time whenever a feature is being released. Instead, they should be focusing on improving the overall quality culture at your organization. Lastly, the organization in which the CI/CD pipeline is sorted, the projects are on time, they are less chaotic, infra issues are less, the DevOps team can focus on improving the platform, the developers will have a better development experience, and the organization will be able to give a platform to good talent also. Okay, so let's see what are the success factors for a CI pipeline before we actually get into the details of how to design a effective CI pipeline. The first thing is the individual there was sitting, he said that we basically are automating all the checks that we are doing. So the idea is to automate everything that comes in the way of releasing a feature. That could be, things that you do in the code review. That could be doing QS doing manual sanity. Everything that can be automated should be automated, and that can be put in the CI pipeline. Shorter feedback loop. So we want to, we don't want developers to, do a lot of task switching. We want them to, get the feedback on their builds as soon as possible, so that when they start with the new feature, they shouldn't come back to the previous feature and start solving the bugs for that. That really hurts the productivity for the developers. We also want that whatever errors that we are showing them in the pipeline should be clear. They should be actionable, so that timely action can be taken. Okay, so another success factor for CI pipeline is, we already discussed quick and frequent releases in an iterative fashion. So the idea is that, let's say if I am integrating my changes and the build failed, so everyone knows that this was due to my commit, right? But in the either case, if we are creating a merge commit, if we are not merging a commit in 2 days, 3 days, 4 days, that becomes stale. So eventually there is a release manager, or there is a person who has to do a lot of activity that could last for 1 day and sort out all these things, and imagine what happens if that build fails, that deployment fails. It is very difficult to debug. So the idea here is quick and frequent releases. After each release, just run the pipeline. For big features, in the trunk-based development, feature flags are used. For the feature branch development also, similar concept can be used while you are starting with your development. So the ultimate goal for CI is to be CD ready. Everyone knows now what the CD ready is. CD means we are deploying the application, and the application is basically in a form which can be deployed instantly. There is no check needed, and we are confident that the deployment will not fail. Okay, so the ultimate goal for the CI is that. Okay, so there are a lot of Python tools used in the CI pipeline. I'll not go deep into those tools because that would be a separate talk and that will take a lot of time. I'll be just listing those down if someone wants to test those in their CI pipelines if they have in their organizations. The category for those is formatters, linters, type checkers, coverage checkers, documentation tools, and security tools. So formatters are basically what? They automatically format your code. You just have to run a command and they format your code as per a style guide or whatever best practices the language offers. Every language has some formatters. The popular ones in Python are Black and YAPF. YAPF is by Google, which basically follows Google style guide. Black has become very popular in the past 2 to 3 years. So major companies like Netflix, 1MG, a lot of companies are using Black with iSort. iSort is basically used to sort the imports. So it has to be used with Black. I'll not go into the details of how the sorting is happening, but one thing I want to point out is that you can just keep this in your pipeline so that your code reviews can be focused onto things like how the requirements are being implemented, if the requirements were missed or not, if the low-level architecture or the low-level design of the code is correct or not, instead of debating on the code review that the format of the code this should be like this or this. So this ends the argument for all the developers that this is the standard which we will be following to keep the code base consistent across the service or even across the organization also. And Black is a standard tool in the Python ecosystem. Important thing to note here is that Black, if you use any formatter, it directly makes changes on your code base. So in your pipeline, you'll be using it like this. You'll be appending a check command. So check command will actually return an error if the black can run on your code base, if you haven't run that previously. Okay, so there are linters, pylint, flake8. So these are basically used to do some cyclomatic complexity checks on your code or static code analysis on your code. Won't go detail into this also. There are type checking tools. So basically Python is a dynamically typed language, and unlike Java, we do not have any type checks. But having a type checks may be a good practice, especially in the applications where there is a lot of complex code. So you would want to use one of these tools. There are a lot of code bases in which documentation is automatically generated, or documentation checks are there. You can use those tools for this. Security is one of the most important aspects of software engineering, especially if you are working on a domain in which security is preferred, like a healthcare domain. So you would want some safety in the coding ecosystem that can come automatically. You just have to integrate these tools and done. There is one level of security that is handled automatically on every commit that you are doing. Okay, so now is the core part. We'll cover the scenarios for crafting an effective pipeline. We'll be covering the first part, in which we'll be designing a CI pipeline from scratch for an existing service. So let's say for that existing service, the CI pipeline is not there, and let's assume that the tests are also not there. So the first thing is, the prerequisite for any CI pipeline is unit tests. So I think if you are not writing tests in software engineering, in 99% of the cases you are doing a crime with your organization. So writing tests is the most critical part that you can, the most hygienic part that you can do with your code base. And if you are not doing that, then what you can do is you can start writing the test cases and go on increasing the coverage week by week or sprint by sprint basis. Let's say if you have current coverage is 10%, then you can set a threshold in your continuous integration pipeline such that if the test coverage falls below 10%, the CI pipeline will fail. And week by week, you can keep on increasing the test coverage. Idle test coverage in most of the cases is 90%. That is pretty decent. Don't aim for 100%. That is, that is not feasible in most of the cases. So there is a coverage Python library and a PyTestConf tool which can help you in calculating the coverage, and also help you can integrate these tools in your CI pipeline to calculate coverage and set thresholds. The second step would be integrating code quality tools. You can start with a formatter, black formatter or an isort. Both can have a single commit. So the first commit that you will be doing in your repository will be a very big commit. And let's say if a person is doing that commit, and let's say if another person is debugging an issue after 2 or 3 months, and they are going into that specific code which was changed by the formatter, then it will be a misleading for that specific developer. So it's very important to highlight in the code base, in the code commit, that this is a formatter code. This should be done continuously when you are creating the app, but if it is not done, then this I think is the correct way. Apart from that, after formatters, you can then integrate linters one by one. Okay. After that, you can use your default VCS. By VCS, I mean if you are using GitHub, Bitbucket, or GitLab, all of them provide a decent CI/CD pipelines. You can start using those pipelines, and you can use a bare-bone pipeline structure. On every PR, your CI pipeline should be run, and if any step fails, just block the PR. That's the basic bare-bone CI pipeline that you should be running at any cost. in every library or in any service. And the last thing is keep optimizing, keep visiting back to your CI pipeline and keep optimizing, keep increasing the threshold so that your pipeline can become efficient. Now let's come to the core part, how to optimize an existing pipeline. So before starting to think how to optimize an existing pipeline, you need to make sure that you are aware about all the metrics that your CI/CD pipeline is currently offering. So it's very difficult. It's very important to measure that. There are a lot of metrics. I have tried to cover some important metrics in this talk. I'll go through some of them. One of the very important metrics is the total build time. We previously talked about the duration of the build. The duration of the CI pipeline should be short. So the build time is something that you should be keeping your eye on. Maybe you can have a dashboard and you can see how your build time is increasing with the increasing code base. Try to keep the build time as low as possible. The CI pipeline should have a build time less than 10 minutes in an ideal state in most of the cases. Feedback time is time from code check-in to receiving the first feedback. So the first feedback will be, let's say if you are running the first step, let's say the first step is the black formatter check or the unit test case check. So as soon as you get a feedback, let's say the step ran successfully or it didn't run successfully, that's the time, feedback time. Ideally this also should be slow. The test pass rate, this is very important. Percentage of successful test in continuous integration for a particular service. If a service does not has a low test pass rate, then it means that the complexity of the code is high. The tests that are written in the code are difficult to maintain. For every feature, if one is writing tests and the tests are breaking, that actually tells that either the code base is complex or the ideology to written for the tests is maybe complex or not correct. The test duration is one more thing. So if we talk about the build time, the maximum time which is taken by the build time is the test duration. So tests amount for the majority of the time, and this is also the area in which you should be focusing on to reduce it, shrink it. Queue length is something, let me explain it. Okay, so there will be multiple pipelines running for multiple users, let's say on a single cloud server. So depending upon the resource utilization that you have, the complexity of the service that you have, the number of developers who are contributing, who are basically triggering your CI pipeline. On the basis of that, you will be able to take decisions like what hardware and software you should be using on the CI pipeline. So that's what you can use the queue length for. There are other metrics also. In the interest of time, I'll not cover all of them. The one that I wanted to cover is code churn and error classification. Code churn is frequency of the code changes done in the repository. So if the frequency is more, then the pipeline will be triggered more, and eventually you'll be optimizing that CI pipeline tactically as per the code churn. A CI pipeline with a less code churn, you wouldn't mind spending a lot of time optimizing it because it runs very less. Error classification is something very important that happens in the most advanced stages of the CI pipeline, when the CI pipeline has been running from a long time and you are getting a lot of errors. So you can start categorizing those errors and see what are the categories of the errors that you are facing frequently, and you can try to work on those and reduce those. So the step 2 is The step 2 is optimizing. Now actual optimization comes. We have already talked about correct resource allocation. So it depends upon the nature of your application also. If it is IO based application or a CPU based application, you will be doing the resource allocation accordingly. We already talked about complexity of the text and tests and the daily contributors and contributions. You would opt for self-hosted runners also. All the mature CI servers give access to self-hosted runners. So in that, your CI pipeline will be running on your own server and not on the CI cloud server. There can be a lot of advantages that you can get from that. You can have a better control on what hardware and software you want to use. You can implement auto scaling to actually take full use of your resources. You can save a lot of costs also if there are a lot of tests which can run. If you have a security and compliance problems also, then it will be beneficial for you to run your CI pipeline in your own server rather than cloud server. Another important thing is parallel executions. You can basically parallelize your tests and parallelize your CI steps. So you can parallelize your linting, formatting and tests in a single go, so that they can run parallelly, not concurrently, parallelly. Okay, you can leverage caching also. You can cache Python management dependencies. You can cache the Docker dependencies. You can cache the DB creation in the database and all. One of the most important thing that you have to work on is the pipeline feedback. So as we spoke earlier, in order to have a better developer efficiency, the resolution that they are aiming for should be as quick as possible. They should have the feedback that they are getting should have a better actionability, and that will happen if we have a proper logging system, or we basically have we can also basically have real-time alerts. If a build fails, then we can send the alerts to the concerned stakeholders. We would also want to have a CI pipeline which can give us errors which we can replicate easily on our local machine, so that the error debugging, the error fixing can happen as quickly as possible. Okay, the major part of CI pipeline is running tests, right? So there is a lot to talk about tests. I won't go into detail of writing how to basically optimize tests, but I will cover a couple of things. You can arrange your tests in such a way so that the tests which run quicker can run first, and the tests which take a lot of time can run afterwards, so that if the test which would be running quicker, if it is failing, then you basically will save a lot of time in your CI pipeline. That's the fail fast approach. You can adjust this approach on the basis of the nature of your tests. You can parallelize tests. They should be running in the, you should have isolated tests for actually parallelizing the tests. So unit tests by fundamental are isolated tests. PyTest EggDist is a PyTest plugin which is used to run unit tests in parallel. Practice test-driven development for better efficiency. Basically, we are talking about continuous testing here. There are a lot of other tools also which you can use to help in continuous testing. Continuous testing means that you are releasing a feature with the test cases, not without the test cases. You are not compromising on the coverage of the test cases. So the last part I wanted to cover is you can also identify flaky tests in your CI pipeline. There can be dedicated tools to do that, but just to define what flaky tests is, let's say a test runs on my local environment but fails on your local environment or fails on the CI pipeline. So the credibility of the tests is not good, and we should fix that in the CI pipeline, because that is giving a wrong signal to the CI pipeline and to everyone involved with the CI pipeline. Lastly, we have to maintain and keep optimizing the CI pipeline. We need to regularly profile and monitor the pipeline so that we can improve the performance for it. We can I've already discussed this, that we need to mirror the CA pipeline on local so that we can reproduce the errors as quickly as possible. We should also avoid unnecessary steps, and we should avoid bulking up the CA pipeline, which actually will not give us the benefit, which may also increase the cost for that. Lastly, I want to conclude this talk with a couple of thoughts that I have. So now I have covered 4 categories to optimize the continuous integration. Working on the quality means the larger the number of tests you have, the more the quality you have. Second is speed, the duration of the CI pipeline that is running. Third is actionability. Whenever a CI pipeline fails, how quickly you can fix that and make that green. Lastly, cost. That's the most important one. So all of these 4 cannot be done on an equal weight. You'll have to start working on 1 or 2 or 3, and you'll have to basically do a trade-off on 3rd or 4th. So that's what I wanted to conclude at the end. If you aim for all the 4 in the beginning itself, you will not be able to design an efficient pipeline. In order to design an efficient pipeline, you will have to identify the engineering culture and engineering values of your team, the nature of the services that you have, the team that you have, the maturity of the team that you have. On the basis of that, you can decide on what factors out of these 4 you can start working on, and then probably scale all these factors without actually scaling up the cost. You will have to keep the cost as low as possible so that you can be profitable. Thank you so much. Any questions?
Any questions? Okay. Thank you, Dollar, for the amazing session. You really explained CI/CD in very detail.
Thank you so much. In case anyone wants to discuss this or has any questions, please connect with me on LinkedIn or Twitter. That's my LinkedIn and Twitter handles. Thank you.
I would like Gora sir to please give him the memento. Okay, so ever wondered how research paper works, how the papers are written, how research helps in your career, your CV, or how research happens, how new things are innovated? So please welcome Arushi Garg. She is a current intern at Adobe, a product, Amazon Club captain, a mentor at GSS OC, and also an enthusiast of AI and ML. She is here to tell you about how research works and how research papers are written. Over to you, Ayushi.
Hi, I hope I'm audible. So finally, after 2 long days, So before that, I would like to introduce myself. I'm Arushi, currently pursuing my BTech. I'm in final year and I have a huge interest in machine learning and deep learning. I have been working in this field for the last 3 years now. And I have written and published several research papers in conferences such as IEEE and Springer. So this will be the agenda for today's talk. We'll start with research and research papers. Then we'll move to what you need to before writing a paper, the structure of a paper, moving on to tips for writing a paper, what conferences are, and then finally ending with presenting paper at a conference and dealing with plagiarism. So what exactly is research and research paper? So research is defined as intensive search with the purpose of becoming certain. Like we research and study in certain domain to find something, to know more about something, and to dive deep into it. A research paper is taking and combining the information that you have found by doing your research, adding on your own ideas to prove a certain thesis statement. Then coming on to why is paper writing so important? So when you write a paper, when you research about it, when you dive deep into some certain topic, so you understand the real meaning, what exactly the researchers and the people have already done, the previous work done in that field, etc. So it helps you to enhance your knowledge in that particular subject. And also it can help you to gain more knowledge to succeed in your career. Also, one more important thing is that it helps to enhance your written communication skills. Written communication skill is very important. Like, okay, so I have done work in machine learning, deep learning, so I'll be taking references from there itself. So I implemented a model, I implemented a project, use certain data set, and made a model. So now I have made the model, I have implemented something, and now when I'll write about it, I'll be able to make other people understand what exactly I have implemented and how I have implemented. So it will definitely enhance my written communication skills. Then starting with what you need before writing a paper. So you should have a clear understanding of the topic that you have chosen. It should be relevant, it should be prevalent in today's world, and should majorly provide a benefit to the society. Then you should go through reliable and credible resources, because you will be referring to them, you will be mentioning them in your research paper. Then your overall thesis should be important and should add on to something. It should have certain novelty. And finally, a well-structured outline, and you should read and you should go through the guidelines of the conference or the journal you are targeting to. Then finally, select the topic of your paper. It should be relevant, and you should find a topic that is relevant to the assignment as in the conference or the journal you are targeting to, and contain enough information for you to research and build a strong discussion around it. You know, take a topic in which people have already worked in, so that you can work more and add novelty, and you can, prove the previous thesis pretty wrong and add yours. Then conduct your research. You should, like conducting the research, working around it should be the most important task while writing a paper. Review your work, review your resources. Try to find resources that are credible and contains plenty of useful information on your topic. And so conduct your research, understand your problem statement thoroughly. Moving on to the structure of a research paper. So these are the sections which are the part of the research paper, starting with the abstract, introduction, literature review, methodology, result followed by discussion, and finally the conclusion and the reference. References here refers to the bibliography. So let's discuss about each and every section in detail. So the first section is the abstract. So abstract is the first section, and it is very important for you to grab the interest of the readers in this section. Okay, so let's say that I have a research paper that is published in a conference by IEEE, and now they have my paper on their website. You search about the topic and you find my paper. So what you'll find is the topic of the paper and the abstract. You have to go through the abstract and decide whether you want to buy that paper or not, because these conference papers are worth some dollars. So you have to read the abstract and decide whether you are ready to pay those dollars or not. So the abstract should contain, let's say we have a 10-line abstract, so it should contain 2-line introduction, then 2 lines of methodology, 2 lines of results, 2 lines of conclusion, and so on. So it is very important to have a very catchy abstract and abstract should be a pretty small summary of your research paper. Then next is the introduction. Introduction is the section wherein you will be introducing your topic, you will be telling about the problem statement, the background story, that why you have taken this topic, how it is socially impacting to the people. Like I was working in the research wherein I was generating a model to classify the pulmonary nodules into cancerous and non-cancerous. So lung cancer is a deadly disease which has led to the death of many people. So, and also cancer is something that we are not able to detect in the initial stages. So it is very important to detect cancer in initial stages so as to increase the chances of the survival. And hence that's why we chose this topic and we researched about it. And followed by you have to write certain investigations, summarize the discussions that has already been done, identify the unresolved issues, and then provide your overview of the research. You can also add a very small introduction about the algorithms or about the tech stack that you have used. And also it is very important to write about the contributions, about your contributions. Why is your research novel? Why is your research paper novel? Then next is the literature review. So in literature review, you will be referring to the previous work that has already been done by the previous researchers and previous authors. So you have to provide an overview of the current knowledge, and you have to identify relevant theories, methods, and gaps in the existing research that you can later apply to your paper, to your thesis. Moving on to the methodology. So methodology is a very...
Not working.
I guess. So sorry, there was some network issue from our end. So we have already discussed about the literature review, and we were on the methodology. So it is one of the most important section of the research paper, wherein you will be actually telling about what you have implemented, and you will be telling about your workflow, your pipeline, etc. Also, it is very beneficial, and it is expected from you that you do add your architecture as well. Let's say you have used a deep learning algorithm, let's say convolutional neural network, and then you have used the transfer learning algorithm such as ResNet or UNet, etc. So it's good if you do add the architecture of the CNN plus ResNet, etc. Right? And also, the thumb rule is that the method section should be very sufficient and should be very detailed, such that any other person who is reading your research paper is being able to implement what you have implemented, right? It is, the person is able to duplicate your research. Then moving on to the result, what you have observed, what you have found during your research. This includes the research. This includes the observation table, all the observations, the accuracies, the total loss, etc. So you have to do multiple experiments, and you have to mention the various observations that you have taken from your research. Moving to the discussion, herein you can compare your work with the previous work. Herein you can tell how your work is better than the previous work and how better accuracy your model is being able to achieve. Then comes the references. All the papers that you have mentioned in your research paper, you have to refer to them in the bibliography or in the references. You have to mention the name of the author, the names, dates, etc. So when you go to Google Scholar, so there's an option of cite. So there you have to select the APAC format to refer to the research paper. Also the conclusion. Herein, you have to conclude your entire research. You have to restate your topic, restate why it is very important, restate your thesis. Also, mention your conclusion in short, mention your observations, address opposing viewpoints, as in why the readers should align with your position, and include a call for action, as in the future work, the shortcomings of your research, the shortcomings of your project. Then once you are completed with the first draft of your research paper, the next work is edit and revise. You should go through your research paper again and again. There could be certain grammatical errors and etc. which the grammatical errors are very basic, but you should, go through the paper. You should reread it, proofread it. And you can also ask some of your professors or someone who have already written research paper, because in research paper it is very important to focus on the language. The language should not be casual, the language should not be informal at all. It should be very scientific, it should be very formal, it should contain all the scientific terms. And yeah, we should, just double check the paper before submitting it to any conference, because these are certain things that the conference people, the reviewers who check your paper do take in notice. And also, here comes the tips for writing a paper. Ask for an instructor, ask for someone who is currently researching about the topic, or ask for someone who has already written research papers. Why is it not working? So here are certain tips for writing a paper. Ask for your instructor for input or clarification, then skim through the resources for important information. Let's say we are writing a IEEE paper. So IEEE has a guideline wherein only 4 to 6 pages are allowed. So you have to get the information, you have to summarize the information in such a way that you are able to write it in 4 to 6 pages. And there are other conferences as well, such as Springer, wherein they do allow pages up to 20 as well. The minimum pages required is 12, and the maximum is, I guess, 20 or 24. But yeah, for IEEE, when you are writing very small papers, so you can aim for IEEE conferences as well, because they only require 4 to 6 pages. And keep your paper relevant. It should, the information written in your research paper should not, diverge from the main topic, and it should not diverge the readers from the main topic. And please do review the guidelines before submitting your research paper. So now talking about what exactly is a conference. Conference is a place wherein you will be presenting your paper, and the researchers submit their paper to a conference according to a specific guideline and timeline specified by a particular conference. Every conference, these conferences are pretty annual, and they release about their conference about 6 to 10 months before, wherein you have 2 to 3 months when you can submit your paper. Then they review their paper, then they review your paper, and send the acceptance mail after 2 or 2.5 months. And in the acceptance mail, if it is 100% great, so they do accept it. Also, there are certain times wherein they do accept the paper, but they do send certain improvements. Like if, let's say, if the plagiarism is 11 or 12%, so they do ask you to reduce the plagiarism to 10% before publishing the paper, before they process the paper ahead. Also, there can be certain grammatical mistake or the formatting errors that they do point out, or sometimes they do mention that, sorry, your research is not very relevant, or it is not up to the mark, it is not adding to any novelty. So they might even discard your paper in that case. While presenting in the conference, so the slot is generally for 10 to 15 minutes. You won't have time to convey lengthy background information, so it shouldn't give a scientific literature review. Instead, you have to present your own ideas, you have to present your topic, and then your observation, the conclusions. What exactly you have done, the methodology is also important there. Here are certain tips while presenting your paper at a conference. You have to start by stating the purpose, tell the audience why your work is very important, then provide a very brief literature review, or you can even skip to it. Then you have to move on to the main points of your own research, and you have to conclude by reiterating the importance of your research, emphasizing the key points, and also do mention the future work. Then while presenting a research paper at a conference, you are expected to share certain slides as well. So it is great, it would be great if you'd use more graphics, and no one would be sitting and reading your entire research paper. No, they'll be only looking to your slides, they'll be only looking to your presentation. So add more bullet points and add more graphs, add more tables instead of writing the complete sentences. And yeah, so do practice it. And also there can be times when they cross question you or ask certain questions regarding your research or any future work, so you should be well versed with your research paper. And finally, talking about the plagiarism, because 10% is the maximum plagiarism you can have in your research paper. So what exactly is plagiarism? Herein you will be, in plagiarism you borrow pieces of text that is already been published by any other author and published text and you add that in your paper. इसकी नहीं है, हो गया बस last slide है, so I can continue, right? ठीक है. So there are certain ways in which you can avoid plagiarism. First is take ample amount of time for writing and revision. Use quotation marks whenever you are writing text from somewhere else or already published text, and please do mention the paper from where you have taken the text from. Paraphrase the original text and do cite the resources. Read widely on many topics. Even if you want to mention certain work from other authors or from other papers, please do paraphrase it and write it in your words, in your language, and add your own ideas. And please do conduct a plagiarism check on your manuscript. There are certain softwares with the help of which you can check the plagiarism. And record the bibliographic details, as in all the references of the research paper, of the sources very accurately. So yeah, that was all from my end. I'm open to any questions that you want to ask or anything you want to ask regarding research papers.
Hi. So could you name those softwares maybe that you use to check for plagiarism?
Sorry?
Could you name some of the programs you use to check for plagiarism?
Okay. Actually, I don't remember it right now, but
That's fine. I'll just post it on Twitter, Okay, thank you.
Is there any acceptable number of pages that you should have in your research paper?
It depends completely on the conference. Like again, as I mentioned, for IEEE, 4 pages is the minimum and 6 is the maximum. And for Springer, I guess 12 is minimum, 24 is maximum, and that's again different for all the conferences. So like if you have smaller content, so you should aim to papers like IEEE, and if you have more content, so you can aim to other conferences. And also there are journals as well, where they accept papers for 50, 60 pages as well.
Do these papers, is there any requirement that you should have some practical experience also into that, or only theoretical understanding or references are enough?
Okay, so it depends on the paper. There can be an implementation paper wherein you have implemented something, you have implemented a model, a project, and you have written about it. The other can be a review paper wherein you have reviewed the work done by the previous researchers and you have compared it and found something, but that's completely theoretical.
Okay, thank you.
Hi.
Hi.
So I wanted to ask a question that recently generative AI has been taking up much space in this. And we have heard in the news that academic authors are also using generative AI to write academic journals. So are there any ethical ramifications for that? I mean, what's your point with this? What's your stand on this? Should we use it or not, in a sense?
Okay, so people have contacted me saying that okay, we have 10 research papers. What is the need of reading the research paper? We can just send it to ChatGPT or any other software and get a short summary of that. So when you do read a research paper, firstly you understand how to write a research paper. What is the language that you should use? The scientific terms that you should use. When you get a summary, these all things get messed up. So it's great if you do read the research paper, because there are certain things that might not be very important for that AI software or the AI tool, but that will be very important for you as a researcher. Because when you research about the things, small things are also very important. So this is about reading the research paper and then writing the research paper. People do this, that they just take the text from other research paper and send it to a tool that may paraphrase it and you can add it, but there are systems that do check that as well.
So it's like reading a novel basically. If you read a novel and compare it to its summary, you lose some context there, right? So yeah.
Hi. Actually, you mentioned both journals and conferences where you can present your paper. Like you mentioned IEEE, where like there is a minimum number of pages, like 4 to 6, and like in journals. So like, is there the only difference between submitting your paper to a journal and to a conference, the number of pages or the presentation you do, or like is there any more like discrete difference between them?
No, like journals are more extensive in that you have to present a very extensive research. Like in conference, you can implement a model, research about it a little bit, and you can present your paper. But journals are more, okay. So when we compare the two, a conference is like a chapter, journal is like a book. So here you can relate. This is a parallel I can draw.
Does anyone have any other question? Okay. That's it, I guess. Thank you, Arushi.
Thank you.
We'll now give Arushi the memento. So, Satya, please, can you on the stage? Do I ask good? Okay. Do you want to felicitate Gora? Do you want to say something on the mic? Gora, where are you going? Just wait for 5 minutes. We are felicitating.
Achha, I thought we were. Yes, but closing ceremony के लिए time.
हाँ हो गया. We are done with the talks.
नहीं, but we are going to do a formal closing ceremony.
I think I'll have this. So first we'll do your felicitation and then we can. No, felicitation first. अरे बाप रे बाप क्या felicitation. So Gora, can you please come on the stage? So Delhi University would like to felicitate Mr. Satyakam Goswami and Mr. Gora Mohanty as the pillars of the Python community in Delhi. Okay. Please can we have a round of applause for them? Do you need this one, Alan? Closing. Mic is on.
So again, it's my turn to speak up. So yeah, we are all sad. Like now, we will be leaving, and from the emotional high of 2 days of wonderful event, where I don't know how many people watched online also, right? It was just, that was a last minute thing which we added up, the live streaming one. Then we had wonderful conversations which I saw happening. Also, I saw very happy sponsors, I would like to thank them, the sponsors, without which event like this is not possible. And also lots of volunteers, apart from the active ones, there are a lot of people who were passively working from behind the scene. People like Gora and Akshay, they were burning the midnight oil and, chasing the speakers and skimming through so many, conference proposals, and they have done a good job. One big round of applause for all the volunteers. Special thanks to DU, Seema ma'am. Seema ma'am was really one of the person with whom we really gelled well. I'm working with her for the first time. Hopefully it will not be the last time. She is already excited for having PyCon India next year here, and she is saying, let's do it. I said, okay, let me take a breather, because this PyCon is still not over, right? Yeah? So September, October, everyone listen, whomsoever does not know that. I think this is a good time to talk about it. PyCon India is one of the largest international events, at the India level. It will be. Yeah, Anurad, you're saying so? Yeah? You want like this? Okay. Then you will hear my other voice then, you'll not recognize my voice. Okay. So the PyCon India one event is a bigger one. It is 3 or 4 times bigger than this one. There is going to be a 5-day event. Hyderabad. People who can make it, do come. It's a wonderful opportunity. People here, a lot of them have attended multiple times actually, and they keep on going there, not now to get gyan and all, but to meet friends now. That kind of friendship and bonding has developed over the years. We have been running this event for last 14 years now. Yeah, 14 years. Yeah, 2018 was the 10th year. So I've been there from the day one, and okay, we started small, but very soon I know it has to have some structure, and it has developed into something which we are very proud of. It has built up as a brand. So don't forget to attend this event, whomsoever, talk about it. Especially students, they feel ki, how am I going to stay and all that. तरीके निकल जाते हैं, just ask your friends, people are there here, people like Anubrad and all that. They stay together, right, in a big bungalow and all. So we can share all that. So talk to people, ask for it, Without asking, you will not get it, Do ask around. Okay? So that's about PyCon India. And yeah, closing remarks, it's been wonderful. I'm very happy. We were able to pull it in within 3 months, Gora sir? 3-4 months, yeah. And it all started with one small conversation, saying that let's make it happen after especially the COVID. Physically, we haven't been meeting. So this was wonderful meeting everyone. Thank you everyone whomsoever brought the ticket, because that's the only way to control, the real serious people from, just the crowd. We don't want the crowds, because quality is very, very important. I hope you got all the worth of knowledge, whatever interactions you wanted. So yeah, over and out for next year. And not next year, first is PyCon India. And then maybe next year PyCon, hopefully, if we are there and we get the venue. And there is a lot of logistics which happen. The catering guy, the videography guys, they have been, very, very, helpful. And do join this, because I heard a lot of voices saying that Telegram is not good, this and all that. So I generally take help of people, young people like Daksh and all. I listen to their advices because they are more social media savvy than me. So I'll go by their word and said, let's create a WhatsApp group which will create more traction, because most of the people are on WhatsApp. That's what they said. I said, okay, let's do it. Because at the end of the day, we have been there on the mailing list forever, right? Gora and me, we remember on IRCs, then all the social medias of this world. And first was mailing list, then IRC, then came so many other things, right? But what's the most important thing is the spirit of being together as a community, learning and helping each other out and moving forward, looking forward and moving forward, whatever it can be, don't. So that's what it is all about, why we do this kind of events and make it happen. And thanks again, DU, sponsors, all the volunteers whose name I couldn't take. I know there are a lot of new faces I saw this time. And do stay connected, okay? Because there are a lot of these connections which can make things happen. Even having the knowledge will not help. Okay, thank you. With that note,
I request everyone to please come on the stage. We'll take a group photo.